Hello and welcome to day 2 of .NET Conf. Obviously we could not afford Scott Hanselman for 2 days. So you got me and...
Hello everyone, my name is Mika Dumont. I'm super excited to be here.
And I am Seth Juarez. We got tons of exciting things today. A ton of sessions. Mika, can you give us a little taste?
Yeah, let me get out my list here. We have Visual Studio for Mac Reborn, as well as some future of Blazor, some F#, new things in F#, tips and tricks on moving to .NET Core, and much, much more.
Fantastic. So make sure you get your questions in while you're watching, because if you ask your questions after we leave, then we can't ask them. So get them all on the board. We want to get all of your questions in, but also, we also have a technical treasure hunt. And I'm going to read this because Beth Massey probably wrote this. By the way, you need to follow her on Twitter. She is almost to 10,000 followers on Twitter. And if she gets there, she owes me like $50. And Mika, she's going to give me like 80. I don't know how to work this out.
Yeah, I think we're going to split it maybe.
Right,
yeah.
So she gets 80, I get 50. Do you like solving hard technical problems and winning cool prizes? I know you do and I do.
Yeah, I definitely do.
You're going to want to watch all of .NET Conf 2019 because .NET Partners are sponsoring a technical treasure hunt. There will be fun challenges to solve and you'll be eligible to win prizes. Just go to .NET Conf /partay, but spelled party. So what is the session we got coming up right now?
Yeah, so right now we have Visual Studio for Mac Reborn, new editors and new experiences with Cody Bayer. So Cody, take it away.
Hello and good morning, good evening, wherever you are today, and thank you so much for joining me here. My name is Cody Bayer, Senior Program Manager on the Visual Studio for Mac team here at Microsoft. Today, we're going to be talking about what's new in Visual Studio for Mac, from new editors and new experiences, and all the other great goodies that we have in Visual Studio 2019 for Mac. So, without further ado, let's get started. So 8.3, that's the version of Visual Studio for Mac that we just released yesterday. It is the biggest release of VS for Mac that we've ever had. It's filled with all bunch of great new features from new web editors, multi-targeting support, of course .NET Core 3 and C# 8 support, as well as smaller updates like pinning documents, improved quick fixes, and source link. By introducing all these new features, we're hoping to really improve the overall developer experience within Visual Studio for Mac. Not just one thing, not just another thing, but the overall end-to-end experience. We have updates in each of those, and we'll get to those in a moment. Of course, this is built upon the solid foundation of Visual Studio 2019 for Mac. That includes updates such as the new C# editor and the new XAML editors, improved Git reliability, updated templates, published your folder, and all sorts of other improvements as well. So not only does 8.3 represent a major step forward in web development and in .NET Core development on VS for Mac, but it's built on top of this great release with new editors, new native editors. We can get right into those because I can't wait to show you all the neat stuff that they include. But first, I want to thank you to our preview users. None of this would have been possible without the folks who hopped onto the preview channel, tried out these new features, and gave us feedback. It's invaluable to us, and we could not do it without you. So thank you very, very much for trying out these new features and giving us that feedback to get us to where we are today. All right, so new editor, new backend. Let's talk about what makes up this new editor, why we have a new editor, and what we can do with it. So I like to think of .NET as the most powerful cross-platform toolkit there is. And if you look at what .NET does and what we can do with .NET, nothing to me demonstrates this more than the new editor for VS for Mac. So if you think about what a quintessential Windows application is, the Visual Studio editor on Windows fits that bill. It's WPF, it's been on Windows forever, it's fast, it's stable, and it's also based on .NET. So when we looked at what we needed for a new editor in Visual Studio for Mac, we looked no further than Visual Studio on Windows. And because it's based on .NET, because it's this cross-platform toolkit beneath it, we were able to port a vast majority of that over to Mac OS. The only portions we didn't take with us was the UI layer. On Windows, that's WPF. On Mac, that's Cocoa and Cortex. So we were able to take all the high-level editor features, IntelliSense, all the quick fixes, Roslyn and the language services, all of the little tools that tell where the text where to go, all of these things were shared between VS for Mac and VS Windows. That is the power of .NET, and that is how we were able to take the quintessential Windows application and move it to Mac OS. So let's take a look at it. Let's see how it looks in the real world. So I have a cat. This is Buttons right here. He is my cat. I went to my vet, and I was told that he needed to go on a little bit of a diet. So I needed to start tracking my calories for my cat. And this is something that is kind of hard because if you have cats, you know they don't take well to being told, how much they can eat. So I wanted to make an app to remind me of this. And I thought, what a perfect opportunity to do this, to try out the new web editors, to see how I can make an ASP.NET Core app with tracking my cat's feeding. So in this application, super basic, I wanted to use ASP.NET Core 3 with an MVC pattern utilizing Razor pages. And I wanted to mark which days exceeded the kcal limits, as well as allowing for multiple cats, because I do have more than one cat, and I don't want to get them confused. Feed all one, not feed the other. That'd be a disaster. And finally, I want to clearly demarcate by day so I don't, again, give all my cats food 1 week and 1 day. That'd be terrible as well. So let's take a look at what we did. Hopping on over to VS for Mac, I'm going to launch the Fitty Kitty demo. And I immediately see there's a to-do here. I need to fill in this class. So what am I going to do? Well, first I know that I need a DB context here, because this is the meal context class. So by typing in oh shoot, I don't remember the library and the namespace which DB context comes from, and that's rather embarrassing. But with Visual Studio for Mac, I am given a beautiful new tool that helps me figure this out. So we're hopping to Preferences and selecting IntelliSense, Show Import Items. I'm able to enable this new feature that lists which import items are available to be imported into my project based on what I'm typing in IntelliSense. So let's see that in action, and hopefully that will make some more sense. By typing in DB context, now I have all of these different completions available to me. And you'll see to the right, I have the namespace for which those completions belong. So DB context, which is what I need to import into my project, comes from Microsoft Entity Framework Core. So all I need to do is arrow down to DB context in my editor, hit Tab, and not only does it complete DB context, it also adds the using into my application. This is a huge time saver and really speeds up the amount of time it takes for you to remember all these different imports. I forget them all the time, so it saves me a lot of time, and I hope it saves you a lot of time too. All right, now another great time saver that I've found to be super useful in this IDE is the concept of snippets. So snippets represent any amount of code that you may use many times. So in this case, I need to type in all the methods and mechanisms for the DB context here. And I don't necessarily, again, remember the exact everything about it. And because I want to impress my friends, I'm going to go ahead and use a snippet that allows me to see and enter the code with just a few characters. So previously, I created a snippet for creating the DB context information. So to do this, I'm going to type in DB CTX. You can see right here that not only is there a snippet here, it has a snippet icon of the ellipses there. So, and as the IntelliSense says, if I tab twice, it's going to insert the DB context snippet. So we'll go ahead and hit Tab, Tab, and there we go. Now I have all of the code I need for the DB context method, and I can type it in here. So as you can see, there's two sections within this code that say not set. Those are variables that I set within the snippet that allow me to, as I'm filling out the snippet, type in the code. So let's see. I know this needs to be named meal context. So I type in meal context, and you can see not only does it fill in the first variable, but also fills in the second, because they're both marked with the same placeholder. I'll show you what that looks like in the snippet editor. So you go to Preferences, navigate to Code Snippets. You can see that DB CTX is the first one on the list. That is the one that I created. And as you can see, I have public, $name, that represents a placeholder for user input. And you can see that the name is the same name between both of the insertion points. This means that what I type in one, I get in the other. If these were different variables, I'd use different variable names. And you can mix these up as much as you want to get the results that you want. Again, I find snippets to be a huge time saver, mostly for code that you have to type a lot, but you don't necessarily remember every aspect of, or for code that has a few plug and play parts that you can quickly replace with others. All right, so that's great. I got this part all completed, but I do need to add my DB set. So I am going to call public DB set. And while we're here, I want to point out another fantastic time-saving feature of Visual Studio for Mac that I absolutely love, and that is type filtering. So, and this worked really well when you have the show import items feature on that we talked about previously. Now, my completion list is rather lengthy. So if I backspace here and look at everything that starts with a D, you can see this is a very full completion list. And it can be somewhat daunting when you don't necessarily remember exactly what you want, but you know it's a class, you know it's a delegate. So with IntelliSense type filtering, you see these icons down at the bottom of your completion window. You can select which ones or which types you want to filter by. So for example, if I want to filter only by classes, I click classes, and that limits the completion list to only include classes. Same goes for things such as enums and structures. There we go. By limiting the number of items in my completion list, combined with the power of showing all available imports, I have a much more helpful and friendly completion list available to me. All right, so know that DB set is a class, so I'm going to limit to class, navigate down here to DB set. I know that it is a type of meal. And IntelliSense is going to suggest that I call it meals, which I agree with. That's a good name. So I'm going to accept that by hitting tab. Then add my get set here. There we go. That essentially completes my context here. Now let's check out my to-do list and see if there's anything else I need to do once I clear this guy out. There we go. All right, by clicking on tasks, I can see that I need to change kcal from strings to int. All right, so I'm going to double click here and navigate. All right, change. Ooh, OK, so yeah, they're actually doubles. So I need to change these doubles to integers because that's the data type it needs to be. And whoever did this, probably Dominic, he did it wrong in the first place. So I'm going to go ahead and change this to be integers. All right, so I can do this in several different ways. I can do a find and replace, but that might replace things which I don't want to replace. I can do them one by one, but we don't want to do that anymore. This is the 21st century. We don't need to do things one by one. So what options do I have? Well, I have the power of multi-caret editing. Now, what multi-caret editing does, it allows me to have multiple insertion points based on pattern matching. So what I'm going to do here is I'm going to hit Option Shift period, and it's going to select double. Now, if I type that key combination again, we'll see that the next double is selected. And the third time, the third double. And now, if you notice to the right of each of these strings, I have the word or the cursor blinking for double. That means that there's 3 insertion points in my code right now. So if I type in int, each of those is changed to integer. So without having to find and replace or doing these each by hand, I'm able to quickly replace those code snippets. Now this is a very simple usage of multi-caret editing. It is a super powerful feature, and it clearly has way more uses than what's demonstrated here. But I hope you give this feature a try. It's available, again, through keyboard shortcuts and also through your mouse clicks as well. For the keyboard shortcuts, if you check out multi-carets under the Edit menu, you can see all the different combinations of keys that you can hit to enable different multi-caret options. All right, so that's step 2 is done. Now, if you recall, I need to be able to tell when I overfed my cat. So let's go into the index.cshtml, take a look at the new web editors. All right, so this is the Fitty Kitty index.cshtml page. Now, I know a few things. surprisingly, but I do know a few things. And one of those things is that I need to have a CSS style. But I want to make sure that I'm using proper IntelliSense here. So right now I'm in an HTML document essentially. It's a CSS-HTML, but the code I'm looking at is HTML. So I'm open a tag, and I see that I get HTML IntelliSense. That's exactly what I would expect at this point. But I know this is a style. I know that the style I want is going to be of type CSS. All right, so now I'm within CSS, because I'm within the Style tab. So I need to have a designation for overweight, or overcalories, apologize. And here I'm going to say background color. See, now I'm getting CSS IntelliSense. So by getting the CSS IntelliSense, I'm able to then complete what I need in this context. So background color, I want that to be red to warn me that I had a little bit of overfeeding. And I want the text color to be white so it is readable. I also mentioned that I wanted to have some sort of designation of differences of days. So even days will have a gray background, odd days will have a white background. That way I can clearly demarcate the days. So I need to have another designation here. I'm going to say even day. And again, I'm going to use CSS IntelliSense to get me the background color. I'm going to pick light gray. Perfect. All right, there we go. Now I have all the CSS that I need to fill out the styles. So I'm going to hop down into my for each loop and add the code. So we saw HTML IntelliSense, we saw CSS IntelliSense, and now we're going to see C# IntelliSense all within the same file with context-aware IntelliSense. All right, so how are we going to do this? Well, I'm going to type in C#. So I know that I need a string to designate the type of style I'm doing. So style choice. Just initialize that way. All right, so I know the main differentiator is going to be the day. So the first thing I want to mark is whether it's an even or odd day. So if item.time.day is an even number, then style choice is going to equal even day, as that's what I set here, so even day. So you notice that I have set these values to be even to, or to be equal to, those which I declared within my style. And that way I can use the CS/HTML and the C# code to designate my style. So I'm going to do the same thing for the over. So if item.kcal_limit, or day total, is greater than 75, 85, let's go with that. Style choice is going to equal over. As again, that is the name of the style that I put in place within my CSS. So finally, I need to add the class here to my table row designation. So class equals at style choice. All right, that should complete it. Now I should have what I need here to see if I overfed my cat, which is important. One thing I want to quickly point out is I can now choose which which browser I want the IDE to launch. So in this case, let's go ahead and launch with Microsoft Edge Beta. So I'm going to click deploy, and we're going to watch this work, hopefully. The ability to really pick out your web editor is a small but big feature, if you know what I mean. It's not something that's going to change everything, but it makes things a lot simpler. And, I have to trust this certificate. Of course I do. I'm a trusting person. And I need to type in my password. And I'm going to let you all see it, so I'm a trusting person. All right, password's typed in, build is successful, deployment is occurring. Let's see how I did on feeding this week. All right, localhost 5001, perfect, here we go. Now, I do have these days designated for when I overfed my cat. I overfed Hemo one day, Buttons the other. That's unfortunate, but now at least I know which days I did overfeed my cats on. We did have an issue with even day, and that is because I named it wrong. So if I go back down here and I run it again, even days should now designate the colors as we would expect. Let's make sure that works as expected. There we go. Now the even days are marked as such. So let's take a look back at what features we covered. First, we covered the updated web editors. These include native typing performance with context-aware IntelliSense. Again, that context-aware IntelliSense was the ability to have different IntelliSense languages within the same document based on the context in which I'm writing code. We also saw automatic IntelliSense importing through show import items. That allows you to import types as you type and ensure that you have anything available to you. One thing to note, though, is that if a NuGet package is available in your solution but not within your current code file, it too will be available in the completion list. IntelliSense type filtering allows you to limit the amount of data within your completion list based on type. Again, that combined with the show import items is a super useful feature. And finally, we saw multi-caret editing. This allows you to insert multiple carets of code at the same time based on any number of different constraints, such as matching characters as well as strings. Finally, one thing I didn't get to show, which is super important, is right to left support in the editor. Now, if you see on the translation here, it says, "Welcome to the editor" in Arabic. Arabic being a right to left language, that means the language of the sentences start on the right and end on the left, opposite of what we are used to in English. On the legacy editor, you see that the string was backwards, so it actually read in reverse. That's no good if you're trying to type in a right to left language. Luckily, the new editor supports right to left languages, and we can see that the end of the string is where it should be in a right to left language. Again, this is a very important feature if you type any right to left language or bidirectional languages, and we're super happy to have that in our IDE. It was a top community request, and we're happy to fulfill it. All right, so quickly I want to talk about multi-targeting here. And then let's see here. So I'm going to open a new instance of the IDE. And multi-targeting is a new feature in Visual Studio for Mac that allows us to target different versions of the .NET Core framework within the same solution. This is super useful when you're trying out new framework types or you want to work on migrating your code. So I'm going to open up this multi-target sample. And as it's opening, let's take a look at what this actually means in practice. All right, so here we are, multi-target framework. So you can see up here, I have the ability to choose .NET Core App 3 or .NET Core App 2.2. And I also have the ability to target it here. One thing I want to point out in this example is how IntelliSense is aware of your multi-target situation and lets you pick, and demonstrates what versions of completions are available to you. So I'm just going to go on down here, going to type A. And as I scroll down, you're going to see that some of these have these little warning triangles next to it. Let's see what that's all about. All right, so if I hover over and select App Domain Setup, we see that it's only available in .NET Core 3. That's not available in .NET Core 2. So now, as a developer, I know which target framework I need to pick in order to use the code that I need to use this time. Again, another super handy feature that really makes development go a lot faster. All right, let's hop on back over to PowerPoint here. Play from current slide. All right, so again, with multi-targeting, you were able to see that you can target different frameworks with a single app. The framework is aware, the IntelliSense is aware of the framework which is selected and also aware of what's available in each framework. Super powerful feature, and I hope you check it out. We also have an updated XAML editor in Visual Studio for Mac, which is a huge, huge, huge benefit if you are a Xamarin developer or if you write in XAML at all. The new XAML editor includes fuzzy searching, resource IntelliSense, and type filtering. Now, we don't have enough time to get into this today, but I do suggest checking out both James Montemagno's talk as well as David Ortnow's to see how the new XAML editor works in real time. I also want to point out that there's more VS for Mac available at .NET Conf. Tomorrow at 8 a.m., my friend Syed Hashimi is going to be here to demonstrate how to get started in .NET Core 3 with Visual Studio 2019. Again, I scratched the surface of what's available in .NET Core 3. Sed's going to deep dive into it and make an app from beginning to end. I really suggest checking it out. It's going to be a great, great, great presentation. All right, so time for questions. Quickly, my name is again Cody Beyer. You can follow me on Twitter at CL_Beyer. We have at Visual Studio for Mac if you want to follow us on Twitter as a team. Documentation, check it out, aka.ms/vsmacdocs. And finally, check out developer community. We're here to listen to your feedback, to provide suggestions, aka.ms/vsmacdevcom. All right, let's toss it over for some questions.
Wow, that was awesome. Thank you so much, Cody. I love those multi-carat tools that you showed earlier, actually. It was pretty sweet. We have some questions here from Twitter, so let's see the first one. Over here, S. Ravi Kumar wants to know, I don't see an option to add Docker support in new editor. Any idea when that will be available?
I don't off the top of my head, but if you want to hit me up on Twitter, I will get back to you as soon as I can on that. I believe that most of those, the main goal was to get C#, then XAML, then web, and then these extra, kind of Docker files and YAML and all those other files in there as quickly as we can post that point. So we're looking at the 8.4 timeframe most likely. But yeah, hit me up on Twitter and I'll get you some more exact timeframes there.
Great. Yeah, we have another question on Twitter. Let's see. This so they want to know what's on the roadmap for VS for Mac.
Great question. First of all, you can check out our roadmap on the docs page. I don't have the link available and I apologize for that. But we're really focused on bringing Blazor support in 8.4. So if you've watched Daniel Roth's amazing Blazor talks, Visual Studio for Mac is aiming for 8.4 as our Blazor timeframe. So check out that. Also updated Git backends to ensure that your Git experience is as good as it can be. And again, bringing more of that editor goodness across other aspects of the IDE, including the support files.
Awesome. Well, one more question right here. When will .NET Conf videos be available on demand? They will be available within 24 hours, so you can get them right off the presses. Well, I'm pretty excited for the next session. Well, actually, we have a little commercial break. Please enjoy this short little package.
Hey there, treasure hunters. I've got your next clue from our friends at Lead Tools. For this challenge, you will use the Lead Tools OCR and Barcode SDK technologies to extract the secret key as text from both an image and a barcode. Join those two parts into a one-line secret key and then whisper that complete key to the .NET bot in the Visual Studio Twitch channel to continue on with our technical treasure hunt. Go to this URL to get started. Solve that, and you could be well on your way to the next step in our technical treasure hunt.
Hi, I'm Cam Soper. I'm a content developer working on .NET Docs here at Microsoft. And welcome back to Entity Framework Core 101. So far, we've looked at using Entity Framework Core exclusively with SQL Server. In this video, we're going to look at using Entity Framework Core with other database providers. The database provider is a layer in the EF Core architecture that's responsible for the communication between Entity Framework Core and the database. It's a pluggable architecture, which means we can support all kinds of databases. The first database provider we're going to look at is SQLite. SQLite is an open source, cross-platform, embedded database technology. I'm starting with a web application where I've already got Microsoft.entityframeworkcore.sqlite.design and .tools installed. To use the SQLite provider, where I would previously use .useSQLServer, I'm instead calling .useSQLite, and I'm passing in the connection string in the SQLite format. That connection string points to a local file here on my machine. I've created a new record. I'm going to use a tool to read SQLite databases. This is an open source tool available for download on the internet. And we'll browse to the products table. As you can see, there's the rope pull toy I just added. The next database provider we're going to look at is a brand new database provider from the Microsoft Entity Framework Core team that supports Azure Cosmos DB. Cosmos DB is a cloud-based distributed NoSQL database, which means that instead of being a relational database management system, it works with JSON documents. Just as in my previous example, I have a working web application, and in this web application, I've already added Microsoft.entityframeworkcore.cosmos.design and .tools. We already have a working entity model and a working database context. We'll use the useCosmos method to pass in our connection information. And once again, I'll have to remind you, don't include sensitive information in your code. One difference with Cosmos DB is that it doesn't support the concept of an auto-generated int for a primary identifier. So I've changed the entity model so that our IDs will be strings, and they'll be initialized to a new GUID, or globally unique identifier. Let's run the application and add a record to our Cosmos DB instance. Now that I've added that record, we'll go over to the Azure portal, refresh my list of items in my Cosmos DB instance, and you can see the squeaky bone I just added. These are just two of the possible database providers you can use with Entity Framework Core. Visit the Entity Framework Core documentation to see the full list of supported providers. Some are provided by Microsoft, and some are provided by the community. Support includes MySQL, Postgres, Oracle, DB2, and others. In this video, we looked at how EF Core uses database providers to support a plethora of different database technologies. In the next video, I'm going to show you tips to get the most performance out of your EF Core applications.
Hi everyone, welcome back. I'm Daniel Roth, and in this session, we're going to talk about the future of Blazor on the client. Blazor is a client web UI framework based on .NET and C# instead of JavaScript. Now previously, the browser was a black box that you couldn't get your .NET code into. Now with Blazor, you can use .NET for your client web development needs. But what if you need to take your app to other native platforms like mobile, desktop, and other devices? It could be really expensive to have to build native experiences for all those platforms, and you might not have the developer resources or the developer skill sets. One common strategy is to use the ubiquity of the web and your existing web developers to build apps with native-like capabilities. In the future, we want to evolve Blazor so that you can use it to build apps that have those native-like capabilities. So we're going to walk this spectrum from the web to native applications. Now we've already seen Blazor server apps in .NET Core 3.0. It's available this week. Download it, install it, try it out. Blazor server apps enable you to add rich client-side interactivity to your existing .NET web applications. Now they run on the server, but they allow you to have that client interactive feel like a single-page web application. They also enable you to leverage the capabilities of the browser using JavaScript interop. Let me hop over here to Visual Studio. Here's the Blazor weather application that we saw earlier this week. This is a Blazor server app. I've already refactored it again to move all of its components into this Razor class library, this Blazor weather.core. If we expand some of these folders, we'll see all the Razor files in there. There they are. That's so that I can reuse these components in future demos. On the Blazor server app, we've seen what this looks like. It has a UI for showing the current weather. And one of the things that we already saw is that we do have client-side interactivity. We can click on and change the current temperature unit. We can also use the capabilities of the browser to get the user's current location by clicking here. That should use the geolocation APIs to give us where we're currently at. All right. One other thing that I've added to this application that also leverages an additional capability is the browser's local storage. I used, it's actually a community project. Was it github.com Blazor? This is a project by Chris Sainty, and he's done a whole bunch of really good stuff. He has a package that uses JavaScript interop to enable local storage in Blazor applications. I use that so that if we go back to the app, we can store our pinned locations locally in the browser. So let's go to Chicago, and we'll pin that one. There it is. And now we can cycle through our pinned locations. So we have Seattle and Chicago. If I grab this URL, I'm just going to close that tab, and then we'll open up a new one, browse back. We still have Seattle and Chicago as our pinned locations, using the browser's local storage to store those things. So we get to leverage browser capabilities as well with our Blazor server applications.
Mr. Roth, Mr. Roth!
Oh my goodness.
I brought your Blazor.
What are you doing?
I brought you your Blazor!
Oh my goodness. Yes. Yes.
Gotta look the part!
Oh yeah, this
The blazing Blazor.
this
There you go.
makes me ready now for the
There
demo.
you
Thank
go.
you,
Now
Mr.
you can
Fritz.
talk
All
about
right. All right, we're gonna blaze on now. Okay. Woo! All right. Yeah, not expecting that. Okay, so what's the next step on adding more native-like capabilities to our Blazor application? Well, the next step is Blazor WebAssembly. Blazor WebAssembly apps run in the browser on a WebAssembly-based .NET runtime. Sorry. So with a Blazor WebAssembly app, the files your app is just a bunch of static files, and they can be downloaded. They are downloaded into the browser and then executed. And they can then leverage the capabilities of the browser as well. So I've taken the same application. This is the server version. Let's close that. Let's now go to a different project, and this is a WebAssembly version of the same project. It's actually using exactly the same components. This is kind of cool. A lot of customers that I talk to are starting out with Blazor Server with the plan to once Blazor WebAssembly is available in May of next year, that they can then shift their app to actually run full on in the client. But let's go ahead and run the WebAssembly version of this app. Looks pretty much the same, does the same things. Like we can get get our current location here. We should be in Redmond. Yep, there we are. All right, and then if we F12 and look at what was downloaded to this application, it looks a little bit different. Yeah, so there you see down at the bottom, there's that mono.wasm file. That is our WebAssembly-based .NET runtime. So this app is actually running client-side directly in the browser. Now, to show that that's really occurring, we can even debug. When I F12 again, if we look in the console, you can see there's a debugging hotkey gesture that we can do. I'm not debugging this in Visual Studio. I'm actually going to use the browser dev tools to debug it. We don't support debugging in Visual Studio yet for Blazor WebAssembly apps, but we will in the future. For now, don't run it with debugger in Visual Studio, and then you can do this trick. So I'm going to hit Shift-Alt-D. And that's going to try and bring up the browser dev tools to connect to the tab that I want to debug through a debugging proxy that we set up for you. Now, for that to work, we actually have to run the browser with remote debugging enabled, which I don't have it doing currently. And it's telling me how I can restart it, so it does do that. So I'm going to close down the browser completely, and I'm going to run the command that it just told me to do to restart the browser with remote debugging enabled, and we'll hit that gesture again, Shift-Alt-D, and now I should get the browser dev tools that can connect to my tab. There we go. All right, so let's put this side by side with the tab I want to debug, and we've already got some files open. Let's go ahead and close those. In the sources tab, we can see down here, or we can actually take a look at all of our, let me give myself a little more space, all of the files that are in our application. So there's Blazor Weather Core. What do we want to look at? Let's look at the temperature unit picker. We'll open that file up. We can set a breakpoint right here on the click handler when the temperature is changed. Let's go ahead and get the current location back up on the screen so we can change the temperature unit. We'll click, and there, we just hit a breakpoint in C# in the browser running on top of a WebAssembly-based .NET runtime. We can even expand down here and take a look at some of the local fields in our component. So currently, the temperature was Fahrenheit. Let's hop out of here and let the app continue. If we clip the temperature unit picker again, it should say that it's changed, and has it? Yeah, it looks like we're good. So now the temperature is Celsius. So there, we just debugged our Blazor WebAssembly app directly client-side. So that's pretty cool. We'll go ahead and let that run. All right. So that's Blazor WebAssembly. Now, we can use some of the more modern web standards in our Blazor WebAssembly app to make it even more native-like. And apps like this are typically called progressive web apps, or PWAs. What is a PWA? Well, a PWA is just a web app, but it uses modern web standards to enable things like offline support. You add a service worker so that the files can be cached and used even when the browser is not connected. Support for push notifications. PWAs tend to are fast and responsive, so they have that native app-like feel. On some platforms, they can even be OS installable, like you can pin them to your home screen on your phone. Or on Windows 10, you can install them so that they can be run from your start menu. So we can take our Blazor WebAssembly app and turn it into a PWA. All right, let's do that. So actually, we've already got it running. And if we look at the top with our Blazor WebAssembly app, you can see there's a couple of icons up there. And this one here says install Blazor Weather as a PWA. That's because the browser and Windows 10 is detecting that this is a progressive web app. If I go ahead and click that, yeah, let's go ahead and install. And now we see our Blazor WebAssembly app, but it's in like a native shell with all the same functionality still works, like, I don't know, St. Louis. So we can find new locations. We can get the location by geolocation. And we can see that on the start screen of my Windows 10 box, there is my Blazor weather app, and it has a nice little icon so that shows up in the start menu. So that's pretty cool. So that's a Blazor PWA. How did we enable this? If we go back to the code and look at how this was implemented, in the www root folder, we can see there's a service worker that was added to this application. This is a piece of JavaScript that enables caching. And then there's also this manifest file, which specifies like icons that can be used when this app is either pinned to a home screen or to the start menu on a Windows device. So that is a Blazor PWA. It's starting to look a little bit more native. It's got a native shell. It's runnable from the start menu. Let's go ahead and close that. Great. Hybrid apps are native apps that run natively on the device. They have access to all the native capabilities of the device, but they use web technologies for rendering their UI. So for example, you might have a mobile application that's running natively, but it's using a web view for rendering all of its user interface. Or you can have an Electron application. And an Electron application is using an embedded Chromium shell to handle all of its user interface. Let's see if we can build Blazor hybrid apps as well. We've been doing some experiments in this space. Let me go back to Visual Studio. All right, so here in my third project, we have a Blazor Weather Electron app. So I'm going to set this as the startup project, and we're going to go ahead and run it. Again, it's using the same components as before. But now, instead of running as a web application, this Blazor Electron app is going to run in an Electron shell. It's a native shell, like we have all the access to all the native capabilities of Electron. The same functionality still works. Let's see what the weather's like in New York. And it goes. We can get the current location and so forth. We have all of our pin sites. And this app is interesting because it's not actually using WebAssembly. The Blazor WebAssembly app and the Progressive Web app, those were both WebAssembly based. They were running inside the browser using the WebAssembly based runtime. And as a result, they were also limited by the browser security sandbox. A lot of people ask me about Blazor WebAssembly apps when they see DLLs being downloaded into the browser and ask, is that safe? Is that okay? Like, is there any security issue there? And the answer is no, because the code that's being executed is being executed using that .NET WebAssembly runtime running in the browser security sandbox. So it can't do anything more than what normal JavaScript could do in a browser application. Can't do anything more, and it can't do anything less either. It has all the capabilities of what JavaScript can do, but no more. So it is safe. In this case, though, we're running on Electron. In an Electron app, the .NET code is running in a normal .NET Core process. And that .NET Core process does actually have full access to the native capabilities of the machine. So if you want to touch the file system or open arbitrary network connections with this application, that's stuff that you can do in this application. So basically what we have here is a native desktop app with the UI built using web technologies, built using .NET, and it's cross-platform. This will run on Windows, Mac, and Linux. So that's an example of what a Blazor hybrid app might look like, at least for desktop scenarios. This is something that we're exploring and investigating. If you want to play around with Blazor Electron, I think I have this URL set up. You should go to hbs:// Blazor Electron. AK8MS Blazor Electron is the URL. And let's see if this is now live. I think I set this up this morning. Yeah, there we go. This will take you to our ASP Labs repo, and we have an experimental project that we're working on that integrates Blazor with Electron, and there's a sample there that you can try out. All right, now the last stop on our spectrum from web to native is going, first let's get past the hybrid screen, is going full native. Actually having a native app, but instead of using web UI or web technologies to render the UI, we use native controls so that we can leverage the native controls of the device. This is an area also that we're investigating and experimenting with. I don't have a live demo for this area, but Blazor was architected from the beginning so that its renderer was extensible. The default renderer in Blazor renders HTML, and that's why you use Blazor to build web applications, not too surprising there. But the renderer can be replaced. In fact, you can replace it with a different renderer that renders to whatever you want, like you might render instead to native controls. There's a really cool demo that is just a tech demo, an experiment. It's not anything that we have any plans to ship, but that Steve Sanderson did at NDC Oslo earlier this year. And what he did is he took the Blazor renderer, he replaced it with a renderer that could render to native Flutter controls. So he was able to build a Flutter app using Blazor, writing his code in C#. Normally Flutter apps would be written with Dart. It's pretty cool demo. You can take a look at it at the link below, aka.ms Blutter. So Blazor plus Flutter gets you Blutter, I guess, where you can see Steve Sanderson demo that capability of Blazor. And again, this is not something that we actually plan to ship, but it just shows you what is possible with the Blazor model. This is very similar in nature to what you typically write with applications that are using technologies like Xamarin or React Native. These are applications that run natively on the device and then also are rendered to native controls in a cross-platform way. We're looking at could we do something similar with Blazor, like have a Blazor native that does a very similar thing. Nothing to share yet there, but it is an area that we are currently looking at. All right, so this is what the roadmap now looks like for Blazor. Blazor Server is available today. It is supported in .NET Core 3.0. If you want to build a Blazor Server app and deploy it into production, you can do that right now. Go ahead and download it, install it. It's great. You can start adding some rich interactivity to your existing .NET web applications. Blazor WebAssembly, we announced earlier this week, will ship next year. We're targeting May of next year. We'll start to see more progress on that in the months ahead. We're also starting work on Blazor hybrid apps and Blazor progressive web apps. You should expect to start to see previews of that functionality in some of the .NET 5 previews that will be coming up shortly. .NET 5 is expected to ship in November of next year. But hopefully we'll have previews of PWA support and Electron sooner than that. If you want to play around with Blazor WebAssembly apps as PWAs, there are actually some really nice community projects out there that you can download and install. And those are really great to try out. Blazor Native is not something that we have any concrete roadmap for, but it's an area that we are experimenting with, and we hope to learn more about and talk to folks like you to see what we should do there. So that is the future of Blazor on the client. I hope you enjoyed the things that you saw. I hope you're excited about them. Give them a try. Try out Blazor and Electron with a sample. Try out Blazor WebAssembly. Give us feedback. And of course, make sure you download .NET Core 3.0 today. There is no time like the present, so make sure you're using the bits that are already ready available. This is a bunch of useful resources that you can go look at to get started with Blazor. Go to blazor.net to get the bits and find the documentation. You can get the .NET Core 3.0 bits at the .net/get-core3. Make sure you get Visual Studio. If you're on Windows, you're going to want to get the latest release of Visual Studio 16.3. We have a wonderful Blazor workshop if you want to learn how to program with Blazor and participate in the Blazor community. They have a lot of great folks like Chris Sainty, who did the Blazor project, and others that are building wonderful JavaScript interop libraries and component libraries. And with that, I'm going to turn the remainder of the time over to questions.
Yeah, thank you.
Check this out! Like I am
that's
sparkling.
pretty awesome. Yeah, I love that. Yeah. So thank you so much. We have a little special surprise.
What?
Another
A little-
surprise.
What
Lots
is
of
this?
surprises
Just
today.
go on over there. Just walk over and let's get you.
What is this,
Let's
Scott?
get this over there right now.
So I want everybody that's watching to know that this is actually Dan's 15-year anniversary at Microsoft.
It
What?
is. Yes.
And Blazor probably wouldn't exist without Dan. And
With a lot of people.
So
With a lot of
but
people
you're
work
a
on
big piece
Blazor.
of the Blazor thing. And so I want to give you this gift. This is a Blazor pillow. But what's even better about this Blazor pillow, if you swipe up,
Oh my goodness.
But
there
wait,
is Dan Rohr on the Blazor pillow. Look at that. Is that spectacular or what?
Spectacular.
Are
That is
these being
blazingly awesome.
fabricated at large? Because I'd love to just like lay my sweet
Oh,
head
this
on
looks
that.
like a one-of-a-kind thing. I don't know. That is. Thank you,
Congratulations
Scott.
on
Thank you
15
very
years,
much.
Dan. Thank you
It's
very
been
much.
a good 15 years. To the next 15 years.
Yes.
Fantastic.
Thank you.
Can I
That's
can I
great.
borrow that pillow for a couple of weeks? I mean, just maybe. No,
Creepy. No.
Yeah, you wanna-
this got awkward real quick. I'm so sorry.
we probably have a ton of questions.
Let's do
oh
it.
wow!
Let's
Lots of people tweeted you in
that
your
over.
brand new jacket, so that's pretty sweet. Do you want to take a
Yeah,
look?
let's do it. So let's start from the left here, and we're going to get this question here. Will Blazor be a good choice for enterprise-level web apps that need high availability, scalability, and fine-grained services on the cloud? Wow, this is really good.
Yeah, yes. I mean, that's what it's built for. And Blazor Server in particular, that's what's shipping today. That's what's supported. Absolutely supported for large enterprise applications. I think we think of Blazor as being particularly well suited to enterprise apps for line of business applications. It would be absolutely, yes, it is ready.
So yes,
The answer
yes,
is
and
yes. All right. What else do we have here? So what about this one? How do users update new build versions in Blazor PWA?
Oh, updates. How do you do that?
These updates to new versions in a PWA. So I believe that's all managed by your service worker policy. So I think the inherent question is when you download a PWA, you can often set up a service worker so that it's available offline, which is effectively like caches the files. When you set up the service worker, I believe that's where you put policy about like when does the app go back to get the new files. And, I'm sure there's also a way where you can just force the app to refresh. But I think that's how you would do it. I'll double check on that, but that's my current understanding. We haven't done a lot of investigations in Blazor and PWA yet. We've just done some early, proof of concepts like you saw today. This is an area that I expect that you'll see us looking more into in the .NET 5 wave.
All right, next question. Any updates about supporting gRPC web for Blazor? Also, Blazor native on mobile.
Yeah, gRPC web, that's really interesting. So we support gRPC now in .NET Core 3.0. However, it doesn't work from a browser. You can't speak the gRPC protocol from the browser to your front-end servers. There is a variant of gRPC that you can use called gRPC Web. We don't currently support it today, and we don't have concrete plans to support it yet. But we are talking about it as a potential area to invest. So don't know yet, but let us know if you think that would be interesting and useful. For Blazor Native, well, we just talked a whole bunch about what we're thinking for Blazor Native. We are right now in the prototyping and investigating stage. Blazor was architected from the beginning to support non-web native scenarios where you replace its renderer with some other renderer that can go to native controls. It's very similar to what React did. React started out as a web framework and then moved to support native apps with React Native. Blazor can absolutely do the same thing. What the roadmap for that is yet, we don't know. It's still TBD.
TBD. Okay. We have another question here. A PWA using Blazor, that's something really attractive. But for now, my question is, which server auth integration is preferred, like Windows or DB? Chrome has problems with Windows auth.
Ooh. So which auth mechanism should you use with a Blazor application? So that will in part depend on your hosting model, like if you're hosted on the server or if you're running on WebAssembly in the client. And really the type of auth you then use will depend on your app and will depend on your environment. If you're running in the client on WebAssembly, that's like a SPA. So you use SPA-style authentication patterns. Typically that means using like an OpenID Connect OAuth-like flows where you acquire a JOT token and use that with all of your HTTP client requests. You can also use cookie-based auth from a SPA. That is possible. Blazor server apps, you have the whole set of auth options available to you based on what you're trying to do. If you're writing a line of business application and you have Windows users and you want to let them log in, Windows auth, that would be a great option. If you're writing an app where you need users to be able to register their own user profiles and have their own passwords that you want to manage, then using ASP.NET Core Identity for your authentication support is a great option. For the WebAssembly apps, using identity servers support for OpenID Connect would probably what you want to do.
Fantastic. So just a couple of pictures. Like this one to me is
great.
It feels like I'm there almost,
Yeah.
right? I mean, do you know?
Like we're
it
there
feels like
live.
we're there. Like it's like we're there. Yeah, it's wonderful.
wild.
And another one, of course,
Wow,
Jeremy.
looking sharp.
If you follow him, you'll find he did another picture of me, but not as flattering as this one. Jeremy, you got to get my good side, buddy. Now for
Official
more
Blazor jacket.
For more important questions, obviously, can this be integrated with an existing .NET Framework project? If so, how? Via NuGet?
That's a great question. Could you use Blazor with a .NET Framework app? I mean, Blazor Server obviously not, because Blazor Server is running on ASP.NET Core. Like it's using the SignalR support in ASP.NET Core. So no, with .NET Core 3.0, you can't run that on a .NET Framework app. Blazor WebAssembly is just static files, so it doesn't really care what is on the server. It could be actually PHP or whatever on the server. So technically, I guess you could use .NET Framework on the server with a Blazor WebAssembly app, but it's really been optimized and integrated with .NET Core. So like the full stack experience that we imagine for Blazor WebAssembly is you have .NET Core on the server, Blazor WebAssembly on the client, and we provide you all the nice integration points there. That's how we mostly imagine it being used, but technically, it should be doable.
And here's like a super awesome question. Mika, what does it say?
Yeah, is that Blazor's future of web development?
Is Blazor the future of web
Is it the
development?
future of web
Oh,
development?
no, I'm not trying to put it on your spot, because you're wearing the jacket and you have a pillow with your face on
You're
it.
wearing a
So
Blazor.
whatever you
We're
say is
Blazor.
super authoritative when it comes to the future of web development.
It absolutely is. For many, many web developers, is it going to be the only way that people write web apps going forward? Like some people ask, like, does this mean that no one will ever write JavaScript again? Like, no, that's not what Blazor is going to do. There will be lots of people still writing JavaScript. There'll be lots of people writing in all sorts of different technologies. What WebAssembly did is it actually opened up the door for really any platform you want to be used in the browser. So I imagine there'll be people using Python and Go and Rust in the browser as well, but we're working really hard to make sure we have a great .NET full stack web development story.
All right, so here's another one. And this is interesting to me because I remember when this was introduced, I saw Sanderson demo it to me. It was Damian Edwards and Fowler. And we just sat there and were like, holy cow, this is ridiculous. And the first thing I thought was, perf. Is this going to be the same as the other? So any stats that show performance comparison between ASP.NET MVC Web and Blazor?
Yeah, so there's a couple different comparisons that you could do there. First of all, it's not really an apples to apples comparison. And the reason is, like we talked about yesterday, Blazor is for your client web development needs. It doesn't replace MVC. It doesn't even do the same things that MVC and Razor Pages do. Those are server rendered technologies that you use on the server. Blazor is meant to be used in the browser for client web UI. So you don't even do when you want to do a server rendering, you do that with MVC. You don't do that with Blazor at all. But there is some interesting perf characteristics of Blazor that are worth mentioning. Blazor is based on a diffing algorithm where you render your components, it calculates a diff, and then applies it to the DOM. That diffing algorithm has been highly optimized to be very, very efficient. When you run it on WebAssembly, there are some known performance issues with any CPU-intensive loads on our existing WebAssembly runtime right now. And that's because right now our .NET WebAssembly runtime is doing IL interpretation. And it doesn't have a jitter. It's just interpreting the IL on the fly. And that can be slower. We're working on that. We're working on supporting ahead of time compilation to WebAssembly, which does give you back that like native-like performance. We haven't had a preview of that yet, but we hope to have one as soon as we can, shortly. So that will hopefully address the performance problems of running Blazor WebAssembly in the browser. When you're running on the server, you're running on .NET Core. It's super fast, no performance problems at all.
All right. I think we have one more question.
Yeah, we have time for one more, right?
Yeah, we do.
All right. Will Blazor support a per Razor component server-side WebAssembly configuration in one SPA?
I don't know if I could parse that. Will Blazor support
a per Razor component server-side / that's like so many pieces here. That's why it's such a good question.
I think the way I choose to interpret this question.
Nice. Nice.
Yeah, you can
well, you are wearing the jacket, so you can do whatever you want.
I think what this is asking is you could imagine maybe having a mixture of hosting models in the same app, where this component is going to run on WebAssembly, but that component's going to run on the server. Maybe for whatever reason it makes sense to do that. We don't have a first-class way of doing that today. It is something that people have asked us about. Right now, you pick one or the other. You're doing Blazor WebAssembly or you're doing Blazor Server. It doesn't seem like there should be anything blocking it, though, because like I said, Blazor WebAssembly is just a bunch of static files. You could have a Blazor Server app. You throw a bunch of Blazor WebAssembly files into its www root folder, and you can download those and use those. So it seems like you could get it to work. I haven't actually done it yet, though, and it's not an area we've really played around with. Maybe that's something that we'll look at going forward.
Well, this has been amazing. We have coming up a short commercial break, and afterwards, no commercial. We're going to go directly to Jeff Holland, who's probably going to get us to think about servers less. His words.
That is exactly right. What an amazing transition for the Blazor Power Hour that we're having this morning. I am Jeff Holland. I'm a Principal PM on Azure Functions, working on Azure Serverless. And today we are going to continue the amazing conversation and very flashy conversation that Daniel had this morning with his Blazor and his Pillow around Blazor, both server-side and WebAssembly. We're actually going to apply that into a very common scenario, which is running Blazor and Azure Functions for serverless web apps. So to start with kind of what to expect for the next half hour, let's start by talking about what are serverless websites. What's some of the architectures that people are using? What are some of the benefits of why people would look into doing this? Where Blazor fits into the story? Where Azure Functions fits into this story. We're going to talk about how you deal with things like domains and delivery of that content. And then finally, we'll have some time for question and answers. So to start with, when we look at a traditional web architecture, like the kind of web app that you probably built before, has been kind of the one often talked about as a 3-tiered web application, it works a lot like this, where you have a client who's got their browser, and they make a request to some website. In this case, I've got a cool hip .dev domain. So let's say I want to call jeff.holland.dev. That's the website I want to go to. Well, the browser makes that request. That request travels across the internet. It ends up landing on some server. And that server is running some code, right? Maybe this is an ASP.NET app. Maybe it's a Node app running Express. It doesn't really matter. It's just the architecture I want you to be aware of. So it's going to land on that server, and that server is going to process the request. Maybe it has some things like Razor files or CSHTML. It's got some assets and images. And the server is going to render an index.html page. And it's going to return that page back to the browser, and the browser pretty much just paints it for you, right? So this is the traditional web architecture. You've got your browser, you have a server that's running some code, maybe talking to a database behind the scenes. And this is a fine architecture, but it does have some limitations. One of the limitations is that I need a server there. So in this case, I have a website, jeff.holland.dev, right? That might be my personal website. I'm not a super popular guy. I don't really need a server running 24/7 to process those requests. But in this architecture, I need to have a server running all of the time, ready to process those requests. So I'm paying maybe some, whatever, a dozen, couple, $20, $30, $40 a month on a website that's maybe only getting a few hits a week. But on the other side of it, maybe I actually have some traffic that is incredible load, right? Maybe I actually need to scale out. And with this 3-tiered architecture, I have to scale out all of these servers, because as I get all these browsers that are coming, I have thousands of browsers that all need their rendered version of an index.html page, and they need that to be processed in the server, returned back. So I also have to now scale these large servers, which can be a cumbersome process when I need to then serve this for high traffic, right? So now let's talk a little bit about a serverless web app architecture and how you can write apps in a serverless way. It starts the same. You have a user in a browser, and they say, hey, I want to go to jeff.holland.dev. But in this case, instead of hitting a server, they just hit some files in storage. So it's like pulling directly from a storage account. You could almost think if I open OneDrive and I get a link and I email it to someone and they click that link, that's all I'm doing here. I'm just routing the request to say, go pull in some files. So the storage account is going to return back an index.html page and some code that needs to be rendered on the browser. So in this case, since there's no server that's rendering the page, what I'm actually relying on is the browser to render that page for me. So all of the code, all of the logic to draw the elements, to update the elements, now actually needs to run on my browser because I don't have a server behind the scenes. I just have this storage account with static assets. Now, this is a popular architecture because in many ways it's a lot less expensive, right? I'm not paying for a server. I just need files in a storage account. I can also just have the browser do all the processing. For scale-out situations, it's very nice too. But one of the challenges with this architecture in the past is that really it was JavaScript users who were able to benefit from this architecture, because JavaScript had frameworks like React and Vue and Angular that you could do this rich native rendering on the browser. You couldn't run .NET in the browser. But as we've talked about already a lot today in this week, you can now run .NET in the browser. You can have the same architecture, but have it be .NET code that's rendering in Edge or Chrome or Firefox. And this is all made possible because of this amazing technology of Blazor and WebAssembly, right? So WebAssembly is like an underlying universal technology that lets you run compiled binary code from a browser in a safe way. Blazor is the .NET implementation, a part of .NET Core 3. So now .NET developers can build these serverless web architectures too. I mentioned here, it might look a little something like this. And in the case of, I do need to call a database. While I could write Blazor code that connects to something like SQL or Cosmos DB directly, that makes me feel a little bit antsy to be thinking about all these browsers making a direct connection to my database. So the other pattern that we often see in these serverless web apps is that when you do need some code that runs server-side, like a database connection or anything to deal with data really, you can call an Azure function. And these Azure functions are serverless, so you're only paying when an execution's actually happening. You still get this amazing scale, so you get a lot of the cost benefits and the scale benefits, but you can still have some code running in the cloud. And what's nice about Blazor and Azure functions that I love is I can now write .NET code running in my function. I can run .NET code running on the browser. It's .NET across the board, right? Even if I need to pass maybe a class or an object from the browser to an Azure function, I can use the same class file in both spots. I can share code between the server and the client. This is really nice, and it also gives me benefits that when I need to scale, let's say 1 million people go to jeff.holland.dev. All of you watching now are like, hey, what is at jeff.holland.dev? Maybe you're poking around it right now. My functions just scale automatically, and my storage account is super elastic in how it can scale as well. And what's nice here is that while I might need thousands of rendered index.html page, all of the compute, all of the processing to actually render those pages is all happening on the browsers, right? I'm kind of taking advantage of all the users' computers. I'm making them do the hard work. Their smartphones, their laptops, their desktops are all rendering the page. And it's just up to me to make sure that I'm serving that static content. So it's a super appealing scenario. This is how I personally run my website. Or jeff.holland.dev, because I pay pennies a month for this thing. I get amazing scale, and I'm running .NET in the browser and .NET in the server as well. So I want to take some time now and demo this to let you know how you can get started building something like this. So the first one to note, I have .NET Core 3 already on my machine. And to start using Blazor, I just want to make sure I've installed the Blazor templates, right? So here at docs.microsoft.com, I have templates for Blazor right here that I can install in and be ready to go. And once that's there, I can create a new project. So let's start with the client side. Let's create a new Blazor client-side WebAssembly app. So I have here a folder already ready to go, and I can just say .NET new. And I'm going to use the template Blazor WebAssembly, or Blazor that's going to run in the browser, right? So I go ahead and push to create. It's using the template to create a Blazor WebAssembly app. And let's go ahead and open this up in Visual Studio Code now so that you can see what this app looks like and some of the stuff that it scaffolded for us, okay? So this is pretty familiar. You probably already saw this in some earlier demos this week as well. I have things like my startup file, which it feels very familiar to me, program.cs. I'm able to inject in some different builder and configuration aspects. I have here some different pages. These are Razor pages. In these cases, these are Razor pages that are going to render in the client. The index.html page is pretty boring. It's just some HTML. The counter example is a little bit more interesting because here I have some code. And it's going to increment a counter using current count ++. And then finally, the fetch data example is fetching some data from an external source. My favorite line of code in all of this template too is this line right here. And I don't know why, but just the fact that I'm using HTTP client, and I know that my good old buddy HTTP client is going to be the thing making this request from my browser, in my case using Edge on Mac, just tickles me. I love it. I love HTTP client. I love the fact that I can use it in the browser. So here I have some code, some basic pages here. If I want to as well, like let's go ahead and just test this out without even making any changes. I can just say .NET run. It's going to compile this Blazor template. In this case, it's going to compile it along with some WebAssembly kind of artifacts so that it knows how to run cleanly in a browser. And in just a second here, it should expose for us a local host that we can actually browse and start to navigate to. So right here, localhost 5000. If I open that up, here now is this C# app, no code server side. It's not even doing code locally. It's just compiled it and handed it over to my browser. And my browser is now doing all of the work here through WebAssembly, okay? So now let's talk about how we can start to call some data from an external source, right? In my case, I said sometimes you might have a database, something like Cosmos DB or SQL, that I don't want to call directly from my WebAssembly app. So here, let's add in some function information. So since we're already at the Blazor side, I'm going to start by creating the Blazor aspects to call a function. So let's add a new page here. Let's call it my function.razor page. And here, I'm going to type faster than a speeding bullet and paste in some code I wrote before that says, hey, I have a new page here called functions. I'm going to get my handy dandy HTTP client that tickles me, as I mentioned before. And here, when I'm trying to initialize the page, you'll notice I'm actually calling an Azure function. Now, in this case, it's calling a function that would be running in the cloud. If I'm debugging this locally, I could change this to localhost and actually call a function that's running on my box. And then it actually even has some information here. So while it's waiting for the function to respond, it's going to say loading. And then once I get back my message from the function, it will automatically populate the message. So it's going to be dynamic as well and wait for those responses. So here I can call that function. Let's just go ahead into the navigation menu as well. And I want to make sure that there's a way to navigate to this new page. So I'm going to type that very quickly as well too. Right? So now I have what could be some code to call a function. What about my function? Where's the function that I can call? And that's super easy to set up as well. Let's go ahead here and open up another empty folder called function app. I'll just create a new window for VS Code. I could add these to the same workspace. Now here in Visual Studio Code, I've installed the Azure Functions extension. Now I could do this from Visual Studio 2019 as well, but since I'm already in VS Code, I'm just going to stick with it. Let's just go ahead and create a brand new function project using that function extension. And as I mentioned, what I love about Blazor is that I actually want to write C# client side and C# server side, or serverless side. So let's go ahead and choose C# as our language. These are APIs, so they're going to be triggered by HTTP requests. I want to call this my hello function, and I can give it the namespace. And with that, VS Code is now scaffolding for me a Azure Functions project that I could use to run all my code, in this case server side. So here, this is the default template. It's pretty boring, right? It's just saying, hey, get a request, look at the query parameter, see if they passed in their name, and then say hello to their name. I could add in here, connect to Cosmos DB, do a query on SQL, return the results. In my case, though, let's just even simplify this a little bit. And we're just going to say return new OK object result, and we'll just say hello world. Okay? So here now is my Azure function. When I'm ready to go, I could debug this locally. I could now publish this to the cloud. So I can say, actually, I want this code to be running in Azure, so it can be called whenever I need to, right? So I have a function already here called jhollandblazor, which is the function that I could publish this to or create a new one. And so now this code can be available to run in the cloud, right, at the URL that I decide. So if I actually switch back over here, you'll notice I've already published this same app ahead of time at jhollandblazor, and I've said /hello. So let's go ahead and test this out now that we've actually added some more custom code. We'll do the same thing, .NET run. It's going to compile this app, create the WebAssembly bridge, pass all those static content files over to my browser in just a second. And here, if we now open up localhost 5000 again, same data before, but you'll notice here's my new Azure Functions tab. And when I click this, you'll notice it says loading for a second. If you caught it, it said loading while it was making that call. And then as soon as it got the call back, it says the message is hello, right? So it called that function. The function returned some data. In this case, it was just a string, but I could very easily replace this with data from SQL as well. So for the last part of this, I want to show, now that I have this running locally, how do I get it so that it could actually be accessed from somewhere that's not localhost 5000, right? I mentioned before this needs to be in a storage account. So how do I go actually get this into a storage account? This is actually my favorite part of this entire demo because it could not be easier. So I'm in Visual Studio Code already. I mentioned before that I have the Azure Functions extension already installed. Let me show you one other, not task, sorry. Let me show you one other extension that I have installed. I have a lot of extensions because I love VS Code. In addition to the Azure Functions extension, I have the Azure Storage extension, which will let Visual Studio Code know how to talk to a storage account. And with this extension, I can actually get a one-click publish to a storage account. So first I need to generate the bits that I need to publish, right? So right now I've just been debugging. How do I actually generate the static content that I need to upload to the storage account? So if you're familiar with the .NET CLI, this next command I run is going to be very familiar. It's really just .NET publish. I'm saying publish me a release. This isn't for debugging anymore. I'm going to define my own output folder. In this case, just use the publish folder. I could use the default if I wanted to. And when I run that, it's going to compile my app as well. It's going to create a release profile for it. And it's going to stick it in this folder I just defined called publish. So if I come here, once this is done compiling, you'll notice I have a new folder called publish. And if I open up publish, it's got all of my bits here. Now you might be wondering, what are the files that I need to copy to my storage account? There's some web config, there's some DLLs here. The answer is right here. Do you see this dist folder for like distribution? This is the folder that I want to copy and paste into a storage account. You'll notice here's the index.html page. This is kind of the static content it's going to return. It's a pretty boring page. It just pretty much says load up all the amazing WebAssembly stuff. I've got some framework things here which have all my WebAssembly bits, my bin folder which has my DLLs. So this dist folder is the one that I need to get into a storage account. And I mentioned this was my favorite part of the demo because check this out. I'm going to right click this folder, and because I have that Azure storage extension, In VS Code, I have this one-click gesture right here, which is deploy to static website. Now, really all it's doing is it's just going to copy this folder and copy it into an Azure storage account for me. And it's going to configure the Azure storage account so that it can serve web content. So I could do this manually. I could do it through Azure DevOps if I wanted to. But for getting started, I really like to just say, you know what, deploy a static website. Here, it's going to ask me to either create a new storage account or select an existing one. I already have a storage account called jholland website, so I'll just say, you know what, publish to that one. And let's go ahead and tell it to deploy. And you'll notice here it's saying copying over those 49 files into the web folder of this storage account. So as it copies those files over, it just takes a second. Now, all those files have been copied, and here I can now go to jhollandwebsite.z5.web.core.windows.net. That's super easy to fit on a business card. But I can browse to that, and here I'm just hitting that storage account, and the storage account now has returned to me back all this static content that I've been able to render into this Blazor page, right? So this is no longer localhost 5000. This is now my storage account running in the cloud. In fact, if I come over here to my storage account, I can even open up this storage account. There's no magic here. Let's use this Storage Explorer preview. And here in my Azure storage account, this is just that dist folder, right? So all I'm pointing to is that I've configured this storage account to do, I'll show you all the settings here, static website hosting. So I've turned this on, which gives me a nice endpoint. And then Visual Studio Code went and copied all my files into this folder that it creates for web hosting. And all that's happening is my browser makes a request to this domain, and my storage account returns back this index.html that it can use to render the page, right? So no server anymore, just storage. Now, the last thing I want to talk about, again, I'm not in localhost anymore, but I'm not really at a nice domain, right? I'm at jhollandwebsite.z5.web.core.windows.net, and all of you can browse to this and it will work, but it's not the kind of website I want for a blog, right? If you remember, the one I actually wanted was jeff.holland.dev is the actual web page I wanted, right? And you'll notice here, when I go to that, I actually do have jeff.holland.dev set up, calling my Azure function, and it even has a beautiful certificate so that it's HTTPS enabled. So the last thing I want to talk about is how did I pull that part off, right? How did I actually get the storage account to be able to use with a custom domain like holland.dev or jeff.holland.dev? So the other aspect here, if you're going to go set this up for yourself, and there's some great docs and samples as well, is that in Azure, I have a few resources that are helping me out. For one, I've hosted my DNS records inside of Azure. So I have holland.dev as a registered domain in my Azure account. And I've actually told it, and I apologize, my zoom here is a little bit aggressive as I've been zooming in and out. I've actually told it that when I go to holland.dev, I've configured this to route to Azure Front Door, right? So Azure Front Door is a kind of like a CDN++ service for Azure. I could also serve this directly from a CDN, but I like Azure Front Door for a few features that it provides. I've even had some other C names here too, so I can go to like jeff.holland.dev or functions.holland.dev, which will call my functions. So I have some DNS here, and then I mentioned the Azure Front Door. This is the thing that gives me custom domains, right? So at my Azure Front Door, which is kind of the delivery network resource, I've told it to serve resources for requests to holland.dev, to jeff.holland.dev, to functions.holland.dev. I've set up some routing rules here so that it will redirect always to HTTPS. Front Door gives me free certificates. I've also redirected it, so if you just go to holland.dev, it's going to reroute you to jeff.holland.dev because I'm vain and I want my full name in the URL and not just my last name, right? So there's a few other helper resources that if you're starting to build these architectures, again, that resource group I was showing you here, this is all I needed. So I have my function app, I have my DNS records, I have my Azure Front Door, I have application insights to monitor the health. And that's really everything that I need to get started in hosting my new Blazor apps. So hopefully you get a sense for how you can get started using tools like Visual Studio, Visual Studio Code, create a serverless Blazor app. And while this is fun for things like blogs, maybe where I'll finish too, is we also see people using this for bigger scenarios, right? So one of the things, I'll leave this page up here on learning more. One of the cool scenarios we ran into actually about a year ago is we had a large retailer who was running a massive promotion. They needed to be able to serve like 10,000 requests a second because they were going to be giving a huge, huge deal. And they were worried because their website traditionally was this massive WordPress site. And they're like, it's really hard for us to scale that out to handle 10,000 requests a second. So what they did is they took just the page that was going to be hit with the promotion. They made that page into this serverless web architecture where they had Azure CDN, they had storage, they had functions. This was before Blazor, so they were using JavaScript, but the world still lives the same, like the truth are there. But they were able to run this massive promotion. This page scaled incredibly elastically. They only paid for the number of hits that it had, and the rest of their site could go be happy as a WordPress site. So this is a really interesting pattern to be aware of. I'd encourage you to try it out for your own blogs, or even if you want to try aspects of your website as a serverless web architecture. As I mentioned, if you want to learn more about Blazor, check out blazor.net. There's templates and getting started docs there. Functions pair great with it for the server code, so azure.com/functions. And thank you all very much for joining. We'll see now, Seth, if we have any questions that have come in along the way.
We do actually have some questions.
I'm glad.
By the way, well done.
Thank you.
I'm always impressed. This dude's such a good presenter. Let's start with this. Are you ready? No matter what you use with Azure Functions, is still one of the coolest and most amazing techs. I just wanted to lob one to you.
I was going to say, is this my own tweet? Did I tweet some love
Adding
about
Blazor
functions?
to it levels up the cool factor. It's good to be cool, every once in a while. At least it was for me that one time. Now here's a serious one because I wanted to lob one to you, and now it's a little bit a harder one. Jeff Holland, doesn't infinite scalability also mean infinite cost?
That's a fantastic question. It can mean infinite cost. So one of the things with functions that is fantastic is that you can scale per request, but there's a term you hear in the serverless sometimes called a denial of wallet attack, where if you just hit this, if someone actually did a DDoS right now on jeff.holland.dev, you might rack up my bill a lot. So one of the things that we allow today only in some of our more premium tiers for Azure Functions, but as a way to kind of set caps so that you can be like, look, I want to have this be serverless, but I never want to be paying more than whatever, $500 a month. So something to be aware of, things like API management are also paired often with functions so that you can do things like rate limiting and throttles. So it can mean infinite cost. Even then, it's whatever, 0.00054 cents per request, but it is something to be aware of.
Yeah, but if you're racking up that many calls, your website is probably racking in more.
Exactly
you,
right. You better put some ads on that Blazor page.
All right. So last question: when will .NET Core 3.0 be supported in Azure Functions?
Yeah, this is something we're really excited about. So we actually made an announcement on GitHub about 2 weeks ago. In October, so in a few weeks, we'll have a preview of writing Azure Functions in .NET Core 3. It'll become generally available around Q1 of next year. So keep an eye out for where you can start using that, where we'll rewrite our entire host and let you write code that takes full advantage of .NET Core 3 and Azure Functions as well.
So I said that was the last question, but I lied because people are putting them in and questions are important. A question about this tutorial: will this tutorial be available for people to look at?
Yes, so right now it's scattered in a few docs. I'm actually working right now with the Learn team to try to turn this into an actual step-by-step tutorial. So there's a few docs both on the Blazor page that talk about static hosting and the Azure Storage page that talk about this. Obviously it's a recording. I kind of did everything step-by-step. So it is there. It's more scattered than I'd like it to be. So one of the things we're doing before Ignite is turning this tutorial into an actual module that people can follow step-by-step.
So for me, I did an Azure function the other day, and I thought of you the whole time, and I even wrote it in Python.
Whoa!
It was super cool and all in Visual Studio Code. But one of the questions that I have, and my friend here, J-Paul, also has, is how authentication and authorization will work in Blazor and Azure Functions in general.
Yeah, so Daniel mentioned this a bit before. Azure Functions has a few features out of the box to help with authentication. There's something called App Service Authentication that can automatically do like Azure Active Directory validation. Generally what we see in these types of scenarios is kind of the OAuth type flow where the client makes a call, it generates a token, and it just passes that token along to the function. And then it's up to either the function itself in code, or as I mentioned, some features like app service authentication or API management that can do the validation outside of your code. So definitely look at OAuth tokens and that OAuth flow, and there's even some wonderful .NET libraries to make that even easier. That's the pattern I would recommend.
Here's another question. Can HTTPS server for Azure Storage be configured to be case insensitive? Do you know that one?
I thought it was.
I mean, I
if
thought
I type in capital jeff.holland.dev,
which is how I type it in.
it still gave me HTTPS. So
Yeah.
I don't know. Maybe there's a gap here. If there is, just send me a tweet directly, and I'll make sure to pass it along. So.
Fantastic. So for those, and I know you probably mentioned this, and I just sort of on the slide mentioned Python. What languages can you write these serverless functions in?
So C#, F#, PowerShell,
What?
Python, Java, and JavaScript.
Did
So
Jeffrey
those are the ones.
did Jeffrey Snowbird like show up one day?
He
and was
says
like,
that he writes PowerShell functions, and he says the same thing. He thinks about me the whole time when he writes them. So I hope all of you, whenever you're writing a function, and you're happy or sad, keep me in your mind. I'll help where I can.
Fantastic. Thanks so much, Jeff. And by the way, all of you, get your questions in as early as possible. If you think of it during the session, just put it in. Just a couple of stats before we go to my good colleague. The people that have been watching the most minutes happen to be Trinidad and Tobago, 265.28 minutes on average. And I'm wondering who's that one person that's like, I think I'll watch for 0.28 minutes. It's probably me. And now, without further ado, we have here my colleague Zach talking about DevOps for the .NET engineer. Let's go to him.
Hey everybody, my name is Zachary Deptawa. I'm a cloud advocate for Microsoft, and I'm excited to be here today. I'm talking about DevOps for .NET Core devs, so let's just jump in. So what is DevOps? We've often thought, do we actually need DevOps? Is it a question of, is this something that we should even be focusing on now or in the near future? Well, we know now that you absolutely need DevOps. It's critical for businesses to innovate at the speed necessary in today's world. And if you ask people, what is DevOps? If you ask 5 people, you'll probably get 10 different answers. And so I can tell you what Microsoft's view of DevOps is. DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. And notice I didn't say continuously deliver code, I said continuously deliver value, because if I just continuously deliver code, I can push it up in a source control, but I end up with a mountain of code somewhere. Unless it's delivering value, it's not really worth anything. So why is DevOps important? And this is a big one. So if you're not currently using DevOps best practices, I can guarantee you your competitors either are or they're going to be very, very soon. And so what that means is your competitor will be able to out-innovate you. They'll be able to do things at a much quicker pace than you can, and that might make you obsolete. And nobody wants to be obsolete, believe me. All right, so we always thought about this DevOps thing, right? We've got some manual processes. We're going to start to automate them. Things are feeling good. It's kind of a theory right now. Let's get things going. But now we have actual data. We can see the empirical data that says that companies that use DevOps actually innovate much faster than companies that don't use DevOps. And it's not just by a little bit, it's by a lot. And so when we think of DevOps at Microsoft, there's really 3 pillars that you need to pay attention to. And number 1 being people, number 2 being process, and number 3 being products. And we'll dive into those a little bit here. So admittedly, the hardest part of all of this, of adopting DevOps best practices, in my opinion, is the people. And people, they're averse to change, but not only that, you have to have this idea of continuously delivering value to your end users from the very top of your organization to the very bottom. Everybody has to be in line saying, yes, we want to continuously deliver this value to our end users. And that's really going to be the hardest part, is making that shift. The process, now that's a little bit easier, because really all the process is finding something inside of your organization, inside of your team, that works for you, that allows you to innovate quickly, but also allows you to maintain a high standard of quality for your applications. So that's probably the easiest of all 3 of these. And now let's talk about the products. So this is where you're going to find things that will help you use the DevOps best practices and methodologies. You need products that will help you plan and track. things like work items, bugs, impediments. You need things that are going to allow your developers to push and pull from source control. But not only that, that will tie back to that planning and tracking so you can see where your work is actually making an impact. And you also need something that's going to bundle up your code for you automatically. So your devs should be able to push their code for testing and have something fire off that's going to bundle that up and push it out into a testing environment for you right away. And after you have everything into production, it doesn't stop there because you need to monitor and watch what's actually happening inside of your application. You need to know, is your application up? Is your application down? How are the response times within your application? And you need to be able to see what your users are actually doing inside of your application. I don't know how many times I've talked to clients that say, you know, we built this app to do this thing, but our customers are using it in a much different way than we thought that they were going to use it. So what that data allows you to do is you can look and say, yes, we're absolutely delivering value, and that's great. Now we can double down on this and we can move forward in our next sprint and do way more cool things for our end users that will deliver value. And if you're not delivering value, that's awesome too. You see that data so you can pivot and make sure you deliver value on the next sprint. So all of these things, right? There's a ton of tools that can do all of these things. And these are all great tools. You can pick and choose these tools that will fit what you're doing. You have to make sure these tools can communicate. You have to make sure that there is no problem with that communication. And you have to make sure that it's set up accordingly. And they work great. Or you could replace all of these things with something like Azure DevOps Service. You can target any language, targeting any platform using Azure DevOps, and that's what we're going to talk about today. So what is Azure DevOps? Well, at a high level, it's a suite of 5 products. Azure Boards being the work item task tracking management. You can track bugs, impediments, features, things like that. Azure Pipelines being the Git repository system for private Git repos inside of Azure. Azure Pipelines being the CI/CD portion. This is the build and the release portion. This is the automation. Azure Repos being the private Git repository portion. Azure Test Plans is the testing infrastructure inside of Azure DevOps, and Azure Artifacts is the artifact repository inside of Azure DevOps. And so that's great. That's a ton of talking. I got it out of the way as quick as I could. Let's jump into a demo and see this in action. So what you're looking at here, this is a .NET Core app that I have deployed. It's an actual app that's running. You can actually go to that if you want to. But what it's doing, this is an app that simply tracks my exercise and it tracks my nutrition for me. But what I noticed, actually what my coworker Abel noticed, is that for some reason, we're tracking the color of our food. And honestly, we don't care about what the color of the food is. We just care about the important information. So we have this board here inside of Azure DevOps. This is our .NET Conf demo project, and this is our board. And you can see our tracking here. We have in sprint swim lane. We have a super duper important swim lane. And you can see we have a bug here for food tracking should not track color. So this is really awesome. I'm actually hosting the code inside of Azure Repos here. So what I can do, I can click this little button here, create a new branch. I'm going to call this food color tracking, if I can spell. There we go. And it's going to be based on the .NET Conf demo repository and the master branch. And what's really awesome is because I built it from that work item, from that bug, it actually links right to it. So I'm going to create this branch, and it's going to link from my work item to that branch. So now on this branch, that work item is there. So now I have a new branch, food color tracking. Let me drop over to PowerShell. And this is just normal Git stuff that I'm going to be doing. I'm going to do a Git pull because I just created a new branch. I'll do a Git, if I can spell. Oh my goodness. Okay. Check out and not that. Okay. Git, I can't spell today. Okay, there we go. Now we're back on track. I checked out the food color tracking branch. And so now that I have that checked out, let's actually go edit the code. So I don't care about this color field in my database. I'm going to delete it inside my SQL file here. And I'm going to save that. I need to comment some stuff out here really quickly. I don't need these things. Okay. And I'm also going to comment out here as well. Let's get this commented out. That's not necessary. All right. So now that I've made these changes, I'm going to save this. If I go back over to my PowerShell, I see that I've changed those 3 files. So I'm going to do normal commands, a git add. I'm going to do a git commit -m, and this is just going to set a commit message for these changes. Food color tracking removed. And I'll do a git push. So what this is doing is I'm actually pushing the code that I just changed into my food color tracking branch into Azure DevOps repos. So now if I go back over to my repository and I refresh, Azure DevOps, the repos, it actually saw that I updated my food color tracking branch, and it says, hey, you just updated this. Do you want to create a pull request? Well, if I wasn't done with my work, I wouldn't create a pull request, but I am done. This is all the work that I need to do. So I'm going to click create a pull request. It pops it up for me automatically. I'm going to be merging food color tracking branch into master. That's great. The title and description are pulled from my commit message, and you can see that my food tracking should not track color bug is actually attached to this pull request. I didn't have to do anything. And you can see my changes here that I made. Everything looks good. Let's create this pull request. And boom, I've got a pull request. I can check out the files here and take a look. But not only that, I can make comments. I can say in line, this is the best code I've ever seen, which is totally true. I can hit comment, there's the comment in line. And now, if everything looks good, I can go ahead and approve this. Now, in the wild, you probably don't want to approve your own pull requests, but for the purposes of this demo, I am. So what's really awesome is inside of Azure DevOps, I have a build and release pipeline, and I have it set for continuous integration. You can see this little blue here. That means that it saw that I made a change in my master branch, and it kicked off my build automatically for me. And this is happening in real time. We're actually watching these tasks run in real time. But even after the fact, I can drill in and get a look at what happened if I need to go back for troubleshooting or just want to see what happened. While this is running though, let's take a look at what a build is actually comprised of inside of Azure DevOps. All right, here we go. So this is a build. You can see that we're getting the source. This source we're pulling from the Azure repo that I have, .NET Conf Demo from the master branch. I could pull it from another source if I wanted to. And also, this is an agent-based task runner. So what's happening is I'm running tasks on an agent. These are the tasks that I'm running. But what's really cool is you can use a hosted agent that's hosted inside of Azure, or you can run an agent anywhere you want to run it. I'm actually running my agent on my demo server. And that's just something that you can do if you'd like to do that. But you can see because this is an ASP.NET Core app, I'm using NuGet, building the solution, testing my assemblies, copying my DAC pack, and I'm going to publish this to an artifact. And this artifact is what will be used in the release. And you can see my build finished. So let's go ahead and take a look at this artifact real quick. So now that the build finished, here's the artifact. I've called it drop. And you can see I've got my DAC pack and I've got my webapp.zip. I've got everything that I need for my release. But not only that, because I have continuous integration and continuous delivery set up here, it's already kicked off my build into my development environment. And that is so powerful. I didn't have to do anything besides make that pull request and merge it. So let's take a look at releases real quick. So the way that I view releases, you can set up stages in such that you have one for each environment. So I have a development environment, a staging environment, a production environment, but you could do this in any manner that you want to if you have a different way that you like to set that up. You can also have stages that run in parallel with each other if you need that. You can see that we're using the artifact that was built, and also I can drill in here, and just like my build, I can watch this happen real time or go back and look at the logs if I need to. While this release is happening though, let's take a look at how a release is created and how a release is set up. So you can see that each stage has jobs and tasks. And for each of my stages, they all look the same, but it's the same kind of setup for my build. So this is a task runner that runs on an agent. It can be hosted in Azure again, or it can be hosted on an agent on a server like I have here for my demo. But I'm deploying my Azure App Service, deploying my database, and running Selenium, and that's the gist of my releases. Let's take a look and see where we are. Okay, so my release finished to development, but you notice it's blue here. It's not green. It's kind of weird, right? Let's take a look at what's going on. Aha! So I set up a post-deployment approver required. So now that this has kicked off, it's done my development deployment, I have an approver that's required to say, yes, everything looks good, I've tested it out. Let's go ahead and roll over to our staging environment. So I'm an approver, so I'm going to go ahead and approve this. And I can say, looks good to me, approve. I could also reject if I wanted to, but everything looks good. So theoretically, that should have kicked off my build, right? Let's take a look. I'm sorry, my release to staging, but it looks like it's hung again. So what's going on here? I set up a pre-deployment approver as well. So yes, someone that looked at development, made sure everything was fine, they were able to approve that, push it over to staging, but now someone from staging needs to go and take a look before it blasts that code into my staging environment. So whoever is managing that environment can go and say everything looks good, but not only that, if everything looks good, they can also defer the deployment for later. So say somebody like me decides I want to push code at 5 p.m. on a Friday, which is not the best idea. Well, it can roll out to development. I can even accept that in my post-approver acceptance here, but it won't blast into another environment until somebody from that environment can take ownership and accept it. So that's really awesome. I'm just going to go ahead and approve this though. And now it's in progress and it's rolling into my staging environment. So you can also set this up to where it's manual only. You don't have to do an automatic release if you don't want to, but that's just how I have this configured. So this is all really cool, but I want to show you kind of a neat trick here. And actually, you know what? Let's make sure before I do this, let's make sure that my changes are working. There we go. The color field is gone. So my changes look good. Not only do my changes look all right, but if I go back to my boards, that bug that I was tracking that I opened this branch for, because the branch closed and in that pull request, it actually resolved this bug for me. I didn't have to come here and do any of this. It just moved it right on over. So that's awesome. And it's also tracking that. If I drill down into this bug, you can see that it actually tracks what happened with this work item. And so now that looks all great. But let me show you something awesome. So I'm just inside my Azure portal here, and I'm going to click Create a Resource, and I can click on DevOps Project. Now what this does is this actually scaffolds out an entire DevOps, an Azure DevOps project for you. So you can see all the different languages here that we have built in. You can bring your own code if you'd like to. I'm going to click .NET and ASP.NET Core. I'll add a database. Let's go ahead and use Windows Web App. And let's name this .NET Conf Demo 9. We'll go ahead and choose an organization that I have access to. And I can change the location here. Let's go ahead and put this in East US. There's also some additional settings that I can set. I can change where my application insights are. And I can change where my database lives as well. I'm going to put them all in East US just because. And here we go. I can click Done. And now what this is doing is super powerful. This is actually building out my Azure DevOps project for me. It's building out my repository, it's building out my builds and my releases all for me, and it's actually going to do a deployment. Now this takes a few minutes to set up because there are several moving pieces and it is doing a deployment, but I have one that's pre-baked right here. And so you can see when it's done building, you have your CI/CD portion. This is the DevOps portion on your left side. You can see your Azure resources on the right side. But what I find really cool is you can go into these, and these are deep links into Azure DevOps. So if I click here, this will throw me right into Azure DevOps, into this project. And now I can see that it actually gave me an ARM template for what it deployed. I can see my application here. I can fork it, I can clone it, I can do all the things that you would normally do with a Git repository. And that's awesome. And I can see, I can drill right into the build, I can drill right into the release, and I can also hit the application. This is a live application. This URL will work for you as well. It's just a demo application, so it's nothing robust, but it is an application nonetheless. So something else that I want to mention that's really cool, you can build this scaffolding, right, using a DevOps project inside of Azure inside of the Azure portal. But once you have that built, this is an ASP.NET app, that's all it is. So I can go in here and take all this code out of my repository, push up my ASP.NET Core app, and have it deploy automatically to my testing environment. And that gives me a quick and easy way to test this without having to set up all the bits and pieces myself. Not only that, if you don't want to mess with this repository, you can actually go to your builds here. And this is just a normal, just like the other build that I showed you is a hosted task runner. And my sources are right here. So I can change the source here that my build is actually pulling from if I want to. So you can set this up, you can change out your source, or you can just change out the information in your repository, and you are instantly or almost instantly working with a fully DevOps project. And so that's really powerful. I implore you to go check that out and try it out. But yeah, so my work here is done. Let's go back to this. And that's all I have for you. If you want to connect with me, I'm on Twitter. I'm a cloud advocate, like I mentioned, and I'm at zdeptawa. And here's some good links if you want to take a screenshot of this or a picture of this. Make sure to follow at Azure DevOps for the latest information. And that's it. Thank you so much.
Okay, awesome. Wow, that was great. Thank you so much. So we have some questions here on Twitter. Let's see which ones we have. All right. Let's see. Oh, look, somebody already here is actually like already using it. So that's pretty sweet.
Nice.
Yeah. And let's see. Here we have a question. Why Azure repos and not GitHub? I guess what are the pros and cons between the two? In your opinion?
Yeah. So with Azure repos, it's using the Git protocol. So you can actually host on GitHub if you want to, and you can use it as your source. So you don't have to host inside of Azure repos. But if you are using Azure DevOps, you are linking into all of your Active Directory configuration. If you have that, that might make things a little bit easier. But it's really up to you. We don't want to force you to use Azure repos. We want you to use what is best for you, basically.
Sweet. All right. And then we have another question here. Hey, Zach, how can you tell in a pull request that inline comments have been made?
Let me take a look at that. Let's go back to my pull request. That's something that I haven't actually looked at, but it should show you. Let me see. Oh, I'm on the wrong build here. It should actually show you here in the pull request, if I can get to that. Here we go. So I'm opening up this pull request, and you can actually see this little icon here. It tells me that I have an inline comment, and you can see that comment right here.
Oh, awesome.
Yeah.
Okay, great. Yeah. And we have another question here. Any plans of adding features to enable Azure boards to be used as a help desk ticketing system? So for like external party access interface to raise tickets, built-in automated ticket creation via email or other sources.
Honestly, I'm not sure. That's a question that's best posed for the product team, and I can actually take this question back and figure that out and get back to you. So that's no problem.
All right, awesome. Yeah, definitely. Let's see. There's a lot of questions here. Let's see this one. Can we specify the version number of the release on Azure DevOps, or should we modify the CS proj and something similar for release notes?
So this, I'm actually not sure of, to be completely honest. I'm brand new to ASP.NET stuff, but I've been given permission to say reach out to Abel Wang. It's Abel Squidhead on Twitter. He can actually give you...
It's a great name.
Yeah, he can give you all the information. Abel's an awesome guy who works for Microsoft as well.
Okay, sweet. And, oh, look at this. Right here, we have some people watching from Germany. So that's pretty awesome. And let's see what else we have. Let's see here. All right, it's another .NET question, but aside from writing custom tasks, do you know of a way to loop over a set of tasks during your deployment? So deploy to several servers, and for each server copy file, stop an old version, start new version.
Yes.
Do you know the answer to that one?
Yeah, for sure. Yeah. So if you're going to deploy to several servers, let me pull this up really quick because this is actually pretty cool. We have this concept of deployment groups, and I didn't get into this. It's great for another video, and there are actually videos that we've done on this before. but you can create a deployment group that says, here's my development or my production or whatever you want to call your deployment group. You can build that out, and you can create agents. You put agents on your servers, Windows or Linux, that will allow you to deploy to those, and you can deploy to them in parallel. So 2 servers, 10 servers, 50 servers, it doesn't matter. You would want to use deployment groups for that.
Okay, sweet. We have a couple more questions, just real quick. Here's another one. Can I have an Azure DevOps deploy my Java artifacts to a Tomcat server?
Yeah, definitely. And if there's not a task that's already built, I actually failed to mention that. Let me show that really quickly as well. There's so much information and so many cool things you can do in here. These tasks are just basically, I mean, they're just tasks. These are first-party tasks that we built, but you can add a task to your agent. There are hundreds of built-in tasks that you can add. But not only that, if you can't find anything in here, there's a marketplace with, I think, over like 1,500 tasks. But not only that, it doesn't, but yet, wait, there's more. You can write your own task. It's just Node.js or PowerShell. So yeah, most definitely you can do that.
Cool, yeah. And then any way to filter PRs by labels or tags?
I'm honestly not sure. That's something that I'll have to check on and get back to you. I imagine you can, but I'll have to double check.
Okay, awesome. So we're gonna go and view some commercials right now. So thank you. Thanks again, Zach.
Thanks.
Another clue for you, this time from the folks at Gnostis. And they say the answer, dear developer, is only 2 documents away. Start here and go where the clues lead you. Follow those clues, find that secret password, that secret passcode that you're looking for, whisper your response to the .NET bot in the Visual Studio Twitch channel, and you could be well on your way to the next step in our technical treasure hunt.
Hello everyone, and welcome to this series on ML.NET, a machine learning framework for .NET developers. My name is Pranav Rastogi, and I'm a program manager on the .NET team focusing on making machine learning approachable to .NET developers. In this series of videos, we'll be looking in depth at ML.NET. Let's start by understanding what is machine learning. Machine learning is all about programming the unprogrammable. Let's say in this case, we want to write a function whether this picture is an image of a dog or not. Machine learning will help us figure out whether this image is a dog or not. Some other examples of using machine learning are, let's say I want to predict a price of a house. A price of a house can depend on a variety of features such as how many rooms does the house have? Does the house have any special amenities like a pool? How big is the yard? And all these features will determine what the exact price of the house is. Now, traditionally, let's say we had to write a program to detect whether this is a dog or not. What we would have done is we would have looked at images of dogs and cats, and we would have looked at certain characteristics like how large are the ears, do they have a tongue, how big the tongue is, and we would write this program ourselves, taking care of all the possibilities to figure out whether the image is of a dog or a cat or not. These are some example images that I would have looked at to figure out how to make the program understand whether this image is a dog or a cat. So I'd be looking at cat pictures, I'd be looking at dog pictures, I'd be looking at different examples of all these images and trying to write a program by myself. But with machine learning, all of this becomes much more simpler. Machine learning allows a program to learn from a set of data to figure out what are all the characteristics of a particular problem. So in this case, what defines a dog, what defines a cat? The machine learning program will look at different images and see, all right, how big is the mouth, how big is the tongue, does it have claws, does it have whiskers? And as it trains on more and more data, the machine learning program will become more smarter and smarter in terms of figuring out whether this image is of a dog or a cat or not. And in the end, what you would have is a program that you can call to figure out what type of animal is this. So machine learning is really about programming the unprogrammable. What this allows to do is it allows you to write a function which trains on a set of data to figure out whether this picture is of a dog or a cat. And the machine learning model that you get is trained on lots of these images where it learns about different features, whether how big the mouth is, whether the cat has claws or not, whether the cat has whiskers. And so you don't have to write all of these constructs yourself. The machine learning program looks at all these images and learns, and then it gives you a function, which is a machine learning model that you can use in your application. Such advancement in machine learning has opened many possibilities where you can use machine learning to train machine learning models over data which is of different kinds. You can train machine learning models to detect audio, to recommend, for example, new music that you would like. You can use machine learning on text-based scenarios, so you can do things like sentiment analysis, sales forecasting, movie recommendation, anomaly detection. You can use machine learning on images, so you can classify images, whether it's a cat or a dog. You can detect objects in an image, so you can effectively build a greater user experience for online cataloging. And then machine learning can also be used to teach machines itself so they can be much more smarter. In this video, we looked at the basics of what is machine learning. In the next video, we will take a look at ML.NET, which is a framework for building machine learning models for .NET developers.
Hello, everyone. Welcome to Bringing Big Data Analytics through Apache Spark to .NET. I'm Bridget Murtaugh, and I'm a program manager here at Microsoft on the .NET team. So let's start off with what is Apache Spark? So big data means that there's an increasing volume, velocity, and variety of data. So let's take, for instance, a factory. There can be thousands of Internet of Things sensors in a factory, each producing petabytes of data. Now, while it's great to have that much data so we can understand how our factory's performing and ways to improve the equipment, how can we actually process it all when we have that much? And more than just that, how can we process it all quickly and efficiently? Well, welcome to the world of Apache Spark. So what is Apache Spark? Apache Spark is a general-purpose distributed processing engine for analytics over large data sets, typically terabytes or petabytes of data. Put a little bit more simply, Apache Spark is a great tool we can use to analyze a large amount of data in a quick and easy to understand way, so we don't have to be data science experts to understand or use it. So there's quite a few different things that we can do with Apache Spark that are all super interesting and exciting, but just to touch on a few of them, one of them is Spark SQL, which means analyzing data that's structured in some way, so maybe data from a CSV or from a database. There's also Spark Streaming, which means analyzing data in real time as it's being produced. So in our factory example, it means analyzing data live as it's coming from those IoT sensors. So we can go and detect maybe if there's a malfunction in our data, and we can go and address it right away. There's also machine learning capabilities with Apache Spark. So you can combine the powers of big data and ML to scale and have faster, more efficient training and prediction of machine learning algorithms. So to understand how Apache Spark works, there's only three main components that we really need to take a look at. The first one is the driver. So the driver consists of the user's program. So for instance, if you wrote a C# console app, that would be part of the driver. The driver also consists of a Spark session. Now what the Spark session does is it takes that user's program, so for instance, it takes that C# console app, and it divides it into smaller pieces known as tasks. Now those tasks are divided amongst our second component, which are the executors, or the worker nodes. And the executors or the workers are on something known as a cluster. So each of those executors takes one small task, so one small piece of our user's program, and finishes executing it. And the third component of our architecture is the cluster manager, which helps with dividing up the tasks and allocating resources amongst our driver and our executors. So how can I use Apache Spark? It sounds super great, super useful, so how can I get started with it? So there's different APIs that we can use that are popular with Spark. And they're written in languages like Scala, Python, Java, and R. But up until this point, there weren't any .NET APIs for Spark. So what if I wanted to use Apache Spark combined with my pre-existing .NET knowledge or extensive code base and business logic? Well, we now have an awesome tool that we can all use, and it's known as .NET for Apache Spark. So .NET for Apache Spark is a free, open source, and cross-platform big data analytics framework. It allows us to reuse the knowledge, skills, and code we already have as .NET developers. So anywhere that you maybe have an extensive C# or F# code base, now you can go ahead and introduce big data analytics within it. .NET for Apache Spark is also designed for high performance. The overall goal for .NET for Apache Spark is to provide .NET developers a first-class experience when working with Apache Spark. So we have had several customers express a lot of interest and actually see success with .NET for Apache Spark. And one of them is the Microsoft Search, Assistance, and Intelligence team, who's working towards modernizing workspaces in Office 365. Their job is to work with different ML models on top of substrate data to infuse intelligence into Office 365 products. Their data resides in ADLS and in turn gets fed into their models. Why they were looking towards .NET Spark was because a lot of their business logic, such as their different featureizers or tokenizers, were all written in C#, meaning it would be ideal to be able to use big data analytics still within the .NET ecosystem. And so far, their experience has been extremely promising, stable, and they've really loved the vibrant, open source big data analytics ecosystem within the .NET community. The scale of their jobs has been about 50 terabytes, so quite a bit of data, and they've really started seeing success with it. So now that we've seen a little bit about what .NET for Apache Spark is and why it's such an exciting new solution for us, let's take a look at a few different scenarios that we can complete and some really exciting applications we can build using .NET for Apache Spark. So one of the most fundamental big data apps is batch processing. So what is batch processing, or what is batch data? Batch data means that we're working with data that's already been stored. So for instance, we could be doing something called log processing, which means looking at and gaining insights from logs from maybe a website or a server or a network of some sort. So we can understand what actions our users are taking or what pages of our website are the most popular. We can also do data warehousing, which means taking in data maybe from a variety of different sources and then performing a large-scale analysis on it. Maybe that data is all stored in Azure Storage and then gaining different meaningful insights from it. So in the example that we're going to be looking at today, we're going to take a look at some GitHub projects data. So you can see here in the snippet of that data that our projects data includes the URL of our projects, the author, a description, what language it is, things like that. And we want to know, on average, how many forks does each language have? And the number of times each project has been forked is represented by that column H there. So let's go ahead and take a look at our first coding example with .NET for Apache Spark. So I'm going to open up Visual Studio 2019 here. And we can see here that I'm just dealing with a C# console application that I've already created, and I've already installed the Microsoft Spark NuGet package. Oh, there it is. Cool. And we can see that it was also installed because I have these great jar files over here in the Solution Explorer. And at the top, I'm using Microsoft Spark SQL and Microsoft Spark SQL Functions because, as I had mentioned, Spark SQL helps us work with structured data. So if I'm reading in GitHub projects data, that data does have some sort of pattern or structure to it. So I want to use Spark SQL. So to start off with, in my main method here, the way that we start off any .NET for Apache Spark app is by creating a Spark session. So that's what's dividing our program into those smaller tasks to be distributed amongst the executors. So we can see I've created a Spark session called Spark, and I went ahead and built the session, and I just called my app GitHub and Spark Batch. Pretty appropriate name. Now, after doing that, the next step we typically want to do in our apps is to actually read in our data. So I have our data stored in a CSV, and we want to read that CSV into an object called a data frame. So a data frame is going to be the basic object that we store our data in when we're working with structured data in Spark. So if I open up this region here, we can see that I'm working with a data frame here, and I just called it projects.df to stand for my projects data frame. I go ahead and called the read method, and then I also call schema, which means that I'm working with whatever pattern my data has. So for instance, I know that my data has an ID column, a URL, an owner ID, and I also know the type of data that's stored in there, whether it's an int or a string or something like that. And it's a rather long schema because I do have quite a few columns. And then I can call .csv since I know that my data is stored in a comma-separated values file. And then another popular method that's good to use is .show, which allows us to actually print that data frame to the screen. So if I continue on, another popular step that we'll want to do when working with batch data is to do some data prep or data preparation. And that means that we're kind of cleaning up our data. So maybe if there's some null or missing values, or if there's some extra values, maybe like a few extra columns we don't need, we can go ahead and remove those so that our data is easier to read and easier to work with. So one of my first steps of data prep was working with the data frame NA functions. And with that, I chose to drop any values that are null. So any rows that have missing or null values, I chose to remove, so that when I go and perform calculations later, I'm not accidentally trying to perform calculations on a missing value. Also with my data prep, I chose to drop a couple of columns that I don't think will be important for my final calculations. So I dropped the ID, the URL, and the owner ID columns. So after doing some data prep, we can actually go ahead and perform the functionality that we wanted to, which was finding, on average, which languages have been forked from the most often. So the first thing I wanted to do was group my projects by language. So what I've done here is I've created a new data frame that'll represent now my grouped data. And I called the grouped by method, which allows me to choose which column of my data I want to organize by or to group by. So I chose the language column. And then whenever I do a group by, I also need to call aggregate, or this .agg method. And with aggregate, it allows me to perform some sort of functionality across every row or every entry of my data. So in my case, I performed the average of the forked from column on each row of data. So essentially, I'm grouping by language and then finding on average how many times each language has been forked. And then finally, I don't want to just display my data as is. I want to do one final step to make it a little easier to understand and read. So I've chosen here to order my data frame in descending order. So that way I have the top forked languages at the top of my data frame, so I can see those first. And then a final good step to do is to go ahead and stop our Spark contexts. So I went ahead and called spark.stop just to clean up resources and make sure everything finishes executing correctly. Okay, so now I have a few steps here that I'll need to be able to build and run my program. So one of the steps when working with the .NET for Apache Spark app is to make sure that we have one of our environment variables set correctly. So there is a .NET assembly search paths variable, and we'd want to make sure to set it to specifically my app, so in this case batch, and then the bin, debug folder, and then whatever version of NetCore app that you're using. And then also, one other thing you can check is the level of logging that you have in your output. So if I go ahead and open this up, so there's a file called log4j.properties, and here I've set the logging level, or whatever is going to be output to my console, to be the error level. So rather than displaying maybe some extraneous warnings or info or debug messages, I'm only going to display messages that are actually an error, which will help make sure that my output isn't too confusing or crowded in my console. So now it can actually be time to go ahead and build and run our program. So fortunately, I've already done that for us here to save some time. So I'm going to open up the terminal. Oh, not that one. That one will be later. Okay, so here I moved into my batch directory using cd batch, and then I just went ahead and built my project using .NET Build. We can see that build succeeded. So now let's go ahead and see how we actually run a .NET for Apache Spark app. We use something called Spark Submit, or the Spark Submit command. And every time we use Spark Submit, there's a few different components to it. So we say spark-submit, and then we're also going to reference the .NET runner. We're going to specifically reference one of those jar files. In our case, we're using Apache Spark version 2.4 and .NET for Apache Spark version 0.4.0. And then also we want to have a path to our app's DLL so it can actually build and run correctly. So after running Spark Submit, let's see how our program did. So first, we're expecting just to see the data frame with our CSV data in it, so just the raw GitHub projects data. So let's take a look. All right, so we can see it here. We see that it has all the columns we expected, but we can also see that the data is kind of overlapping with itself. There's a few too many columns, like updated at is all the way over here instead of continuing to the right. And then there's also a lot of null and missing values. So it seems like it was definitely a good idea to go ahead and do that data prep we did. So if I scroll down, now we can go ahead and look at our data prep result. And so now this data frame is a lot easier to read and understand. We can see the data doesn't overlap with itself, and all of the data actually exists. There's no longer all of those null values. So it's a lot easier to work with. So next, we can go ahead and see the output of when we were trying to calculate the average number of times each language has been forked. So let's take a look. And so we can see we have a column here for language, and we have a column here for the average number of times it's been forked, and it all looks correct. And we can see that it did sort in descending order because languages at the top have been forked on average more often than the languages down here. And then it's also worth noting that for all of those data frames, it's only showing the top 20 rows. And so this is really useful because in case we're working with terabytes and petabytes of data, we don't want to be stuck trying to show those data frames and then having it take forever or getting confused and too crowded on the console. Okay, so we have successfully run our first .NET for Apache Spark app. So let's go ahead and go back to our presentation. Alrighty, so we've already done that demo. So let's move on to our next scenario, which is combining machine learning with big data. So when we combine machine learning with big data, it means that we want to scale the training and prediction of machine learning algorithms. One great framework we can use for the machine learning when we're combining ML with big data is ML.NET, which is a free, cross-platform, open source machine learning framework. In our example that we'll be looking at, we're going to be performing sentiment analysis, which means that if we're given a piece of text, we want to determine if it represents something positive or something negative. So in our case, we're going to analyze a set of online reviews, and we want to know which are positive and which are negative. If we were given a review such as, "I love .NET for Apache Spark," that would be considered positive, and we could maybe see either a true or a 1, depending if we're using a Boolean to represent positive or negative sentiment. If we saw a statement like, "I hate running inefficient big data queries," that would be considered a negative sentiment. So let's go ahead and take a look at our sentiment analysis demo, where we combine ML.NET and .NET for Apache Spark. Okay, so I've opened up Visual Studio 2019 once again, and in this case, when I look at the NuGet packages I've installed, I haven't only installed Microsoft.Spark, I've also installed Microsoft.ml, which is the NuGet package we need to use ML.NET. And then we can see at the top here, I'm using statements both related to ML.NET and .NET for Apache Spark. So we can see Microsoft.ml and .ml data. We can also see Microsoft.Spark.SQL. So if I scroll down here, we can see that just like we had done in the batch example, we start off by creating a Spark session for our program. And I've just gone ahead and given my app a different name compared to the batch app. Next, it's also going to be similar to our batch example, since we are still technically working with batch data. We're just taking it a step further by also performing machine learning. So in our case, we want to read our review data into a data frame. So I have some Yelp reviews. So I have it in a yelp.csv file. And I've also set a few options for my data frame here. So for instance, I know my data has a header. And so the 2 different columns in my data, which include the text, and if it's a positive or negative review, those columns are labeled. So that's a header. And I don't want Spark to treat that header as part of the data because it could throw off my results. And then I just went ahead, called show, so I could see my raw review data as is before we go ahead and actually predict using ML.NET. So now it's time for the fun part, where we can actually start combining machine learning with big data. So how would we actually start calling the ML.NET code? So how we can do that is using something called a UDF, or a user-defined function. And so UDFs are a popular solution so that we can perform some sort of function on, let's say, each row in our data frame. So if I open this up here, we can see that we create a new UDF by calling UDF method and then register. And within the angled brackets, I have string to represent the input that I'm working with, which is text or reviews, and then Boolean to represent what my output is going to be, which is a true or false for negative or positive sentiment. I've decided to call my UDF MLUDF, and what I'm doing within this function is passing the text into a method called sentiment. So we may be asking, so what is the sentiment method? Where do we create it? What do we do within it? So within sentiment, if I scroll down here, we can see that sentiment actually contains our machine learning code, so the code that was generated from ML.NET. And I got this code, and I actually also trained my sentiment analysis ML.NET model by using something called Model Builder. So Model Builder is a really useful UI tool that we can use within Visual Studio that helps us train and work with machine learning in a much easier and understand way. So just to see what Model Builder looks like, if I right-click on my project and say Add Machine Learning, I can see that within here, I can choose a scenario. So I can choose things like issue classification, sentiment analysis, price prediction. So in my case, I would have chosen sentiment analysis. And then I can just go ahead and choose my input file. So I could choose my input review data set to do some training on. And then ML.NET does all of the training for me and generates some really awesome code for me. So if I go back here, this was actually code generated from Model Builder using ML.NET. And what it's doing is essentially creating a way to start predicting. So it calls the ML model that was trained and created, and then it creates a prediction based on whatever strings I pass to it. And then down here, I created classes to represent my review data, since I do need to pass that or work with that when I'm using ML.NET. Okay. So now that I've gone ahead and created a function where I can call the ML.NET code, I want to actually call that function. So what I've done here is there's this really neat functionality in .NET for Apache Spark where we can actually execute SQL queries. So if you're familiar with SQL syntax at all, we can have those SQL queries within our code. So in my case, I've gone ahead and selected column 1, which represents my input review text, and then passed column 1, so passed each review, to my ML.NET method. And what I can do here is then just go ahead and print that out, essentially. And then I called show so that I can see the output of my operations. And then similarly, just like we had done using the batch app, you'll want to make sure you set your environment variable correctly, so that bin debug netcore app folder. And then we can go ahead and go into our apps directory and build and run it. So let's take a look at how that came out. Okay. So you can see here I had built my project and built succeeded. And then I ran Spark Submit using pretty much the same types of parameters, just in this case it had to be to my current apps DLL. So if I scroll down, what we see here for the first data frame is that was just the raw review data. So these are all the reviews that were in my Yelp data set, and this is the true answer if it's a negative or a positive sentiment. So we can see when someone loved something, that represented with a 1, so that means it was a positive sentiment. And if someone said something was not good, that was a 0, so negative sentiment. So now, the next data frame that we're going to see is going to represent the prediction from our ML.NET code. So let's scroll down and see. And we can see here we're dealing with the same reviews, but now this is the predicted sentiment. So you can see here that it looks like it was pretty accurate. We can see when someone loved something, it was predicted as true, so positive. And then again, when something was not good, it was false, so negative sentiment. So you can see here that we were successfully able to combine .NET for Apache Spark and ML.NET. Let's go back here. So now that we've done that demo, we have one final quick scenario to go through, and this is with structured streaming or real-time data analysis. So in structured streaming or real-time analysis, we're working with live data, so data that's maybe coming in from a sensor, so like an IoT factory sensor, or a phone, or a network. And structured streaming uses the principle of micro-batch processing. So essentially, it takes our continuous stream of data and divides it into smaller little chunks, so maybe every 5 seconds represents a new batch. And then it can perform functionality on each of those smaller batches, and then append the result essentially to a table that already exists. So then if, let's say, another 5 seconds passes, we'll have another batch, perform functionality on it, and append it. Another batch, perform some functionality on it, append it, and so on and so forth as our stream still exists. So in the quick demo that I'll show you here, we can actually do live or real-time sentiment analysis. So still using .NET for Apache Spark with ML.NET, now we can see that if I type a string into a console, let's say, we can determine in real time if it represents a positive or a negative sentiment. So let's go ahead and take a quick look at that demo. Okay, so I still have the Microsoft ML and Microsoft Spark NuGet packages installed. I start off creating a Spark session, but instead of reading into a data frame from a CSV or stored data, now I'm doing something where I'm reading a stream, and I have to set up the host and port information my stream is coming from. And then I still use ML.NET with a UDF, and I can still call the ML.NET code in a very similar way. And then finally, as I'm working with the data and displaying it, I use something called a streaming query, and I can go ahead and call write stream and determine that I want to write my stream to the console. And instead of saying spark.stop, we can do query.await termination. So if I go over here, I can see here that I've set up a quick netcat terminal, so just an easy way to read to or write from a network connection. And for instance, I could write something like, I love Spark. And then in my other tab over here, I've already built and run my .NET for Apache Spark app. So if I scroll down, you can see that I've been working with my different batches here. So every time I hit enter is considered a new batch, and it determines in real time if my line was a positive or negative sentiment. So you can see when I said, I love Spark, it was considered true, a positive sentiment. So that's awesome. We have real-time streaming working. Okay, so a couple quick steps for how you can get started with .NET for Apache Spark. We have, if you go to the .NET website, so dot.net/Spark, you can go ahead and read even more about .NET for Apache Spark. You can go through a really neat getting started tutorial we have where you can get up and running with .NET Spark on your local machine in 10 minutes or less. And you can also visit our docs and see some other learning resources we have. You can also visit our GitHub, so github.com/.net/Spark, so you can go ahead and view some of the documentation, you can see how things are implemented, you can participate in the open source community with Spark. So thank you so much, and now I guess we'll turn to questions.
Fantastic. So that was an amazing presentation, Bridget. Now help me out because I am a little dense. Spark isn't like a database. Is it? Is it where the data is stored, or is it a medium for transferring data over? Help me out to set the context from these questions.
Sure, yeah. So Spark isn't a database, so it's not where the data is stored. So you'll already have your data stored in something like somewhere in Azure, so maybe an Azure Data Lake storage or in a blob or something like that. So Spark is actually kind of like the framework or the tools that we can use to start analyzing that data. So it allows us to read it in and to process it more quickly and to make different calls to it so that we can gain meaningful insights from it.
Amazing. So it's like the pipe then that takes data from any scenario and then moves it over. Is that right?
Yeah, that's a good way to think of it.
Fantastic. And so you mentioned a lot of stuff with .NET. We didn't have .NET isms for Spark. When did this start? And if you were to point, because you pointed out tons of cool things, but if you were to tell people one thing, look at this first and see why it's powerful, what would you suggest to them?
Okay, so we started this project. We first started it towards the beginning of this year, so I would say about in April, even though we did have a predecessor to this project a few years ago. But yeah, I would say as of this year is when we actually started having like these awesome .NET bindings to Apache Spark. And for something really awesome, I would say
if you check out that landing page, so dot.net/Spark, you can see really that you can really start processing terabytes and petabytes of data at a manageable scale. So you don't have to spend like days and weeks and months and years processing all this data. You can actually start gaining insights from it in like a matter of hours.
That's pretty cool. Does .NET for Apache Spark support using F# instead of C#?
Yes, I believe it does. So .NET ecosystem in general.
Fantastic. Well, this is amazing. Thank you so much, Bridget. Now, here's a couple of things, though. Before we go, I want to remind everybody about, I'm not finding it, but the actual tech challenges that are available. Let me get my handy notes out here because they're pretty good. And if you have more questions for Bridget, make sure you get them in. Make sure you participate in the technical treasure hunt. It's happening all day. Tons of technical problems that you can solve, maybe even do a little bit of code. If you solve all of them, you will get a ton of wonderful prizes. It's pretty cool if you go to .NETConf/party. That's what we're going to, if you go to .NETConf/party, sorry, they're talking in my ear, you'll be able to see all the cool things. And there's a ton of things happening today. Make sure you go to the Apache Spark coolness for .NET, which I think is pretty cool. We're going to go to a commercial break here in a second, and after that, we're going to have more Servers Less with Jeff Holland, who's going to talk about Durable Functions 2.0, serverless actors, orchestrations, and stateful functions. All right, let's go to Jeff actually right now.
I am so excited. That's the second time that I'm way better than a commercial break. Like, let's just start with the serverless functions. Why even wait? So I am thrilled to be here today. My voice is going to hold out for one more amazing session here at .NET Conf. I'm getting over a little bit of a cold if you can hear it in my voice, but I'm so excited. I will be just as durable as the functions that we're going to talk about. So last year at .NET Conf, I did a session talking about durable functions and some of the patterns that you can do. I'll do a slight refresher on that for those who might not have seen last year's one. But what I really want to talk about today is durable functions 2.0 and some of the stateful patterns that you can now do for .NET, doing serverless compute in the cloud to let you do things like stateful entities, actor-like patterns, orchestrations that unlock an entire new world of scenarios that you can start to get into. So to start with, as mentioned before, I'm Jeff Holland. I'm a program manager on Azure Serverless, focusing on Azure Functions. So today we're going to start by doing a little bit of an overview of what Durable Functions is. We're going to talk about some of those new patterns, specifically durable entities, go over some examples and scenarios. And if you have questions, be sure to tweet #.NETConf, and I'll answer those at the end as well. So I'll make sure to keep time for questions, but please participate, ask questions as we go so that I can answer them here live. So thinking about functions, I apologize for those who might not be familiar with Azure Functions already. I'm going to kind of make some assumptions that you're aware of what a serverless function is, at least, even if you haven't already used one. And traditionally, when you think about functions, there's oftentimes paired with some qualifications about functions, like, oh, they're stateless, they're very short-lived. So if you want to do a pattern like what I'm showing here, just a really simple, an event happens, like, hey, we add a customer. And whenever we add a customer, we need to create a record for them in a CRM database. And then we need to send them a welcome email. And then we need to update some SQL database, right? You have like 3 tasks that need to happen. The way that traditionally you'd have to build that is like what's showing behind me, right? This idea where you have function 1, drops it in a queue, function 2 triggers, does its little short processing, drops it in a queue, and then hits function 3. And it's totally fine. You can do it that way, but it's a bit cumbersome as a developer or an operator to have to write this decoupled code as these kind of independent functions, managing it, deploying it, looking at how many customers I'm adding and the health of that pipeline can be challenging. So what Durable Functions lets you do is it's an extension to Azure Functions. It can be installed in as a NuGet package. And it will enable you to write this in codeful ways, using code to describe more stateful and long-running stuff. So here, this is an example of an orchestration. It's the same logic I was showing you before, where I'm going to call function 1, then I'm going to call function 2, and then I'm going to call function 3. That's what I've described here in code. But here, rather than me having to manage the queues or mentally map how things might be happening, I've actually been able to write this as code, as a special type of function, as a durable function. Now, this entire orchestration might take 30 minutes. It might take 3 days. That's totally fine Durable Functions is going to do it all for me as this nice extension and let me describe it and monitor it and manage it as code. So here I can absolutely see what's happening. Oh yeah, function 1, function 2, function 3. If an exception happens, you'll notice I even have things like a try and a catch block so that I can catch exceptions and handle them. So it's this nice pattern that I'm able to do. Excuse me, as I mentioned, I'm going to be durable. I'm going to make it through this. All right, so what are some of the patterns that you can do with durable functions? And I mentioned before, the kind of one I spent some time about last year was talking about orchestration. So I have my orchestrator function. It's calling each of my activity functions. These are other functions in the same app. And I can chain them together. But I can also do other patterns, right? So sequencing, it's the one we've talked about. You could do fan out and fan in with durable functions. Like imagine a scenario where, hey, every week there's going to be a report. I'm going to get a batch report. And for every single record in that report, I want to go execute a function. And rather than me having to kind of manually drop stuff in queues, Durable does it for me. I can just describe this as like a for loop and say, hey, for each record, call this function. And Durable Functions is going to do that for you. External events correlation. Kind of an example here I like to think about is imagine that you're hiring a new employee and there's 3 events that have to happen, right? They have to upload their driver's license, they have to upload their social security information, and maybe they have to upload some form. And what I want to have happen is wait until all 3 of those things have happened and then continue. Maybe fire a third function that says, hey, you're done. You've uploaded all you need to do. With Durable Functions, you can write in code a way for a function that waits for those 3 external events, waits for all of them to happen, and when all 3 have happened, will continue on. Also written in .NET code, just like the code I showed you earlier. Long-running operations is a powerful pattern as well, where maybe you actually want to monitor something. I did a sample a few months ago, which was pretty simple. It's also in our Durable Functions docs, which was, hey, tell me when the weather is going to be nice over the next 6 hours. So you could kick off a function, and every 10 minutes it's going to pull the weather and say like, hey, is it going to rain? Is it going to be sunny? I live in Seattle, so we really need Durable Functions just to let us know when it's going to be sunny outside. And so this function is going to monitor the weather for a few hours, maybe a day, and as soon as the weather is nice, it sends me a text message. So the idea where I have this kind of long-running function where I'm monitoring the weather, I can describe that as a durable function as well. Asynchronous work, this is another powerful pattern where maybe I want an HTTP triggered function, one that can be triggered on an HTTP request, but maybe that HTTP request is going to take 5-10 minutes to process its work. And I don't really want to call the function and have the thing that's calling it keep that request alive for those 5 or 10 minutes, right? Oftentimes, like if it's from a mobile app, it's very common that I'm going to have a hiccup in my connection. It might disconnect after 3 or 4 minutes. It's not a very scalable pattern. So with Durable Functions, I can say, hey, start the function, fire it, but then return back immediately with a status endpoint and be like, hey, I got your request. Check back in a few seconds to let me know what my progress is. So you can kind of have like this progress API through Durable Functions where the function might take 10 minutes to process that HTTP request, but my clients just check the status. They're like, hey, are you done yet? Nope. Are you done yet? Nope. Are you done yet? Yep, I'm done. Here's the result. Awesome. Great. Super seamless pattern, just a few lines of Durable Function code. And then finally, human interaction. Maybe I have a approval, right? I submit a document. I need to wait for Jeff to approve it. I need to wait for Seth to approve it. Once both of them have approved it, then submit it to the final result. So these are just a few of the patterns that are more stateful in nature, are more long-running in nature, that if you're using just serverless out of the box or Azure Functions out of the box, it might be like, how do I solve these? And Durable makes it really trivial with just code samples and examples. And in fact, all of the patterns I've shown here, if you go to the Durable Function documentation, which I'll link to at the end of the presentation, we have code samples and examples for doing all of these. Now, how does Durable Functions work behind the scenes? And I want to illustrate it with this slide. So I have here, and I apologize, the color's a little bit hard to note. In this gray box, I have my Durable Function code. And it's just a really simple Durable Function orchestrator. It's just going to call the say hello function and pass in the value world. Now, behind the scenes, how Durable Functions is working is you just write this little bit of code here, that gray box up top. In Durable Functions, this extension to your Azure function is going to interact with a storage provider like Azure Storage to monitor and maintain the state for you. It's going to keep what's called an execution history so that it knows what step it's at, what step to do next, still enabling you to do like scaling to 0. So if, for example, if I was doing an approval workflow and it's like, hey, I need to wait for Seth to approve a document before I can continue, you're not paying for the 2, 3, 4 hours or 4 days where your function's not running and you're just waiting for approval. Your function can actually scale to 0. And when Seth approves the document, it wakes up and continues on. So that's all happening because of the state management behind the scenes. So let's walk through it now, right? Let's say I trigger off this function. I say, hey, start my orchestration. And the function wakes up and it's going to start evaluate the first line of code. So it's going to say, all right, create a new list, outputs. And it will get to the next line. And Durable Functions is going to see this await word. And when it sees the await word, it knows that there's some activity, some task that it needs to perform. Now, as I mentioned, because it might be resuming from a previous state, it might have crashed from a previous state, the first thing it's going to do is it's not actually going to evaluate this code. It's going to go ask Durable Functions, and it's going to say, hey, have I already done this? Have I already said hello to world? So in this case, the Durable Function asks the execution history. And it's like, hey, have I already said hello to the world? And the execution history is like, no, you haven't done this yet. It's like, OK, cool. I know that's what I need to do then. So it's going to go ahead and schedule this work. It's going to drop a message in a queue that's managed completely for you. And going to say, hey, we need to say hello to the world. And after that, your Durable Function stops. It's done. It's like, hey, I scheduled my task. Now I'm going to wait to get triggered again. Now at this point, your activity function, your function that's actually going to do the work, your say hello function, it had some work scheduled for it. So it's going to wake up. It's just been triggered. It's got work scheduled for it. So it wakes up, it triggers, it says, hey, my orchestrator wanted me to say hello to the world. So the function's going to do its work. It's going to update the execution history table. You'll notice I visualized that here. So hey, I did my work. I said hello to the world. And then it shuts down. Now when that happens, the orchestrator gets triggered again. Now here's the really important part to note. When the orchestrator starts again, it doesn't resume from the middle, right? There's not really a way to just start from line 52. So what's actually going to happen is the Durable Function is going to start from the top again. It's been triggered. It's going to first evaluate that first line of code, right? Create a new list. Now it's going to get to the second line. And as I mentioned, it's going to say, hey, I need to await something. I need to await saying hello to the world. And it's going to make that same check. It's going to say, hey, execution history. Have I already done this thing? Have I already said hello to the world? And in this case, I have, right? In the history table, my activity function did its work. It created its outputs. And it's like, yeah, you actually said hello to the world. The result was hello world. So then the function's like, great, I'm going to go to the next line. And in this case, the next line is just return outputs. But you could imagine if I call another function and another function, this pattern kind of continues where I'm scheduling work, the work gets scheduled, I'm updating the results in a history table, and then my function spins up again and starts again. So all this happens for you behind the scenes. You don't have to worry about this kind of execution history song and dance. You just write that really simple code that I showed earlier that looks a little bit like this. But behind the scenes, that's what's happening. It's using storage, it's queuing, scheduling work, and it's replaying that orchestrator and rehydrating the state every time it plays. Now, that's Durable Functions all up. Let's now talk about Durable Functions 2.0. And as the name implies, 2.0 is better. It's great. It's new. It's exciting. Durable Functions 2.0 is currently in preview. We just shipped the Beta 2 package a few weeks ago. So what are some of the improvements that are coming to Durable Functions? Well, the first one that I'm the most excited about is this Durable Entities pattern that we're going to go into in just a second. If you've done any actor programming before, like Akka.NET or Orleans or Service Fabric, you might see some similarities in this Durable Entities pattern. Another one that we've shipped as part of Durable 2.0 is the ability to make resilient HTTP requests from an orchestrator. So an orchestrator being like, hey, call function 1, call function 2, call function 3. You can now say, oh, now make an HTTP request. You can even add authentication to that HTTP request. So maybe you have a durable function that's going to call a few Azure APIs. You can do all those Azure APIs and use like a managed identity to authenticate those requests, all within a durable function. Pluggable state providers. So previously, durable functions just worked on Azure Storage. We now have a method to swap in different state providers. Maybe you don't want it to be Azure Storage. Maybe you actually want it to be Redis, because you're going to be running these durable functions on premises or in Kubernetes, or you want it to be Event Hubs or Kafka. We've created a new pattern so that you can plug in different state providers. Your code doesn't need to know about it, but behind the scenes, it can use some different state providers to take advantage of maybe better throughput, disconnected environments, etc. We're shipping a Roslyn analyzer that will actually evaluate your code in Visual Studio or VS Code as you write it to let you know of common pitfalls like, hey, the code you wrote here isn't deterministic. And when it does a replay, it might end up getting in a weird state. Our analyzer can detect that and do the little squiggly lines for you, which is fantastic. We've also just made some nice improvements around the interfaces and testability so that you can more easily write unit tests, implement interfaces for your durable functions. So this is some of the goodies that are there, but let's actually spend the next few minutes diving into durable entities. Now, what is a durable entity? Again, traditionally, you think about functions, you think about stateless and short-lived. These are stateful functions that can be long-running in their state. So let's take a very simple example, a counter. Let's pretend that I'm creating the next Fitbit or Apple Watch. Everyone's going to get a device, and I want to track the amount of steps that someone has taken. So I really need some state for each user that's a counter. Now let's look at how you could write that using durable functions in this new entity pattern. So this is an example of a durable entity. This is an entire function app right here. This is all the code that I would need for my function app. And really, it just looks like a class because that's kind of what it is. It's a counter class. And my class has properties. I have the count property, which is an integer, which I'm going to set to 0 initially. I can increment the count. I can decrement the count. Obviously for Fitbit, you don't really reduce steps when you walk backwards, but a counter can go backwards. And here I'm just saying like, hey, when I increment count by 1, decrement count by 1, I could terminate an instance of a counter. Maybe I have Jeff's counter, I have Chris's counter, I have Seth's counter. Maybe I want to destroy one of those counters. I don't want to keep the state anymore. In fact, if you've written functions before, the only thing here that might look a little familiar is this line at the bottom, which is like, hey, I have a function, which I'm going to call counter, but all it's saying is map this to a durable entity of class counter. That's the only code I have to write here for a function app, and Azure Functions with durable functions will now turn this into a counter. So let's check that out now. I have here in Visual Studio Code an example of that counter. This is the same counter we were just looking at. The only thing I've added here is I've injected in a logger. You can inject in bindings as well. You can inject in your own custom services. But here I'm just injecting in a logger, but it's still that counter, right? This is the entire code for my function app right here on the screen. Now what's amazing here is just like any function app, let's go ahead and start and debug this project. Again, all it is these 25 lines of a class definition saying, hey, I want you to keep track of a serverless counter. So it's going to spin that up. It's going to run the Azure Functions runtime on my machine right now. And because I have the durable functions extension installed, in fact, if I open my CSproj file, you can see here I pulled in that beta 2 package of the durable task extension. As my function app spins up, it's going to recognize that this is a durable entity, this is a stateful function, and it's going to let me interact with it. Now there is a durable SDK that I could use to interact with that counter inside of my code if I wanted to. Or durable entities exposes a direct REST API. So I can perform operations on my entities, get the state of my entities directly over HTTP without having to create like an HTTP trigger if I didn't want to. So my function's now running, and here I have some HTTP requests that I'm going to use to call this entity, right? So it's running on localhost 771. Here's the path to that REST API. I'm saying, hey, call durable task and an entity. And here I have counter. Now, why does it say counter here? Because that's the name of my class. That's the name of the function that I created called counter. In this part right here in the path, this is where I put in the ID of the counter, right? If you think about this idea of a stateful function, I might not just have Jeff's counter, I might have Seth's counter and Chris's counter. So here's where I can define the different counters that are going to be running. Each of these might have a different count step, right? Different steps for each person. So let's go ahead and try to get the steps for Jeff right now. And when I call it, it's going to process. And actually right here, what it's returning back is a 404 not found. And that's because this is a brand new function, a brand new storage account. I've never run it before. I've never done an operation on Jeff. He's never taken a step. So it doesn't actually exist yet, which is fine. Let's go ahead and do an operation on the Jeff counter. Let me move this out of the way. So here I have a post request that I'm going to make. And here I'm going to say increment the counter for Jeff. Now, why is it say increment here? And that's because if I come back here to my counter code, it is because here I defined a method called increment, right? So it maps to the method that I defined. So I'm going to say, hey, increment, which does count plus plus. So let's go ahead and send that request. It says accepted. Let's send it a few more times. Let's take a few more steps. Send, 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 send. I think I hit that 4 times, maybe 5 times. Now, let's do that first call again. Get the current state of Jeff. And when I call that, here I get back a 200 OK. And you'll notice now it actually knows the count for Jeff is 5. Now what's cool here is I could shut down my machine. I could restart my machine. I could close everything down. I could spin it back up again, make this same call, and it's going to remember, oh yeah, I have the state for Jeff and the count is 5. I could publish this to the cloud running as an Azure function. It's only going to run and bill me when it's actually being invoked. But I could call this in 3 weeks' time, and it's going to remember the count for Jeff is 5. So this is a powerful pattern that lets me now represent state, keep that state around, manipulate that state, and have some operations on that state. Completely serverless, right? So all the benefits of functions, massive scale, only pay for when it's running, but in this case using durable functions in this new stateful entity pattern. So where are some of the places that this might come in handy? There's a lot. I have another example I won't run into now, which is like imagine that it's .NET Conf and I have a bunch of sessions, right? I won't run the sample, but I will show it because I think it's a good one to visualize. Imagine here that I have sessions. So I have a session class, like a session at .NET Conf. Every session has attendees, number of people who are viewing it. Maybe they can submit reviews or evaluations, which is going to be a dictionary with the string and double, string being the attendee name, double being the score. And I can also submit an evaluation, which is a method to submit an eval. Here I'm going to pass in an evaluation, which I've defined here. It's just an attendee and a score, as I mentioned. I can add those together. I can even get back in aggregation, which is like, hey, give me back the average score for this session. I could now deploy this class, this durable entity, as a function app, have it processing and maintaining the state for every session happening at the conference, maybe multiple sessions in parallel, and durable entities is going to maintain the state for me. Storing all this in Azure Storage behind the scenes, but I as a developer haven't had to worry about wiring that out. In fact, I get nice guarantees here too, where imagine that I tried to increment my counter 100 times at the exact same second. I will get guaranteed single threaded for one instance of the counter so that my counter will increment 100 times, right? It won't have race conditions as well. So there's some cool stuff here. The last pattern I want to show with durable entities, this gets a little bit more advanced. So hopefully you've been able to follow along so far. It's actually a pattern that I've come up against a lot running serverless functions. So let me walk you through this scenario here. Imagine I have a simple architecture like this. I have Azure Event Hubs that I'm sending thousands of events to every second. Those events are triggering a function, and that function maybe needs to update some data in a database like Cosmos DB or SQL. Well, behind the scenes, as these thousands of events are coming in, my function is actually probably going to scale, right? It's going to scale to many, many instances. And the problem comes in, what happens if there's an outage or some issue with my database downstream? What if my function is triggering this whole time? It's trying to update these records in a database, but those calls are failing. And people can get nervous in this because your function keeps scaling, it keeps triggering, but it's just hitting failure after failure after failure after failure. So what I wanted to implement is a circuit breaker pattern where ideally I have something that is monitoring the state and the health of my circuit. So here it's the same architecture, but you'll notice I've just added in this stoplight here, which is green right now, which is supposed to be saying, hey, this is healthy. And what I want to have happen is that if I start getting a bunch of exceptions, like maybe 100 exceptions, I actually want to set this to red and stop triggering my function. But how do I do that? That can actually be complicated to solve for, especially noting that my functions are going to be scaling across these concurrent instances. Well, this is where durable entities comes in. I'm going to deploy a durable entity which will be monitoring the state of my function circuit, that stoplight. And whenever one of my functions hits an exception, I want it to send a signal up to that entity. And it's up to my circuit entity, that stateful function, to do some aggregation math to figure out, is this healthy or not? And if it notices that I get maybe 100 exceptions in the same second, it's up to the durable entity to stop the trigger, to turn it off, right? So that's what I wanted to build. And in fact, there's a sample on GitHub that I'll link to in a second that does exactly that, where I have a durable entity that has the state of the circuit, open or closed, and you can add a failure to it. Any of my functions can say, hey, I hit an exception, and I just have here some code, I'm not going to dig into it right now, where I'm saying, you know what, if I ever have more exceptions, in my case it's like 50 exceptions within a 30-second window, then I want to go ahead and break the circuit to turn it off. And in that case, I just have some code that disables this function app. So let's actually test it out now. The last thing I want to show here, I have here running in the Azure portal, this is my Event Hub triggered function. And right now it's running, it's happy. And let's go ahead and publish now 1,000 poison events to this function. So I'm going to send bad, very bad events. Let's go ahead and publish now 1,000 bad events, so I know I'm going to hit my exception threshold. Let's pretend that these are all database failures. And here, if I come back here to my live metric stream, we should see here in just a moment, assuming that, yep, it's sending those messages. My function's going to wake up and it's going to start triggering, and it's going to hit exception after exception after exception. And what's powerful here is that after I hit that threshold of exceptions, my durable entity is actually going to fire and disable my function app. Now I'm refreshing it now. It doesn't look like it's triggered. I hope I've hooked up to the right. Oh, there we go. All right. Might have been some Wi-Fi hiccups there or wherever else. So I'm now online. I see some failures processing. You actually notice right away my exception rate started to climb. It's hitting a lot of exceptions here. And normally this is where I'd get really nervous, right? If I had 1,000 requests coming in every second, this exception rate's just going to grow and grow. But you'll notice it actually just dropped off pretty quickly. And the reason it dropped off is because here I hit my threshold of exception and it's actually disabled. It stopped my function app. So I had this durable entity that was keeping the state of this function, monitoring the health of it. It hit enough exceptions in that window that that stateful function was able to then go turn off my other function. So kind of an advanced pattern here, but just trying to give you the idea of how you can use these stateful functions to unlock patterns that traditionally would be really hard, that you want state for, maybe in aggregation, but with durable entities becomes super simple. So before we move to questions, these are just some resources for you to be aware of. If you're interested in using Durable 2.0, check out this link to check out the docs for Durable Functions 2.0. There's a number of samples, like how you could use durable functions to create a Twitter service or a rideshare service that you can check out at the second link. And finally, that circuit breaker sample, the code that I used to do that last example of disabling a function, that's here as well. If you have any questions, reach out directly on Twitter as well. More than happy to help. But with that, I'm going to see if there's any questions that have come in during this time. So we'll turn it back over here to see if there's anything that's popped up.
Yeah, awesome. Thank you so much, Jeff. That was really, really cool. We have some questions. So the first one is, when is ASP.NET Core 3.0? When will it be available for Azure App Service?
Yep, so I believe it should be there, if not now, very, very soon. I was on an email thread yesterday where once it went GA, we have to go update kind of our entire fleet of machines and make sure that they have 3.0. I believe it should be there now. Obviously, there's a few ways to run app services. So you can run app services in a container, which would just work out of the box. But I believe now you can take a .NET 3 function app, deploy it to app services, and it should work. If it's not available now, it should be imminent. As I mentioned, there's been some very chatty threads to make sure we're ready to go.
Awesome. And then here's another one. So where can people get your Azure Functions t-shirt?
Isn't this amazing? I love this. Is my favorite shirt. I'll move my laptop so you can look at that. It's the ASCII art for the function runtime. So I will tell you, We are printing a bunch of them right now because it's a hot commodity. If you can make it to Microsoft Ignite, we're going to have thousands of them. So come to our booth there. If you can't make it, try to grab us at some other conference, and we'll make sure to bring them. Obviously, .NET Conf is a digital conference, so it's harder to distribute them through this live stream, but they're coming, and I'm glad you appreciated it. I love this shirt.
Yeah, so you hear that, everyone? Go to Ignite, and that's where you'll get those t-shirts. Yeah, and we have another question. What languages support the Durable Functions framework?
Yeah, fantastic question. So .NET supports it, obviously, is what I showed. JavaScript is the other one that you can write these durable orchestrations in. Right now, we're working on getting JavaScript to work with these new entity features I just showed. So some of the 2.0 features I've been talking about are only exposed through the .NET SDK right now. JavaScript's being worked on right now as well. But we're working on Python support. I don't know if we've actually said that publicly before, but we are working on Python support as well. So stay tuned over the next few months for any updates and news around Python for these durable functions.
Okay, great. And we have another question. Durable functions or Logix apps? When should I use what?
Yeah, that comes up very often. If you've used Logic apps before, they also let you create these orchestrations specifically. Some of the big differences, Logic apps is a declarative visual designer. So when you write a Logic app, you have these different connectors, and you can have step 1, call step 2, call step 3, doing similar things that a durable function orchestration can do. Honestly, what I think it comes down to for a lot of folks is personal preference. Some people want to describe these orchestrations in code. Some people like this declarative nature or the visual designer of Logic apps. So that's a big one. There's a few other ones where I'd say it's a little bit easier. If you want to leverage one of the over 200 connectors that Logic apps has, use Logic apps. If you're only orchestrating functions, maybe Durable is a little bit nicer for you there, though Logic apps can do it great as well. Some of these other patterns, like we talked about stateful entities, that's really going to be Durable only. So there definitely is some overlap. Personal preference is big there. I'm a fan of both. I'll use Logic apps for some things, Durable for others. It's kind of like, hey, do I want one of these connectors? Do I want this visual designer? Or am I just going to write some simple logic in code directly?
Cool. And here's another one from Simon. When will it be possible to change the runtime of an Azure App Service or function service to .NET Core 3.0?
Yeah, so this is slightly different from the first question in that you can write like an ASP.NET Core 3 app and deploy it to app service. But functions, like when I showed you the function code, it's its own kind of SDK. It's almost like its own flavor of ASP.NET in some ways. That does not support 3.0 yet. We're underway working on it right now. There's an announcement in our GitHub repo. Currently, next month, so October, we'll have Azure Functions in .NET Core 3 available to try out and becoming generally available early next year. So stay tuned for that as well, as to be able to write these functions in .NET using .NET Core 3. App services, as I mentioned, if you're just deploying a web app using ASP.NET Core, that's much sooner, but a function app using .NET Core 3 is next month for preview.
Cool, and I think we have time for one more question. So the last one is, how much data can you store in the stateful pattern? Is there a limit of how many users can I store the amount of steps? For how long will this data get stored? Am I paying for this stored data?
So it's really up to the storage account behind the scenes for some of the limits. There's no limits with the framework itself. We'll just use your Azure storage account. You will be paying for that storage. So by default, we'll keep it around indefinitely. If you have a bunch of data in there, we have SDKs to help you kind of clean up old instances or old entities if you want to keep it clean. But by default, we'll stick them in an Azure storage account. As long as your Azure storage account has the room for it, you can keep your state there. If you want kind of more state or you need higher throughput than Azure Storage is able to provide, that's where I mentioned some of those pluggable providers will come in. But you will be paying for the storage costs of all the state. So like my counter example, if I open my storage account right now, there's going to be a blob that says like Jeff's counter, the value is 5. I'm going to be paying some, whatever, 1/100th of a cent for that state. If I had bigger state, I'd be paying more.
All right, awesome. Thank you so much, Jeff. Next up, we have Beyond Copy and Paste, creating interactive documentation with Maria Nagaga.
Thank you so much, Mika. Thanks, everyone, for staying tuned with .NET Conf 2019, and thank you for listening to my talk. So my name is Maria Nagaga. I am a senior program manager on the Visual Studio and .NET team. And I want to talk to you today about interactive documentation and how we think about that, and how it's important for our first-time developers as well as developers who are continuing to grow and build on our platform. So let's talk about documentation. Documentation is how we build trust with our developers. It's how we educate people. It's how we sell our products. And good documentation means that we are as invested in our product as much as you are. It's important as we build our documentation, from first-time developers to people who are building code every single day, that we make sure that their on-ramp is as smooth and as effortless as possible. So let's talk about documentation today for a few minutes. With documentation today, it's getting really good, but there are still a few assumptions that we continue to make about our customers. First is the assumption of knowledge. Sometimes when content creators are writing documentation, they assume that the people coming to our documentation have prior knowledge of the framework and the languages being taught. The assumption of tech. As a content author myself, I sometimes continually find myself thinking of my experience as the only experience. I sometimes reference the operating system I'm using. I sometimes reference a version of Windows. I always assume that someone has as good internet bandwidth as I do. So a good example of this is providing links to certain specific downloads, as well as screenshots that only reflect a particular operating system. And the last one is the assumption of time. We are all really guilty of doing that. We assume that the people coming to read our content or use our videos or our documentation have more time than they do. Usually when people are learning things, trying new things, or testing something out, they have a limited amount of time. Whether you're an educator, a hobbyist, or a seasoned developer, you're probably doing this over your lunchtime, or just before you go to bed, or just before you start work. So we need to make sure we cater for that. So when we look at documentation today, majority of the documentation looks like this. It's static code, right? And if we think about this from the perspective of a net new developer or a brand new first-timer, they're often left wondering, what does this do? So we then go to Stack Overflow, we copy and paste a bunch of code from here and there, but then we're still left with a challenge, especially as first-time developers. What template do I use in Visual Studio? What libraries do I need? What do all these error messages mean? We are telling people that for their first few lines of code, there's a huge on-ramp, or even just to run a sample. For our seasoned developers, you're probably working really fast, and you don't want to copy and paste code in and out of your code base. You just want to see if this is the best thing for you. So we've noticed one thing as we begin to improve our documentation, our expectations have changed. And we expect more from the people building our content to do more. Video has done great work in this space. And we just launched right now with .NET Videos on how we are investing in videos and how we are making sure that our developers have an interactive experience where they're able to listen, pause, and rewind. But still, we're assuming a bit of time on your side. But it's really good content, so please go and look it up. Another thing is interactive snippets online. This has actually become a requirement for languages and frameworks. When you can see popular languages like JavaScript and Python allowing people to test APIs and syntax right within the browser. But we're also seeing it in popularly emerging languages as well, such as Scala and Go, where people are able to interact and test APIs right within the browser. But this is just a few pieces of the puzzles, right? So we have video on one side. We also have syntax iteration online. However, people want to have experiences that feel as native to the experience that they would have in the browser. We're seeing this in places like Microsoft Learn, where people are able to try and test things out, which would be similar to what their local experience would be. So when they do transition into an offline experience, it feels vaguely familiar. But then we also have the concept of trying. Now, this is something I constantly do. If I want to try out a new NuGet package, I will create a throwaway package, see if it's working, I will delete it, I will do it again. But you're seeing places like MPN, with the help of companies like RunKit, creating these experiences online. We should be able to try out our NuGet packages and see what they're like right within the comfort of our browser. And what we're continuing to see here is a narrowing of the divide between documentation and code. And the reason why we're seeing this is the landscape is continuously growing. We have developers, such as people who are watching this show, writing blog posts every single day. We have hobbyists, and the hobbyist field just keeps on growing, from makers to web developers, mobile developers, IoT, from social media influencers, where they're just constantly learning how to own their own online experience. We have data researchers who are using and mining data and making these analytical choices to make more informed decisions. We have educators, both CS educators as well as non-technical educators, where we're seeing in primary and secondary schools all around the world, where non-technical teachers are given the task to on-ramp the next generation to be comfortable in this new world of coding. And finally, we have our students who want to explore and learn as much as possible, and we need to provide those opportunities for them. So when we're creating these new experiences around documentation, especially at Microsoft, there are things that we wanted to make sure that we landed very comfortably with the customers. We wanted to make sure that they had up-to-date documentation, nice and fresh, referencing articles that were from 2019 versus 2003. We wanted to make it engaging. And engaging is not just about making it flashy and cool. You want to make the navigation really easy. You want someone to land on a documentation page and know where they need to go. You also want the steps to be clear and quick and easy. So if you go to .NET right now and you go getting started, you will see how to get up and running in 10 minutes, giving people the moment to feel empowered in 10 minutes or less. And finally, we wanted to create a friction-free learning experience. We wanted someone to be able to go onto a web page and learn about the language without having to install all the tools or know everything. And in 2017, we launched an interactive online experience with a product that I built called Try.net, which allows people to experiment and try .NET, the language, within the browser. So let's talk more about the Try.net interactive experience and what we offer there. We have our initial goals were in 2017 was to have an interactive documentation online, bringing us up to speed with the other languages that had been providing this for their customers. Most importantly, we wanted it to be login free. We wanted to make sure that someone didn't have to install everything on their machine in order to just write console.writeline hello world. We wanted you to give that quick win. And finally, we wanted a fast on-ramp. We wanted it so you could edit the code online, click run, and see the results. We wanted you to feel that moment of success. But we also noticed that Try.net is growing, and those are some of the wonderful things I want to share with you today. So when we first began in 2017, we wanted a friction-free online experience, and we did that. With Try.net, and you go to docs.microsoft.com, you're able to run C# code right within the browser. But as we began to notice that, there were certain difficulties. First of all, what happened if someone didn't have good internet access? What if somebody wanted to do this locally on their machine? How are we creating that experience for you? Also, we wanted to make a cheaper alternative that allowed people to run things easily within their website. And luckily, in 2018, we also got Blazor. And it allowed us to pivot from running things in containers on Azure Container Instances to running things on the client side with Blazor. And not only that, because we created these experiences, it also allowed us to create a local experience with the .NET Try Global tool. And if you look at my slide right now, we have a student in South Africa who calls this one of the most influential things that he's used that allows him to go and share C# experiences with his fellow students. So we thank you, and we hope that you continue to use us. And then we have a special surprise that I think a lot of you didn't expect, but we also have .NET running in notebooks. And I'll be sharing that demo with you later today. So let's go and see some demos now. All right. There we go. There. OK. So as I said, Try.net started in the browser. So if you go to any single sample on the docs.microsoft.com quick starts, you notice that we have an editor right now. You can copy the code over, run it, and you have the direct results. You can also edit it easily right within the browser, so you're not restricted by what is in the code, and you run it again. This is all running on Blazor. It's all running on the client side. That allows us to create opportunities where people could possibly add this to their websites as well, which we're hoping to enable in the future. But I also talked about the offline experience. If any of you have ever done a workshop or done a tutorial out there, you've probably had to get people to download the tools, clone the repo, make sure they're in the right operating system, and before you know it, it's 2-3 hours into the workshop and nobody has done anything. We wanted to make sure that people could be just successful with the .NET SDK and the .NET Tribal Global tool and get things up and running. So I want to give you a quick demo of that. So we have this repo. It's our samples repo. You can go to .NET Try/samples on GitHub, and you'll see 4 clear instructions where it will tell you to install the .NET Try Global tool, which is available in NuGet today, clone this repo. Then once you have this repo cloned, I want you to go into the directory and type .NET Try. So as someone who prepares for demos ahead of time, I did the first 3 steps ahead of time. So I'm going to go right into here, type .NET Try, hit run. And what this is going to do, using Kestrel, is going to start up my browser. And it's going to give me an interactive markdown experience. If you look at the top, this is an MD file. So I'm going to continue into Introduction to Programming with C#. And you'll notice that you have a list of instructions. It's like an interactive book. Let's go ahead and run this code. Sometimes the first run can take a few seconds, but bear with me. You have Hello World. I can go in, change it again, and I will put in my name, run it again, and I see the results. This gives people the flexibility to learn and experiment within the browser, giving you that nice interactive experience. So I hope that you'll give it a try for the next workshop that you're doing, or if you just want to just try it out. But the big question here is, how are we doing this? How are we able to have this mix of interactive code, C# code, with a markdown file? So I'm just going to go over to Visual Studio Code and show you some of the magic that we're running. So I'm just going to close up the server here. So this looks like markdown that you've probably written in the past if you've done anything with a README file. And if you add any sort of language features within your markdown, you usually have to use a flag. So you'll notice that we have something called CS, which is the C#. We're pointing to a specific region, right? So this is general C# regions called intro. We're pointing to a source file, and we're pointing to a program.cs in my app. So let's see what this is. If I go over to my program.cs, you will notice that I have a couple of regions that already have a bunch of switch case statements, and I have a region called intro. So if I edited this and I said hello.netconf, and I saved this file, and let's just go ahead and run this again, .NET Try. I go back into my introduction to C#, and I've edited it, right? So there's a seamless difference. But another thing that we have to be careful with is that if anyone's written documentation, sometimes it gets out of sync. Like, how do we support our backing project as well as what we're putting in the documentation? We wanted to make sure that we supported that. So let's make some quick edits. Like, how do we verify code? So I'm going to go over to VS Code again, and I'm just going to make some clumsy mistakes over here. I am going to remove the semicolon, save that. I am going to change this from intro to intros. I'm going to save that again. And I want to show you a new addition we added called .NET Verify. Right? So what it's saying, it's .NET Try Verify. Right? So this is going through, and it's actually checking your markdown and checking your backing project to make sure that everything's going OK. And you'll notice that it says, hey, you're missing some things here. You're missing a semicolon, and we also haven't found the intros region. So we wanted to make sure that before you hit push into GitHub, you're able to actually see any issues that might pop out. Okay? And we enable you to do that. If you're someone who would prefer to see this in a UI format, it's also supported on the server on the UI side as well. So I'm just going to do this, do .NET Try. It's going to launch the local host again. And if I go over to the introductions, it will tell me that the region hasn't been found. So on both sides, you have this experience where users are easily able to catch what their mistakes are. So let's go on, since we've seen that. If you want to look at this more, you can go ahead to our GitHub repo and please give it a try. So I want to show you a little bit more in other experiences that we've been creating. So I showed you the .NET Try global tool, and I showed you .NET Try running in the browser. But I also wanted to show you something that we just did this week, and I'm really looking forward to hearing your feedback. If you go to our GitHub repo and you do .NET/try, and you scroll to the bottom, which is pretty long, you can notice that we have a lot of files in there. You'll notice that we have the .NET Try enable badge, but we also have launch to Binder. Now, Binder is a project, an open source project, where it's able to point to a GitHub repo and take out all the notebook files and run them in the browser. So they spin up a nice container, and you're able to look at it right within the browser. Over here, I already got this started. This is C# notebooks. Oh, sorry, let me start that again. Let's launch Binder. This is going to take a few minutes because it's configuring a container for us, and the beauty of live demos is that this will happen as the circle spins around. But what we wanted to show you here is that we want you to be able to try the .NET Notebook right within the browser. We wanted you to play around with it. Let me make this into C#. We're going to go into samples, and I have a housing ML sample right here. Right? So let's walk through this experience. You can install NuGet packages, right? So this allows you to customize it, add any NuGet packages that you'd like. I'm going to hit Shift Enter. What this is doing is it's going to NuGet, it's installing those packages for me. This will take a few minutes. But as we want you to know that if you are using this on your side, you can install as many packages as you would like. You can notice that we're using the ML package, we're using AutoML, and we're also pulling the data frames NuGet package as well. But as that's installing, let's look through the rest of the code so I can run through it. We're able to use our packages in the next cell. As some of you might know, notebooks have cell-by-cell execution. We also wanted to make sure that people had graphs being able to plot there. So we wanted to make sure that people were able to display graphs, scatter plots, right within the NuGet packages, right within the notebook. We wanted to make sure that we made this feel authentic to people who are coming from the Python notebook space, but we also wanted to make sure that our customers who are regular .NET developers, that this also felt authentic and natural to them. So I'm going to run the next next cell. Shift Enter. All right. And as you can see, we have a nice table that has been delayed. We've actually been able to display a table of the housing data. We can also plot some graphs, which I think would be the cool thing. So let's start looking at some cool stuff. All right, let's run that again. All right, so I'm going to go over to Docs, Samples, and Housing. Let's pull in some packages. Bear with me, I am so sorry. But this should take a faster time the next time around. We've installed our packages. We're waiting for just one more, which has been successfully installed. Let's run this. The housing data, right? So what we wanted people to be able to do was see the graphs and customize these graphs authentically. Okay, so let's give it a moment, and what we should see in a bit is a histogram that shows us a trend of all the housing data across California. Well, while we're doing that, just open up. Okay, let's do it one more time. I think the third. Yes, there we go. It just needed one more time. If you hit it hard enough, it will happen. So what we can see is that we have a histogram that shows all the data. If you're someone coming from the notebook space, we also have support, so you can zoom in and see these things in more detail. We also wanted to make sure that you're able to do more interesting graphs like scatter plots. So let's run this. Give it a moment. All right, and as you can see, we have a scatter plot, and guess which state this is? California. Sorry, I don't have a live audience. It's California. As we can see, the pricing is pretty high, but let's say I wanted to zoom in a little more. I can do this. I can zoom in on some of the hot spots. What this will do is that will actually cancel out everything else. So we wanted that rich interactive experience that people have come to expect, and we're looking forward to your feedback. So if you have any questions on how to get started with the .NET kernel, that would come at around Ignite time. We won't have anything for people to try at the moment. However, we do have the MindBinder experiences available right now. So if you go over to our GitHub page, and you'll be able to launch it right there from Launch MindBinder. So we have a couple of minutes for questions, I believe, when we have a chance, and we can give it a go.
Are we ready for questions?
We are ready for questions.
Fantastic. Well, hopefully you can see us here. I brought my brand new phone.
Hello.
That was really awkward. Well, you know, the first thing that's kind of cool is this one right here. Mika, how do you feel about what she just showed us?
I think it's awesome.
Have you ever tried try.net? You're going to love this. I'm reading upside down live.
I'm going to read it. Looks like a fairly simple way to learn and write some C# code inside your browser without having to first create a Visual Studio solution. Plus, lots of sample code aimed at new learners. Check it out.
You have a fan.
Yay! You really do.
And there's a GIF, and I'm going to say GIF for all of you out there listening. I will not say GIF. It's not peanut butter.
Okay.
Of the guy, the Australian guy, going like this, 2 thumbs up. All right, what else do we have over here?
Let's see. Wish this had been around when I was working on Bifrost.
Bifrost?
Bifrost. A few years back. Looks really impressive for .NET open source projects.
Like, I'm wondering if this guy's Thor.
I think you might be.
Okay.
I think you might be. Chris Hemworth, hi.
Yeah.
Oh, yeah.
Of course.
Hey, Chris.
Hi for me, too.
Yeah, we'll say hi.
All right. Here's another one from John. Great to see the improvements Microsoft has made in language platform documentation. I still remember the huge stack of books from C 6.0. That's a long time ago. Should have included a back brace with the product. This is pretty cool. I love the idea of being able to learn and read as you go. I'm personally a fan of notebooks. I'm so glad C# is coming to it. And the try.net stuff is really cool.
Yeah,
so
awesome.
If you could give people one takeaway from your session, what would it be?
It would be number one. Can it only be one, or can I give 2?
You could give as many as you want.
Okay.
This is your
so,
session.
Number one, please go and try the .NET Try Global tool. Give it a try. Make sure you're using it for your next workshop. We're looking forward to hearing how you're doing with it. We've had people try it with workshops that are pulling from Azure Functions, so I would love to see more workshops with that. Also, if you want to give the Binder experience a try, let me walk through that experience one more time.
One more time.
So people can look at it, because I had some technical issues, because that's the world. So let's do that. So if you go to our GitHub repo, which is .NET/try, you scroll down all our code base, you'll notice Launch My Binder, right? So when you launch My Binder, what this is doing is that it is spinning up a container for you, and you're able to actually start running and writing that code right within the browser. So it's pulling in the .NET Core SDK and all that kind of stuff. Now, for it to even look nicer, look at it in the lab format, which I just think is always like a nicer way to look at this experience.
I'm a fan.
It's really cool. I also want to point out we do have F# support. I I don't know if people saw that.
Is that because Philip's next?
Philip is
okay.
next, and I just felt I almost didn't tell. I didn't say it.
That's right.
We do have F# support. So if you went there, you go to Docs. There's an output. There is a bug which I can fix right now. Hit run, but this has all the nice F# expectations that people will have, and my team will continue to work on that.
Fantastic.
If you look at C# as well, let's go up one. Look at C#. You will find two different samples. You'll have one which is the housing sample. And just to give reference to this housing sample, it was literally pulled out of a data science book. And Eric did a side-by-side and was able to replicate this entire experience right within the browser. And we also have a repo one, which I should have run, to show you how we are actively keeping track on the issues that you're doing, and we are actively trying to close them.
Fantastic.
Yeah, and then wait for Ignite so you can start installing the bits on your machine.
All right.
Nice. We have another question. Is it possible to integrate Try.net with DocFX documentation?
Try.net and DocFX.
Not at the moment, no.
Okay.
Okay, and I think there's one more. Is it this one?
Yeah. Can I take a subset of the Try.net code and use it to incorporate C# scripts within existing applications?
Ooh, Jeremy, good question. Yes, you can. Just look at our repo and ask us questions.
And here's another one with
Okay.
another
Also,
GIF.
GIF.
Yoda.
Wise one.
It says, so do what you can as there is no try. Try.net.net. Like, I love the
that.
.net, the cool with Jupyter Notebooks. Look at that.
So, sorry, what was the thing again?
I'm trying to like parse it. This is really good stuff.
Okay.
It says, so do what you can as there is no try. Try.net. The cool with Jupyter Notebooks.com.
I will decipher that. But I think he's saying Try.net is cool, and we're also excited about the Jupyter Notebooks experience.
Oh my goodness, she is so good. Are we ready to go to the next session?
Yeah, we have what's new in F# with Philip. So, Philip.
Now, is it Philip or Phil, or is it like, do I have to say it with a British accent? Philip.
No. You could say His Majesty Philip Carter.
Of course, and that, like I do normally.
Something like that.
Let's do that. Well, welcome.
All right, King Seth. Thank you. Hi, my name's Philip Carter. I'll look in different cameras. And I'm here to talk today about what's new with F#, because I work on F# and other .NET stuff on the F# and .NET team. So, yeah, I want to give a little bit of an overview first. The first is I want to give a slight recap of F# 4.6, which we released earlier this year, and we've been making some improvements on sort of leading up to the F# 4.7 release. So I think it's good to sort of talk about that sort of stuff, right before talking about the brand new stuff. I then want to talk about brand new stuff with F# 4.7. And then I want to talk about brand new stuff, like even newer than the brand new stuff, in F# preview bits, which we're actually shipping alongside F# 4.7. This is actually the first time that we're doing this, so it's pretty radical. So F# 4.6, this was released earlier this year with Visual Studio 2019. However, we've been making incremental improvements, especially to the tools, since that release. So F# 4.6 wasn't really kind of this thing that came out and now it's done. It's something that's been continually improved upon. And really the big pieces there were just performance. So what you see here are two issues on our GitHub repository that are related to tooling performance. And interestingly enough, this tooling work is not necessarily in the tools so much as it is in the compiler. And so what I mean by that is the F# compiler has been around for a while, and it's very well optimized for compiling code, right? You take some code, you run the compiler against it, you get an assembly, you can run that assembly. It's very good at doing that sort of stuff. However, what some people may not necessarily know is that the F# compiler that we use to actually compile your code is also the same compiler that's hosted inside of Visual Studio, inside of Visual Studio Code, and VS for Mac, that sort of stuff. So, the same code paths that we have internally that take your code into minute assembly are, the ones that are run when you're asking for things like IntelliSense or tooltips or things like that. And one of the problems that we identified was things that were very highly optimized for just a single pass compilation, produce an assembly, were not necessarily optimized in a long-lived process, sort of like a server process, you could imagine, inside of tooling. And so as you can see, there's a whole bunch of problems that were here that are all checked off because they're all issues that were fixed. And the end result is just massive performance improvements in all of your tooling, especially if you have really large solutions. So this is something that came out with F# 4.6, but it's also been continually improving. And so I like to think of F# 4.6 as this thing that, over the course of multiple releases has just gotten a lot better leading up to the F# 4.7 release. So the other thing that was sort of mentioned there with F# 4.6 was the anonymous records feature. And I want to show that in Visual Studio Code just a little bit before I get into the new stuff. So moving over here into Visual Studio Code, which I will point out is using the official F# plugin known as Ionide, which has about 1.4 million downloads now. It's running F# 4.6. It's actually the F# 4.7 compiler, but I'm just showing F# 4.6 right now. And I'm going to show you a little bit about anonymous records. So for F# programmers out there who are familiar with records, you know them very well as these types that you can declare up front. They're just really neat little data holders. And you can do a whole bunch of different stuff with them. And then a lot of F# programmers are very used to tuples, where you can just sort of ad hoc, kind of on the fly when you need it, group some stuff together, and then do whatever you want to do with it. But the problem with tuples is you don't get as good a tooling support as you do with records, right? You can't rename labels. It's not able to track things as well, and that's just sort of inherent with tuples being a bit more of a lightweight thing, and records kind of being this. Okay, well I declared a type. Now I'm going to instantiate this type. I'm going to use it in this particular way, and a lot of people want something in between. They want some of the tooling support that you get with records. However, they also want sort of that ad hoc, hey, on the fly, I just want to construct a few things and do some stuff with it. And then later on, they may actually decide, hey, that ad hoc stuff that I constructed, I want to pull that out into a real type declaration. And you can't really do that with tuples today. So that's one of the primary reasons why anonymous records exists. So walking through the code here, we've got this function. It's called getCircleStats. Takes in a radius, which is a float. And you'll notice if I hover over here, there's kind of a big tooltip here. It's saying getCircleStats, given a radius, produces this little bracket thingy. And that's an anonymous record type. You notice there's the little bracket and the bar. Regular records don't have the bar. Anonymous records do. That's sort of the main way that you distinguish them in syntax. And so I get the area, the diameter, the circumference, just normal math stuff. And then I construct some stats about that, about the circle that is defined by the radius that I was given. Right? It's got a diameter, it's got an area of the circle, and it's got a circumference. And so when I actually call that code, I can get my little radius value. In this case, it's 3.0. I get the circle stats, and then I can print the values out. So if this were a tuple, right? If I were to do something like this, there's nothing stopping me from doing something like this, right? Just sort of returning a tuple and then decomposing the tuple at the call site and then calling it there. But I have to construct the names at the call site every time to get access to stuff, and especially if I have like a lot of stuff that has like meaningful names that I want to change over time. Maybe I don't like the name, I want to refactor it a little bit. I can't really do that with tuples. And in fact, now if I want to refactor this, I can just go ahead and do that right here. I can go rename, and I'll just call that area because area of the circle is a bit redundant. And boom, it automatically changes it. I don't have to go and find the name that I constructed from the tuple that I got back and then also rename that. I can just do it on the fly. So this is pretty much what you can already do with record types. Like I could have defined a CircleStats type as a record up front and then constructed an instance of one of those. But what if I wanted to sort of ad hoc group the radius value with these other values that I have here? Well, again, that sort of thing, I could do something like this. I could go, let the group is, I could tuple, I could go radius, and I could go CircleStats, and there we go. This is sort of a typical thing that you would do in F#. But again, what if I want it, but I want like an actual radius value that I could then refactor over time? That's where anonymous records really shine here. So I'll call this more CircleStats. And I'm going to take my CircleStats value that I have here, and I'm going to use copy and update syntax that you would normally have with a regular record. However, instead of just copying the record into a new, with a new value, I'm going to throw a new field on there. So I'm going to say CircleStats with radius equals radius. And now I could print this out. I could go more CircleStats dot radius, and there we go. I have that. And that sort of gives you the power of being able to ad hoc group things up like you would with tuples, but also get some of the niceness that you have with records. Now, there's a little bit more that you can do with anonymous records. I want to show just sort of briefly, if you're doing type declarations, there's a bit of code here. But so you may have something like a discriminated union type. You know, an employee could either be an engineer, a manager, or an executive. And so, you know, but I may want to have a bunch of data associated with each of those types. Now, a very common way to do that sort of thing is to do something like this, right? I could have a manager type here. Manager, there we go. I didn't spell it correctly. And so I may want to have a record that holds the data and have, you know, that sort of grow over time. But, you know, if I want to group things up in a way that's convenient, I need to use recursive type declarations, which that's nice if you want to sound like you're really fancy to your coworkers or something. But what it actually means, you have to write more code and you have to sort of declare something as like a big old unit together. Now, I could tuple these up. I could have, you know, like a name is a string, and then I could say, you know, reports is an employee list. But then that's a tuple instead of a record type. And what if I want to have a record type? Well, now I have to actually make it, you know, the name manager. Well, with anonymous records, you don't have to do that at all. You'll notice there's less code here. There's no need for a recursive type declaration. And that's because, you know, I've just sort of inlined the record here. So again, you get sort of the benefit of both worlds here of, you know, having sort of an ad hoc grouping of values, but in this case, in a type declaration. And that's pretty powerful for anonymous records. So moving on. F# 4.6, it's great. We released it. We made some improvements. Some improvements are actually shipping in the VS 16.3 release. But the new stuff is F# 4.7 and the F# preview that we shipped alongside it. Now, this, I think, I'm a little bit more excited about, mostly because we just shipped it yesterday. It includes a few things, mainly language versioning in the compiler itself, which I'll talk about a bit, implicit yields, and some relaxed syntax, which is, I'll go over that a little bit. The high-level bit here is it just makes your code easier to write, sort of less surprises. Things are a bit more consistent with other things in the language. And then F# preview has some new features that I'll show off here. So I'm going to show off some of this stuff, but instead of VS Code, I'm going to hop over to Visual Studio here, the old big IDE, and we'll get going. So I have a console project here named it F# 4.7. This is .NET Core project. And I want to sort of demonstrate what implicit yields mean by taking you from a compile error to working code. So as you may have noticed, there's a red squiggle here. Right? I can generate a sequence with a range expression. I can go, OK, give me from 1 to 10. That's a new sequence. Awesome. Cool. Well, what if I just want a sequence comprised of 1, 2, and 3? Right? Well, now it says invalid object, sequence, or record expression. That's what? That's pretty weird. Now, you can actually do this in lists and arrays, but you can't do it with sequences, which is kind of weird. In fact, you have to sprinkle this keyword everywhere. This yield keyword, and you know, especially if you're a beginner to the language, this is not very fun. It's not very discoverable. The error message doesn't tell you anything about it. And you know, we could improve the error message, but you know, we figured we might as well improve the language instead of, you know, fix the root problem, not necessarily just make the diagnostics a little bit better. We also have this function called getDaysOfWeek that produces a list, and this same problem actually shows itself in things that are not sequences. If you decide to start conditionally generating things. So in this case, I want to generate Monday, Tuesday, Wednesday, Thursday, Friday, but if include weekend is true, I also want to give back Saturday and Sunday. Now, there's just a bunch of stuff here. This is a horrible error message, frankly. Now, again, I could put in a yield, and yes, it turns out I have to put yields in absolutely every single spot, and that's the only way to get rid of that error message. At least that's the way that things were up until F# 4.7. Now, if I open up my project file, you'll notice that I have this lang version property up here, and I've explicitly set it to 4.6, which is the older, well, I shouldn't say older, the one that I just talked about here. And so I'm just going to comment that out, because this is a new project, and so new projects implicitly use the latest lang version, so you don't have to always set it yourself. And if I go back to this file, voila, all of the error messages are gone because all of these yields can now be made implicit. Now, granted, I can, if I'm really in love with these yields, I can add them all back, and the compiler's totally fine with that. So this is backwards compatible. You know, there's no issue with doing that the old way, but we think that a lot of people are going to like doing this, you know, the new way once they're in F# 4.7. So speaking of doing things a little bit better, we got a wonderful feature that was contributed by one of our community members. His name is Gustavo Leon. And there's a couple things I want to point out here. So first, you can declare, you know, this is how you declare an object in F#. And we require an explicit this pointer for members. You know, I could name this anything I want. I can name it this or self or something like that. This is just sort of a convention of the language. Now, you'll notice this is grayed out. And that's because I'm not actually using self. I'm not really doing anything, you know, recursively with this class. So what typical F# programmers would do is they'd say, OK, well, you know, I'm just going to put an underbar there that indicates that, you know, that it doesn't really matter, the this pointer. But you had to do a double underbar, and that's because what could perhaps be viewed as a bug in the parser sort of had this little weird quirk where you had to put a double underbar instead of a single underbar. Whereas in pretty much everywhere else in the language, if you want to just discard something or say, I don't really care what the name is, you can just have a single underbar. So this was fixed by Gustavo Leon, and it's a wonderful little change. It's just kind of one of those things that, you know, it's these little paper cuts that can get you sometimes when you're working in a language, especially if it's a new language and you're not quite familiar with its idioms. And this is just one of those things that cleans up some of those paper cuts. And the little code fixer here knows to prefix it. Well, in this case, it actually prefixed it with underscore. That's one of the options that you have. The code fixer will also actually do the same there. So the tooling is also up to date with that particular feature. Speaking of relaxations, this part of the demo is actually, it's really nothing. It's just looking at the code. And the reason why I think that's important is because if you've been using F# prior to F# 4.7, you know that you would not be able to write this code today. You would have to tab everything over like this. You would have to align this B and this D with this A. And that was the only way that you could get the compiler to actually accept this particular declaration of the constructor that you have here. And frankly, that's just kind of annoying. So we just made it so you got to indent over 1. And the same thing applies to static methods in this case. So again, before, you had to move all of these over so that they were perfectly aligned with the first parameter that you laid out. Now they don't have to be. They just need to have 1 indentation level over so that the compiler can understand that these are referring to the method that you're declaring right here. So that's kind of, you know, aside from a whole bunch of bug fixes and more perfect performance improvements, that's kind of what's going on for F# 4.7. But let's talk a little bit about F# preview, because that's where things start to get a little bit fancy here. So I'm going to go back to my project file, and I'm going to uncomment out this lang version flag, because this is something I'm going to have to actually do now if I want to use preview features. I'm going to clear out 4.6. I'm going to type preview. So if I save that, now I can open up this file called nameof. And you'll notice that there's no red squiggles. And that's because we've sort of activated the preview mode. So internally, the way that we do things in the compiler is whenever there's a feature that's implemented now, it's associated with a feature flag. And then that feature flag is associated with a given release of the language. So in this case, nameof has the nameof feature flag. And that feature flag is associated with the preview release of the F# compiler. So what that actually means is if you set your lang version to be preview, you will get everything that's associated with that internally, one of them being nameof. So going back to the code here, this is just sort of some basic usage that you could, it's pretty self-explanatory, right? I have a function, it's called combine lengths. I take 2 strings, str1 and str2, and I want to dot and get the length of both of them and combine them. Pretty straightforward. I just want to make sure that they're not null before I actually do that. And in this case, I'm going to raise an argument null exception. And then I want to pass the name of the parameter there. So in this case, before, I would have to do this. Or oh, there we go. I would have to do something like that. And if I change the name of the parameter, I would have to know to go back into the string literal and also change it. That you don't have to do if you're on the F# preview anymore. You can just take the name of everything that you're working with, and that's pretty great. This has been around in C# for a while, and this is something that's been highly requested by the F# community for a number of years. It's extremely powerful if you're doing a lot of logging of parameters and different values, and you want to sort of log, okay, this thing which was, nested in this thing and nested in this thing, and you want to lay it all out and get it into strings. You can refactor with ease and know that you don't have to actually update anything else from there. So, just to show a little bit more of what you can do with nameof, I have a module with a function, and then I have the system namespace up there. So I'm actually taking the name of the namespace, so you can do that if you'd like. I'm taking the name of a module that I declared, and I'm taking the name of an explicitly qualified function, m.f, that's the name of the actual function. I'll take the name. And just for kicks, I can go let nameof, and I can take name of itself. Now, this is probably not very useful for anyone, but it just happened to be something that was enabled by the feature, and so there's kind of no reason not to keep it. So we have it, and it's fun. So the next feature that's shipping in the F# preview is opening of static classes. So let me go up right here. So a static class is, it's just got a bunch of static methods on it, or static members, or maybe some constants, things like that. One of the best examples of a static class is the system.math class. And historically, if you're in F#, you would have to go math dot, you would have to explicitly qualify math dot whatever you want to use to be able to actually use it. But now you can just actually open this thing. And if you were to do this in F# 4.7 or F# 4.6, you did not have the preview turned on, you would actually get an error saying that there is no namespace called system.math. And that's because it's a class. It's not a namespace. And so what that means is I could just call sign of pi rather than math.sign of math.pi. It's the sort of thing that is really handy if you're working with the math namespace and other libraries that do this sort of thing where they put this kind of functionality behind static classes. And this is also helpful for F# programmers who want to create DSLs that use method overloads, just like you can do a little bit in C#. And you can actually declare those in F# today. Because as it turns out, a static class it's not really like a real thing. It's an abstract sealed class in .NET. And so you just create a type that is both abstract and sealed, and you give it some static members. In this case, I gave it L, M, N, O, and P. And then you can open this class when you have the feature enabled, and you can just call them like that. I don't have to explicitly specify my static class.L of my static class.M of my static class, and so on. This is something that we're pretty excited about, especially with some of the focus on working with machine learning frameworks that we've been doing lately, because a lot of these frameworks for .NET are using static classes to sort of pack these method overloads behind there, but have it be sort of a functional interface. And this will play very nicely with that sort of stuff in the future. So that just about rounds out F# 4.7 and the F# preview. So as a quick summary here, F# 4.6, we shipped anonymous records. We've made improvements to those and the tooling for them over time. It works pretty much everywhere. And there's been tons of performance improvements in the compiler and the tools since it was released all the way up until now, and also including this release with F# 4.7. F# 4.7, once I fix the spelling error here. I like to think of it, it just sort of makes things easier for you as an F# programmer. It cleans up a lot of little things, and especially if you're using these yields a lot, like if you're writing WebSharper or Fable code, which uses lists and as sort of like an HTML style DSL, something like that. This makes it a lot easier. And then the lang version support allows you to sort of bump up to a preview, try some stuff out, give us a lot of feedback, get access to those features way earlier before they actually ship. And then F# preview is all about features right now. We're just going to keep building features and shipping features starting now, pretty much all the way until the middle of next year before we start stabilizing for the .NET 5 release. So if you want to get started with F# 4.7, there's just a single link you got to go to. You just go to aka.ms/F# home. This takes us to the F# homepage on the .NET website. And if you go there, there's just a big old button that says Get Started. It'll take you to download the latest .NET SDK, and you can do that. You'll have F# 4.7 already available, and then you'll be able to get off and go running with it. So.
All right, is it time for questions?
I believe it is.
So as I came in, Mika thought, because it's my turn, she's like, hey, I'm gonna write down some cool F# jokes, and I'm just gonna read them in the order they were given. Okay, you let me know if they're funny.
Actually, sorry, Seth, I have to pause you. It's not pronounced F#. It's pronounced F octothorpe or Foctothorpe for short.
There you go. So that was F#ing fantastic.
Ooh.
What the F# is F#? Like, I like the courtesy laugh. Mika, we're only getting courtesy laughs on this one, just FYI. Next one. Knock, knock.
Who's there?
F.
F who?
F#.
Ooh, I didn't see that one coming.
I know. I mean, it's really good stuff. Here's the first one, by the way, from Jeffrey Huntley from California. Overheard.
I think the CA is Canada. Or it could be California. What do you think?
Only Jeffrey can tell us. Jeffrey Huntley from California or Canada. I mean, it could be. I'm gonna get the pencil out of the way here for you. Overheard Ionide Project has millions of downloads.
Yes, indeed.
Nice. What's the Ionide Project?
The Ionide Project is I like to say it's the F#, sort of the official F# plugin for Visual Studio Code. It's built by the community, but it's something that we've also worked with them a lot to make a lot better because, frankly, a lot of people use it. And so we've been coordinating with them, especially in some of those performance improvements that I talked about.
Fantastic. So here is from Heisenberg himself. Why is F# so complicated? There is a myth that F# is complicated. What say you, Philip?
I don't think it's particularly complicated. There's a lot less syntax that I need to do to actually get my work done. C# is a wonderful language, but I kind of get lost in the curlies a lot, and so, yeah.
I will say that as soon as you think functionally, it changes the way you write your code everywhere else. Except my first functional language, I'm going to go way back, was 2007. It was F#. Before it was even released, I wrote a blog post on my little blog. It was like the first one I had ever written. And guess who commented on my code?
Santa Claus.
It was Don Syme, who is the F# Santa Claus. He's like, this is really nice. You could make your code better by doing this. It was pretty good. So thank you so much, Philip.
Absolutely.
We have coming up next, tips and tricks on moving to .NET Core with Kathleen Dollar. But before that, we're going to go to just a tiny commercial break. Let's take you to that right now.
Hey there, treasure hunters. Our friends at Preemptive have your next clue. Provide the secret key to unlock the treasure. The landing page will guide you. Go to this URL to find that secret key. Figure out what it is, whisper your response to the .NET bot in the Visual Studio Twitch channel, and you could be well on your way to the next step in our technical treasure hunt.
In this video, we're going to talk about how to get involved with .NET and the whole community in general. So I brought Scott Hanselman along, who's kind of an expert at this.
I don't know about that, but I want everyone to feel as welcome as possible. And we have such a great community and so many great resources. I'm excited to sit here with you and share them with everyone.
Awesome. So we actually have a website completely devoted to the .NET community. So you can go to .NET.Microsoft.com and just hit this community tab. And first off, we can talk about meetups. So we have an awesome meetup site for .NET events happening all around the world. You can find something local in your area, or if there's nothing local in your area,
make a meetup, right? We've got meetups everywhere. There's hundreds and hundreds of meetups out there, lots of groups, but maybe the meetup is too far away. Maybe you should make one. We'll actually help you make a meetup. We'll give you a section on the site here. We've even got presentations and sample code for you to start giving your first talks at your new meetup that you will make in your town.
Definitely. So next up, we are pretty active on Stack Overflow, Twitter, and GitHub, especially Twitter. We're always talking about the latest and greatest stuff we have out, so if you want to follow any of our Twitter accounts, they're all listed there. GitHub is often where I hang out. Again, so much of our development is open source, so we directly interact with you, our users, on a regular basis. So it's a good way to immediately engage with our development teams.
But these aren't the only places that we hang out. There's a lot more. So if you keep scrolling down, .NET and the .NET community is everywhere that you want to be. So if you're not comfortable on Twitter or GitHub, we're on Facebook. We also have places where you can talk to us and interact with us in a video or a podcast format. We've got regular shows and regular podcasts, as well as a community stand-up, where we just kind of talk about the community and we'll interact live with you on YouTube chat.
Yeah, and that's every week. Next up, so we do have a lot of blogs coming out, as well as Gitter and Discord channels. If you want to hop immediately on a chat, we have channels in there for beginners, as well as people who really want to just talk about C# designs and all of the various things we could do with the language.
Another thing that I might want to point out, if you don't mind scrolling up a little bit, is the .NET Foundation website. If we could open that up in another tab, .NET Foundation has got a bunch of resources for you to dive into projects, but if you scroll down a little bit, there's a section on, these are all the projects. Look how big the community is. Isn't that great?
Yeah.
Go down here, and a little bit farther down, you see Jasmine, and there's Find a Meetup, and then a little bit farther down, we've got, keep going, resources, build your own event. Look at that. Browsing resources, free workshop code, free presentations. This is a way for you to jumpstart your own community. All of these things are available to you, but it all started at the .NET Community website.
So check out the .NET Community website to figure out how to get more involved. Thank you so much for watching the Visual Studio Intro series. We have tons of other videos coming out on C# and .NET Core, ASP.NET. Be sure to check those out.
Welcome back, treasure hunters. I have your next clue from our friends at Twilio. And they have this to say. Sometimes a song and a moment become so intertwined it becomes impossible to distinguish the two. One such song, one that created one such moment, is the answer to this puzzle. But can you roll with the punches and discover the song? The answer lies at the end, or maybe the beginning, of your Twilio quest. Go to this URL to get started and find that answer. Whisper your response to the .NET bot in the Visual Studio channel, and you could be well on your way to the next step in your technical treasure hunt.
Hi, this is Kathleen Dollar from the .NET Core team at Microsoft, and I'm here today with Rich Landert to talk about some tips for moving to .NET Core. How are you doing today?
Great. So the way I kind of think about this talk is I often meet with these big customers who come to campus and ask us for guidance. And I'm like pushing .NET Core, and they're like, Rich, don't lie to me. You know, tell me the truth. Tell me how it really is.
Yeah.
So this is supposed to be the how it really is talk for moving to .NET Core, right?
We're certainly aiming that direction, and we're going to be going into a few places you might not really expect us to go, including spending some time on making that decision about whether to go to .NET Core and when to do it. So let's start out.
And no lying.
We're not going to lie to you. We're going to try really hard not to lie to you, okay?
Definitely.
So we're going to start out, like I said, with should you do it in the first place? Should you port to .NET Core? How are you going to prepare for it? And then some tips about porting it. But that's actually not the biggest part of the talk. The biggest part is the setting up, which I think is going to be the experience you have as well.
Kind of like how to make the plan.
How to make the plan, how to detail that down to being able to carry it out. So before we do that, I think we should start with why do it in the first place? What's good about .NET Core? Because then we're going to talk about some pain points. And I don't want to do that without first saying, why bother? And so these are some of the benefits for .NET Core. We think for a lot of people, the side-by-side installation, that's installation of the runtime, that also can be one of the pain points. But it's a benefit in that you can have two applications on the same, in the same space, two applications on the same VM or the same machine, and they're each running their own copy of the runtime.
And don't interfere with one
at
another.
All. Not at all. All right, it's also faster. It's cross-platform and open source, and it will be getting new features while .NET Framework is now stabilized.
Yeah, it's faster though. One thing we actually forgot to say, it's faster and uses less memory.
It does, and that's super important because when you actually measure just one little piece of code, you can see the speed of that. But what's much, much harder to get a handle on is how the allocations going on in the background are increasing your load for GC, and then you wind up with GC pressure and kicking in a GC.
Sure.
So allocations are super important for a couple of reasons. That's the main
But
one.
yeah, the simplest thing is, if you have a hosted environment with servers, you can pack more apps onto the same machine.
Right. All right. Let's go. All right. So you can find out more about the .NET Core 3 features at this blog post, which Rich did.
Great blog
so
post.
since Rich wrote it, he's pretty excited about that. So should you move?
Big question.
All right. We're going to look at a couple of considerations, and we're just going to walk through each of these.
Yeah, and just one tiny bit is, I've been on, talking to customers on campus, but also I've been to customer sites, I think mostly in the United States, but maybe in other countries too. Definitely in other countries. This question is very real. Because, different companies work different ways, but a lot of times you have like a higher level manager who's resistant to change. And they're like, show me why we should really do this, and is the risk is it low?
Yeah. So this is some of the things you can do to establish specifics about what it's going to take and where you're going to get value from it. We definitely encourage you to go if you can find the value, and that's why the benefit slide is super important. And I hope that when you come back and consider this, you will explore the great things about .NET Core, but not in isolation. You want to look at those alongside the cost. So before we go there,
can I just say one more thing?
Yeah.
Back to these managers that are resistant that you kind of have to prove this to. I was at this one customer, let's say, I think it was in last spring, and we did this project with them, and the management was kind of resistant. And then we did this prototype. We spent like a day upgrading their app. We were actually able to give them real numbers. They were like, whoa, this actually looks pretty good. And this was
were they real? Was it performance numbers?
Yeah, it was performance numbers. This is back in like preview 3.
Yeah, and now it's better.
Of .NET Core. Yeah, well now we ship too.
Yeah,
so.
it's great. Okay, so before we get into some of those specifics, I do want to look at some other concerns that are kind of things that aren't the right reasons to make a decision. So let's take a quick look at these. And so the first thing is, if you're worried about .NET Framework not being supported, that's not in and of itself a good reason to move. So it will be supported for a very long time.
Yeah,
and
I agree.
I understand that in response to that, you might say, hey, but there was this thing, whichever thing it is, that comes to mind. And .NET Framework is actually really different than anything that's been out there before that's undergone a similar change. And the first reason is that it's a Windows component. And so it's part of Windows. Windows needs it.
It's literally on the Windows DVD if we still have those, the DVDs.
For those of you that remember what a DVD is.
Yeah.
So then also it's used heavily within Microsoft. And it's, in fact, Visual Studio.
Yes, that's an example.
Visual Studio is a .NET Framework application right now. So, and then the biggest reason I think is that this is not something, this change to .NET Core and .NET Framework, splitting a bit here. It's not only to free us up to do great things in the future with .NET Core. It is definitely to do that, but it's also to say we don't even have a good estimate of how many apps there are out in the wild.
Millions.
And that's working. It's working and it's getting things done for people. And so stabilizing that aspect of our ecosystem is important to us and important to being able to set it for the future with this base of existing apps being solid where they are. So I think it's super important to think about. There's great reasons to go to .NET Core. Being afraid that we're going to pull the plug on .NET Framework
isn't one of them.
It's not one of them.
Yeah.
A couple other things. You need NT services. Cool. We can do that. Sorry. Oh, and then licensing. So if you're concerned about our license, we are MIT, and we think that that is a good license for business. And if you want to hear more about that, let us know, and we'll get Rich to write a blog post.
Yeah. I'll just say one tiny thing about that. And this is where I've talked to several customers, some of them very, very large. So our source is MIT, which is the part that's friendly to business. But a lot of customers want to hear from us that they're still installing Microsoft provided software. And when you actually go download .NET Core from the website, that's actually like a Microsoft build. And it's if you want to think of it as a Microsoft proprietary product, feel free. It is built from open source, but it's supported by Microsoft, and it is a Microsoft product. So there's nothing scary there at all. So if you want to use the word open source, you can. Some people really love that, and it's true. If you want to use the word like, Microsoft certified and supported, you can use that word too, and it's also true.
It's both true, right?
It's both true.
We sign it. We also provide the source code for people like Red Hat to build it separately.
Yeah.
So we've worked really hard to be on both sides of this fence.
We're kind of doing all the things.
We think it's great to be both at once, and we think we're hitting that. So Microsoft is still, we're still. Nobody's going to do anything crazy.
We're still
in
a
there.
commercial
We
software
are watching
company.
it very closely.
Yeah.
We approve every commit. We're watching it very closely. It's very safe. At the same time, we do take commits from the community. We're thrilled to do that. And I think it's worked out really well. Okay, so let's get into those specific questions. And the first one is your application in active development? Because if you only open your application occasionally and it's to do very small things like change what the current year is, you're just not going to gain a lot. The new features.
Well, there's the other side of it is maybe it's an enormous app that has a very slow rate of change. That's probably the one that you most want to think about is if you only have this one developer left who's working on this mega app, then that may not be the best thing to move to .NET Core. It has to be under active development, and you kind of want to have some kind of team.
And I want to kind of clarify that. It's because the active moving will put it under active development.
Yes.
And so if that's sensible, hey, then that's great.
That's actually a perfect way of putting it.
Yeah, it's going to force it. So we'll talk a little bit more about thinking about that. The frameworks, we have some stuff that's not going to be there. Most things are there. WinForms and WPF there now in 3.0. And then there's the Windows Compatibility Pack will bring some more things in. So there's a number of things that are actually there, but there's some important ones that aren't going to be there. I think a couple of things of app domains are there, aren't they? Or is that completely?
No, so the app domain type is there, and some of the basic functionality, like for example, getting the list of assemblies, is there, but the fundamental concept of app domains is definitely not there.
Right, so it doesn't make sense to do things in a particular way on .NET Core for some of these things, and so they're just not there. That's if you're web forms, you're looking at a pretty deep reconsideration of your application.
Can I say one more thing about the last slide?
You can always say one more thing, Rich.
So one of the things we've been doing over the last few years is it's like, okay, we're going to bring more functionality into .NET Core that you used in .NET Framework, and and we definitely did that in .NET Core 3.0. We brought Windows Forms and WPF, and those were obviously very big projects. That is the end of that journey, the journey of bringing more .NET Framework functionality into .NET Core. So we feel like we did a great job. We took a ton of customer feedback. We added, like if you look at between .NET Core 1.0 and .NET Core 2.1, we added 40,000 APIs, and that's not even including what we did with Windows Forms and WPF. So we feel really good about what we did, but this is the end of that particular phase. So there's all these things on the right-hand side. Those are not the next candidates we're going to bring back. Those are going to remain on that list on the right. And now we're going to go do other things, but not more .NET Framework functionality.
Right, so waiting to see if web forms or WCF.
Exactly.
Sorry. It's just not in the cards. So, and there's some good reasons for these. None of this was arbitrary. It was all, we took a very deep look at all of these things and how it would impact .NET Core, and where we felt that it was not going to come forward with enough compatibility without being inconsistent with .NET Core. It went on this list. So it's, All right. So next thing is to talk about support policy. Doesn't that sound exciting?
Yeah. I remember when I first before you worked here, I was telling you about the support policy. Do you remember that at MVP Summit?
Yeah, and I was
I was talking to you and Julie.
Yeah, so the support policy is different for .NET Framework and .NET Core. So I'm going to talk here for a minute about the .NET Core support policy. And a year ago, in December, not quite a year ago, we released 2.2, and then 3.0 we released, like right now. We just released it.
Yesterday.
That's where we are. So let's look at the schedule going forward, because we've announced the schedule.
Yes,
and we think that's a great idea, so you know what it's going to be. So first of all, in November, we're going to have 3.1, and we're calling that LTS, which is long-term support, and I'll explain what that means. Coming up after that, we're going to have a major release every year, and every other year it's going to be LTS. So this LTS thing is pretty important. So you can think of it like a second train, and along that second train track, we have LTS versions. And one of the reasons that this visualization is kind of important is that it's hard to jump across the track in between. So for example, if you're on .NET 5.0 and you want to get back to 3.1 because you want to jump across halfway through, you have to go back to 3.1, which may not be an easy thing to do. So your best bet is to pick one of these tracks and then be able to commit to it. That's the best way to go about it. So let's talk about the specific support policy, and here's a link to it. You can go read it, and everything here is a visualization of that. It's true. This is my picture. So first of all, what does LTS look like? The current LTS today is 2.1. And we have announced a special date for it, which is August 21st of it was released 2018, so it will go out of support August 21st. I think that may be 23rd there. I may have a typo in this slide of 2021.
Well, that's a minimum. It depends on when.
Yes.
Yeah, it depends on when we ship 3.1. But I guess that will be the date, actually.
Yeah.
Yes.
There's a special date for that one because we were settling on the final policy right then. It had been discussed for a while before that. But that's when we committed to the policy, so there's kind of a special date on that one. All of these are minimums. We could extend support further. It hasn't been our pattern, so I certainly don't think you want to count on any of these extending beyond these dates. It might happen. So 3.1. It's 3 years from the date of release. It's actually 3 years from the date of the release, unless we run late on the next release, and then we expect to go a year past that. But the easiest way to think about it is 3 years.
Yeah,
that's the easiest way to think about it. So what's the current then? That's what LTS does. Current track is 2.2. Will go out of support on December 23rd of this year. .NET Core 3.0, which is releasing today, will go out 3 months after 3.1 ships.
Go out of support.
Go out of support. Sorry. Yes, go out of support. 3 months after 3.1 ships. We don't know exactly what the pattern will be around 5.0, and the reason is that we don't really anticipate point releases at this point in the 3.1 timeframe. We don't really expect.
Meaning of 3.2.
A 3.2, exactly.
We don't have any plans on that.
There's no plans for 3.2 or 3.3. We don't know what our plans will be for 5.0. So we could see a 5.1 or a 5.2. We just don't know yet. So that's what we can look forward to. So you can see that the support is significantly smaller. And this is not to scale. The stuff on the left is a bit more spread out than the stuff on the right.
Yeah, so the thing I'd like to add on this is if we look at, say, 3.0 to 3.1 in particular, the level of kind of migration cost between those should be extremely low.
Absolutely.
So, in terms, like the thing that I would be doing if I was trying to interpret this, like if I had a team building an application, I would just always stay on tip. I would just stay on the latest version, and then my team would get all the benefit of all the latest features. And I know that the Microsoft team is trying to make those as compatible as possible. And probably my server costs are going to be lower than someone else's who doesn't stay on tip.
Yeah, this is absolutely true because not only are you going to be getting the new features, so nullability is, you would get that if you are on 3.0 right now. If you're in the LTS 2.1, you don't get nullability, you don't get async streams. All the great stuff you're hearing about, you don't get F# 4.7. All the great stuff that we're doing, you don't get that.
Or all the new Docker limits support that we
That's right.
added in 3.0, or like the much smaller SDK that's in 3.0.
Right. Performance.
Yeah,
so
tons of performance.
there's a lot of reasons to stay on the tip. However, we feel like it's important for it to be your choice,
Absolutely.
not our choice. So this is why we offer this alternative commitment that occasionally, once every couple of years, we'll mark one and say, we'll support it longer. So if switching versions is a problem for an individual project, this isn't a company-wide decision, it's per project. If that's the right thing to do, go for it.
Right.
We are running a little bit behind, so we're going to have to kick it up a bit. I just want to say that one more thing real quick is the .NET Framework.
The arrow just goes right across.
It just goes. It keeps going. Okay. So we are gonna kick it up because I realize that we're running a bit short on time.
Rich is talking too much.
Yeah, we are. I'm talking too much too. So one of the things is that you're going to be managing your own security updates for .NET Core, and in .NET Framework, the security updates were part of Windows Updates. We're not going to go deep into this. The reason it's sometimes on you deploying is that you had to make sure there was the right .NET Framework on that machine that you were deploying out to, but you always have to do that. Make sure it's there, and it won't be there from Windows.
Windows Update.
From Windows Update. Windows, it's just not part of Windows, and there's good reasons for that, so that we can change it and we can move forward. Third-party dependencies. Ask. How do we ask today? We go to search engine. Go for it.
Simple as
Third
that.
parties mostly have a statement. Now let's prepare. So preparing to .NET Core is going to have a couple of steps. We'll walk through these again. The first one, though, you just want to move to a recent version. If you're back on 4.5 or even before, oh my gosh, any problems you have moving forward, settle that first.
Right, because there were a few points in the .NET Framework journey where we made significant changes, breaking changes, and you need to kind of make sure you've gotten through all of those waves of changes, because like 4.72 and later are the most similar to .NET Core, so that's really why it's so valuable to validate that your app runs successfully on 4.7.2 or 4.8.
Yep. And then you want to know how you're going to validate success. What does that look like? Test coverage is one great number here, but so performance metrics is going to be important too. We expect it to get better, but checking that's always a good idea.
Yeah, so back to those stories that I told earlier. So those developers that I talked to, they had performance tests, which they ran on the old stuff and the new stuff, and then they just did basic arithmetic to figure out which one was faster. But if you don't have those things, then you're kind of just a finger in the wind type of setup, which is not really science.
Yeah, you definitely don't want to be there. So evaluating architectural changes. There's a couple things here. We're going to bounce through this because I think the slide to come back to it, this is deep consideration on your part. We're throwing this out there. And then you can come back to the slide and say, yeah, I want to spend more time on that topic. So first of all, if you have a library that can target .NET Standard 2.0, you absolutely want to do that. That's what's supported on .NET Framework. You want to limit architecture framework changes during the port, because if you say, oh, I'm going to change a bunch of stuff and port at the same time, you've really made the whole effort is going to be crazy. It's going to be hard.
And then it won't be obvious to everyone why the build is breaking. Is it because of my migration, or is it because I actually made some bad plans, or it just can be a mess?
But before you move, you might want to look at a couple of things, and one of which is the isolation of concern. So if you're using WCF in only for one task, but it's spread out all over your application, start by taking all that into one library so that you can replace WCF in just one place. That's what we mean by isolation of concerns. And then there's something called the .NET Portability Analyzer. And I'm going to walk through this just real quickly. It's a Visual Studio download you can get at that link. It's an extension to Visual Studio. And after you run it, you get a spreadsheet. And I'm going to start with the portability summary. And I did two. These are both just standard .NET Framework applications for WinForms and web. This is a web MVC. And let's look at the difference. Right here, this number 34%, that says we're in trouble. ASP.NET MVC, you don't just do a straight port on. It's different work. We'll talk about that in a second, but you can see that number. If you look at, get it back here, if you look at WinForms, you see 77%, which is still a little bit low, but you can immediately go and find out what you've got. And I think that I just don't have the right SDK here, and that there's the work that I can do that's going to move that over. The way that you define Windows Forms itself changes the way the project file looks between Framework and Core, and I think that's what causes this. Because
well, yeah, you can see almost all that stuff is supported. Actually, all of that's supported. So this one was probably pretty close to 100% actually.
It would have been, except that we changed from a dependency to the SDK, and that's what caused the problem.
I see. So this isn't quite so.
So I'm showing you this because we want to again show you where you might trip a little bit, and when you see this, don't panic and think you're not going to be able to move WinForms. It's just that the way that we define it isn't. This tool doesn't handle it really well. All right. So portability analyzer.
Yes.
All right. So we did a little demo of that. And going back to porting your app, what do you actually want to do?
Yeah, this is the active phase.
And we are updating these apps today. Docs. I'm sorry. We are updating the docs today. Right now, there's a PR. We don't know the state of the PR at the moment.
Right, but within the next 24 hours, it should be merged, and then the right content will be at that link.
Right. So you want to choose the project to port. We recommend that you look at the ones with least dependencies and test projects early on. And then you'll change project files and code differently. Test projects early, is that obvious? If you move early with them, it's going to be, life will be better.
Actually, so I don't think it is obvious.
Oh, okay.
This helps shine the light on what the heck it is you're doing. So I think this is great advice.
All right. Project files. Project files is going to be a big headache for you. We'll just tell you that up front. It's going to be a little bit headache on this. So right now, they actually showed something in the keynote that I just want to mention. In passing, Olia showed a tool, and there wasn't much background given on that. And what I want to clarify is that's a prototype that is really got, it's going to work in some easy cases. And so we're trying to understand how you perceive that process of moving your project file. So we have normal channels that you can give us feedback on that, which is the upper right, give feedback in Visual Studio, or if you'd rather go to GitHub repo, .NET.Core would be a great .NET GitHub.net/core/core. Sorry. All right, so you want to create a new project file and then allow globbing to bring in your actual files. .NET standard libraries are ready to go. WPF WinForms, console, class library, these should be pretty straightforward. ASP.NET is going to be a little bit harder. You're going to need to replace certain aspects of that in the IS integration pieces.
Yeah.
And you're not just going to want to try to make this a straight port. This is going to be taking the new ASP.NET Core, which is vastly improved. It's a fantastic piece of work. You're going to want to take that and then move your old code into it.
Yeah, I realize now that we made the slide slightly incorrect. It shouldn't say plan to replace IS integration. ASP.NET Core also has IS integration. It's just that it's slightly different.
Right. So integration only in that where you are counting on these features, then they're going to be different. And you're still going to use IIS. You're right. We had a poor, and we have one more slide, and then we're going to try to take some questions. We ran a little bit over here.
Yeah.
So web forms, we suggest that you look at Blazor, and the reason for that is that Blazor is an event model similar to the way web forms is an event model. And so if you go to Blazor, it's going to be easier for you to take your ideas forward.
So should we move to questions?
I think we should move to questions.
We should too.
Yeah.
Are we at that time?
All right. Yeah. Okay, so moving to questions. So Rich, I thought this one would make you smile.
Doesn't look like a question to me.
Rich Lander rocks. So looks like you have a fan.
Wow, the first one.
Let's see. Okay, so let's look at real questions now. Okay, let's see. What's a good one? Is .NET Standard going to move to V5 when we get .NET 5?
I don't think we know.
Well, I think the first answer is that's unlikely because we have a different numbering scheme for the two. So
do you mean do you mean will there be a .NET Standard? Or do you mean what the number,
it's whatever the question was. I don't think it'll be V5, and we haven't figured out our .NET Standard plan going forward.
Okay, let's move on to the next one from Bill. So in addition to the releases on their product plan, can we expect bug fixes and other updates on a fairly frequent basis?
Yes.
It's basically monthly.
Yes.
Monthly, great.
That's easy. I like that question.
Let's see. This one's from Simon. Hi, would you recommend to move from a ASP.NET website on .NET Framework to .NET Core? Other question, could you provide a download link for the try.convert.exe? Would be great.
So first of all, it all depends on whether you should move. And a part of that is going to be is the improved performance, a simpler pipeline model, and a more consistency between Web API and MVC if you're doing MVC. That's MVC world. If you want to use Blazor, yes, you're going to go to .NET Core. So maybe. Depending on the future of your app and how active you expect to be in it, ASP.NET Core is a fantastic piece of work. This is where I talked about Prototype. The try convert application, that global tool which was talked about in the keynote, is actually not available today. And whether we put that out for the limited usage that it would actually be successful in, I don't think we've decided yet. So there may be, we'll let people know. But right now, what we need to know is if that's important, we would like to do it right. And that tool works in well-constrained boxes. It does not work across everything that you're doing. And so we would like your feedback about that particular tool and idea and what you need on that. Okay. Do we have another question?
Yeah, there's another one from Sean. Any major changes to .NET Standard and or the recommendations of using .NET Standard?
Do you want to take that or do you want me
to? There's no real changes. So .NET Standard 2.1 is the latest one. And that's the first one not to support .NET Framework. So if you want .NET Framework, you stay on 2.0. But that's about it.
Okay, we have some more questions. How much effort is required to move an ASP.NET MVC Core 2.2 to Core 3.0? Is it automatic?
It's not automatic. We actually, me and two other people, ported the .NET Core website, the .NET marketing website. So that's the one that's at .NET.Microsoft.com. It was actually fairly straightforward.
But it is work.
The only thing that we ran into that was weird was the way that ASP.NET Core handles localization. We ran into some challenges there, but everything else was pretty straightforward. It wasn't much work.
Okay, awesome. Here's another one. What about SSRS Web Forms render on .NET Core 3?
Yeah, so that stands for SQL Server Reporting Services. That will not be supported because it's a Web Forms thing.
Okay, let's see. Okay, we have time for one more. What about moving C++/CLI projects to .NET Core?
That'll be supported in .NET Core 3.1.
Okay.
And we're very, very proud of that. That's a great piece that we've got in there. We're happy to do that.
Okay, awesome. So next we have Azure App Configuration, making centralized configuration easy with Jimmy Campbell. Jimmy, take it away.
Awesome. So my name is Jimmy Campbell. I am a developer on the Azure App Configuration team. I'm excited to be here today to talk about our service and also to celebrate .NET Core 3.0. I've been a .NET Core developer since Beta 8, and definitely a lot of change since then. And I think that Azure App Configuration is a great tool for a .NET Core developer to add to their arsenal, whether they're developing modern global cloud applications, microservices, or maybe just sticking in a DevOps pipeline. Whatever, configuration is all across the stack, so a centralized configuration service really makes a lot of sense. So what ended up happening was we saw a lot of problems with configuration, the way applications are moving today. Some examples of some of these problems might be, how do I centralize configuration when I'm running on an Azure function? I'm also running in Kubernetes. I'm running on some VMs that I own, and I kind of need to share settings between them. Or maybe something like, I'm running apps in North America and I'm running them in Europe. I need to share settings, but I also need them slightly nuanced because the application just needs to behave differently in North America or Europe. To more advanced use cases like, wherever I'm getting my configuration from, how do I dynamically update it during runtime? And so configuration is a very fundamental piece, and there are some common problems. We saw people trying to develop their own solutions. That comes with a cost. We also saw things like people try to use things that weren't necessarily meant for configuration, and then they would eventually get to a point where they got stuck because the solution they were using just wasn't designed for that. So it really made sense to make this service, Azure App Configuration, which is been in preview now since April. April. And we got on this, and now it exists, so a centralized configuration service. For .NET Core developers specifically, we offer things like a configuration provider, similar to the JSON file provider in .NET Core. We have a SDK, a configuration client, where you can write, read settings. But I think, first of all, what I should do is get started saying, what is Azure App Configuration? It's an Azure resource. What happens when I create it? What do I actually get when I start using it? And so we'll kind of do like a getting started right now. So I'm going to go into my command line and get started with Azure App Configuration from the CLI. .NET Core has a pretty good CLI, and we're all developers here, so I think we can kind of enjoy the automation opportunities that come with the CLI. So I'll go ahead and get started creating my first Azure App Configuration. So I'm using the Azure CLI now, as denoted by AZ, and then app config is our command group. And I'm going to create an Azure App Configuration .NET conf demo. My resource group is going to be JimmyCA config, one I already have configured, and I'm going to have a location of Central US. So what am I getting when I create Azure App Configuration? So it's an Azure resource, and I'm going to get a place where I can store settings. Settings in our model are stored as key value pairs. So you may have a message, which is hello world, or something like that, just a simple key value. And that's really what we store at the foundation. We do offer metadata on top of that. So you're storing your settings, and they're available to you through a web endpoint. So if you look on the app configuration instance that I just created, my endpoint that has been allocated to me is https://.netconfdemo.azconfig.io. So now I have a REST API listening on this endpoint that was allocated just for me, where I can start creating settings in a central manner, start consuming them in all my applications, my DevOps. Anything that really speaks a REST API can start writing and reading settings from this app configuration instance. And of course, the CLI is one of the things that can do this. We can go ahead and create our first setting here, now that I just booted this up. AZ app config KV for key value. Set, I want to set a key value. So the name of my store is .NET Conf Demo. I have a key I want to create. Color, pretty typical setting name, and a value of blue. All right, so now we just use the CLI, the Azure CLI, to create an app configuration instance and create our first setting. All right, this kind of shows some of the automation with the service, so you can kind of run these things in a script or whatnot. But now we're going to go into the portal, and we can show the UI for this thing, and we can kind of get the best of both worlds. So I'm going to go into the portal here. Let me refresh the page. I'm going to see this .NET Conf demo. Now, everything I've done in the CLI can be done through the portal, and also the things that I do in the portal can be done through the CLI. We look for feature parity across both. And so if I wanted to create my app configuration through the portal, I could have created it through Create a Resource, and I create settings through Configuration Explorer. All right, so here we see the setting that I created, color and then blue. Simple C key value pair to represent a setting. And then we see some metadata on top of it. Label, last modified, content type. The one I actually do want to mention before we get too deep here is label. So key value are definitely important because you need those to have a setting. But label is something important to our service because it can be used when you're querying settings, and it gives you a way to add a new dimension to your configuration. For example, I may have an application that runs a premium and a standard SKU, and I might want the color to be green and standard, and I might want it to be red and premium or something like that. And so I can kind of model this with label. It's not just a metadata. It's not just like a tag that when you get it, it's actually used in queries. So when you query configuration, you can say, give me all the settings for the standard label, or give me all the settings for the premium label. So this is kind of what I talked about before, where I have nuanced configuration, maybe like a West US or North America and Europe, stuff like that. So label is something important for our service layer. So now we have the ability to create settings. We know what it kind of means to have an app configuration instance, how I can create settings for it. I want to go a little bit further into the portal here before we leave it, just to kind of get the coverage. We see some other things down here in operations, such as Feature Manager. Feature Manager is a value on top of just simple configuration. I could probably go into that into another time. But we also have some configuration utilities down here. We are storing configuration, and we're a configuration service. So it makes sense for us to have utilities. Like, for example, I need to restore my configuration to what it was yesterday because it worked yesterday but it doesn't work now. You can do that through the Restore tab. So you can select a day of what I want my configuration to look like. For example, on September 11th, I didn't have any keys, so it's saying, hey, do you want to delete these keys? I can compare settings. I can compare across app configuration stores. I can compare across labels. So like I said, I have a premium and a standard app. I want to compare these things. I can see, oh, red and green. And I can also do import and export. Import and export is really valuable. It's actually my favorite thing because especially when you're bootstrapping app configuration from a .NET Core developer point of view, you probably have app settings.json, something along those lines. And we support the ability to come in from a configuration file, import settings. We also allow export of settings to a JSON file. And this can also be done through the CLI. That's that feature parity I talked about. All right, so that is kind of the background for app configuration, the portal, the CLI, interacting with it. And now that we know how the settings are represented and how we can kind of get started, it makes sense to move into a .NET Core app that's actually utilizing this. And so before I do that, let me go ahead and move to another app configuration that I already allocated. This one doesn't have any settings yet, but I'm going to show the import I talked about. From a configuration file, I'm going to import some settings, appconfig.webdemo.json. I'll actually show that file. It's just like an app settings JSON file, if you will. And I imported it into my configuration store. And now you can see I have all these settings here. They all start with webdemo:. That's kind of a prefixing practice. I may have multiple apps configuration sets stored in my single app configuration. And one way to separate them is by namespacing them. So all these are from my webdemo app, and they all start with webdemo. And now I have these settings here. I can start consuming them in a .NET Core application. So let's move into an ASP.NET Core 3 application that I have. This is a ASP.NET Core 3 Razor Pages application. It's doing very little, actually. The main point to get out of this app is that it's pulling the configuration from app configuration. And the way we're doing that is we're binding our configuration to a model called settings. And you can see there's kind of a one-to-one mapping here, refresh rate, languages. These all map to settings here. And we're binding them to that model and we're using those properties in our Razor view. So essentially, we have like a one-page app, pulling configuration, and just using those settings to show what we're seeing on the web page. The very simple way to demo the configuration. Now, the typical practice in .NET Core for configuration is to use a configuration provider. .NET Core comes with a few very common ones like JSON file configuration provider, environment variable configuration provider, command line, etc. We offer a configuration provider. It's the Azure App Configuration provider. And so that is what's going to be showing right now on my program CS. On top of the environment variable and JSON file providers that come by default in Default Builder, I'm wiring up Azure App Configuration. And so it's these lines right here. This API, add Azure App Configuration, is exposed by the NuGet package right here, microsoft.azure.appconfiguration.ASP.NET Core. So I just need to add a reference to this to my ASP.NET Core project, and then I can go ahead and start using this API. Okay, so I go in, I call add Azure App Configuration, and then I need to do a little bit of configuring to actually set up the app to pull the settings from my app configuration instance. The most important thing is I need to connect. Now, what I'm doing right here is called Connect with Managed Identity. This is a feature that we utilize on Azure platforms that are running applications that support managed identity. These identities can be assigned to these Azure platforms. In this case, I'm running an app service, so I assigned an identity to my app service. And I granted that identity access to my app configuration instance. So I can actually go into my app configuration instance, and I can look at the role assignments, and I say, oh, I granted access to my app service. And so using this flow allows me to short circuit the other way of connecting that I'm going to get to. It allows me to, well, I can short circuit connection string basically. And I can take advantage of the fact I'm running an app service. I'm running my .NET Core app there. But if you don't want to do that, that's perfectly fine. You can just use connect, and you pass a connection string. The connection string comes from our portal or our CLI. You can list it there, and then you would just provide it in to bootstrap your app. But since I am running this app for the demo in app services, I can utilize this way of connecting. And one of the great things about this is I don't need any configuration to bootstrap my configuration. Because as you can see, I'm not using a connection string. All I'm doing is specifying the endpoint of my app configuration instance. OK, moving on to some other options used in this. We have a little bit of filtering here. This use is just specifying a key filter, because I mentioned that I kind of wanted to segment my applications. And in this case, I have them all namespaced by web demo : All right, and so I'm selecting only those. Then finally, we have this configure refresh. And this links back to what I talked about before, where we have a notion of wanting to dynamically update configuration during the runtime of our application, because some application designs depend on this behavior. And so before I go into configure refresh, I actually want to talk about where the refresh is triggered. And so I'm going to go into program or startup CS, and we see this use Azure App Configuration. This is the only other place where any Azure App Configuration code is found in the application. And what this does is it wires up a middleware inside of your ASP.NET Core app that uses requests to actually trigger a refresh of the configuration. If you were using our configuration provider previously, you may have been aware that we were using a polling model before. And now we switched to a middleware model. And the reason for this is that when you're polling for configuration, especially in a microservice world, you end up maybe just using a little bit of unnecessary resources if you're doing that continuously, even if the application is dormant. With a middleware-based approach, we can be smart about when we want to refresh our configuration. If you have 10 apps, maybe not all of them are always getting requests. You're load balancing or something like that. Only the ones that are getting requests need to really be triggering configuration refreshes. When the other ones start getting requests, then it makes sense for them to start triggering refresh as well. And so that's what this does right here. Request-based refreshes. Now we can go back to where we're actually configuring the refresh. because we know that refreshers are being triggered, but what does it mean to trigger a refresh? And that's what we're configuring right here. Essentially what we're saying is, what do we want to keep up to date? What settings? Do we want to refresh every setting, maybe 1 or 2 settings that are really important that need to be dynamically updated during the app? That's what's configured right here. In this case, I'm watching a setting called Web Demo Sentinel. And not only am I watching that setting, I'm specifying something called Refresh All, which means when that setting changes, when I notice a change in that setting, I want to refresh my entire configuration just like I did when the application started up. So I want to go back to app configuration and just get everything again. That's what's happening right here. And so with that, that's the full setup of app configuration in my .NET Core app. Now I can actually see it in action. So I have this application right here. It's blank right now because I didn't have any settings before, but I uploaded some JSON settings. And if I refresh the page, you'll actually see that I have some configuration from Azure App Config, or some settings, some data that came from the settings. It came from my Azure App Configuration. This came because I uploaded that JSON file, but to kind of give a better view of that, we can go in and edit some more things right now. Let me show the values for these. Let's change the background color to green. Maybe increase the font size. Just kind of do what we can to make the changes very apparent, and also make better message. All right, so now what actually happens if I refresh the application now, nothing is going to change because we're only watching that Sentinel value like I mentioned. But as soon as I update the Sentinel value, I just need to change it. It doesn't matter what I change it to. The application can start picking up the changes to all the settings that I updated. So we're going to start seeing the change to the green color, high .NET Conf, bigger font. And so this kind of just shows dynamically updating settings during the runtime of the application. So to get started, all you really need to do, pull in the NuGet the NuGet package, Microsoft to Azure, app configuration.ASP.NET Core. That's if you want to build an ASP.NET Core app. If you're just building a .NET Core app, ASP.NET Core isn't involved. We also have another package called Microsoft.extensions.configuration.Azure App Configuration. It uses that common configuration provider namespace. That one doesn't pull any ASP.NET Core stuff into it. So if you're just building a console app or maybe a hosted service, it makes sense to use that. It's still going to give you the ability to do refreshes. It just doesn't give you the request-based refresh middleware, but you can refresh the configuration yourself on demand. All right, so that's the .NET Core scene, but for a .NET Core developer, just developing applications isn't the whole picture. There's also, you need to build and you need to be able to release your applications. So we've been seeing a lot of mention of Azure DevOps for these kind of needs. And we actually have a DevOps build and release task. It is on the DevOps Marketplace. You can go look for Azure App Configuration, and you can add it right now to your organization or project to start using it. And what this does is it utilizes all the settings we put in our app configuration, and it injects them as variables into our build, into our release. So I can actually go ahead and create a new build pipeline to kind of show off using this. So create a new build pipeline here, delete all the steps, just to add in Azure App Configuration. I want my subscription, my configuration instance name. So now with this task, every setting that's present here is going to be available to my build pipeline. And if I use it in other builds, it's going to be available in those build pipelines. So I can share my settings across builds now very easily if I'm centralizing them in my app configuration. And I can also put my app settings there. And so it kind of makes it easy to manage them in one place and have one interface that you're working with for settings, one set of tools, one CLI, one form of automation. And now to demo this, I will add in a PowerShell task right here. And I'm just going to echo a setting from Azure App Configuration. message. I don't have that yet, but I can create it. Message, hello DevOps. Cool. And now when I save and run this build, I don't want to commit it to master, but I'll save and run this build. And then what we'll see is it's going to very quickly pull the settings, put them in as build variables, and then say hello DevOps, and we'll kind of have that. And like I said, what this allows us is we can easily have one interface for managing our settings for the applications we're building. We can share these settings across all these builds, all these releases, just make sure to bring them in through this one build task. And then we can kind of keep with the semantics of how we want to add dimensions to our configuration with a label, things of that nature. And I even want to go a little bit deeper into the DevOps interoperability with app configuration. I mean, configuration is really all across the stack. So applications using configuration, DevOps is using it. And there's even more room to talk about it here because Azure DevOps is very easy to interact with the Azure CLI. You can spin up very quickly an Azure CLI inline script to start doing something. And so this kind of ties into a scenario where you may have an application and you can't afford to pull settings at the runtime of your application. You can't make a HTTP request to pull settings. You can't talk to the service, possibly as a requirement. Well, if you still want to use Azure App Configuration, it's perfectly reasonable to have those settings pulled at build time or release time. Package them in an app settings JSON file and deploy them with your application. So I can go ahead and show kind of what that might look like right here, and also show using the Azure CLI to talk to app configuration. So let's hook up an Azure CLI task. Let's do a inline script. And we're going to use a functionality. You saw import on the portal, but now let's do an export on the CLI. We're going to do an export all the settings in our app configuration to a JSON file. So that's what we have in this right here. App config, KV, export. We're saying to a file. We give the file path, app settings.azure app configuration.json. It's a JSON file, the separator we want to use, and the config store it comes from. Finally, let me go ahead and publish these artifacts so that we can see them at the end of the build. And it demonstrates, as I mentioned, you want to pull settings during build. You don't want to pull them during the runtime of your application. You want to kind of have that very consistent, or it's just a requirement for when you're running your apps. So let me run this build. And then so this will take just a second for the Azure CLI to log in. That's probably the longest part of using the Azure CLI in this build. But it will produce the Azure app settings.azure app configuration.json file. And if you were doing this in a real scenario, you would just put that right next to your app settings.json. And then bam, you now have dynamic settings, but they came from during build time. So that's pretty much all I have right now for Azure App Configuration. Centralized configuration management solution. We have utilities for managing your configuration, a way to share your configuration across all kinds of different platforms. DevOps, it doesn't matter where in the stack you are. Azure App Configuration can help out provide the configuration there. And I guess real quick, I do just want to show the build artifacts of this. It did say it published build artifacts. Okay, well, there was supposed to be a JSON file there. I maybe typed something wrong in the build pipeline, but I think the idea is there. It basically produces the exact same file as this, and it would be present in the build artifacts. I must have mistyped something. But yeah, that's pretty much it for me. So.
All right, this has been pretty amazing, Jimmy. Like, look, and I'm going to tell you this because Mattheus, I think if I say it wrong, I'm so sorry. I thought this presentation was going to be about app settings.json. Azure App Configuration is amazing. It's cool to have this other place to put that stuff and manage it.
It was about app settings.json, kind of.
Kind of. And then the other one, which was interesting, which you answered there at the end, but I'd love for you to reiterate, What's the best way to do a fallback to offline settings? You kind of showed this a little bit in your demo. Why don't you see what, maybe he's going to tell me how to say his name. I'll say Matthew, Americanized. So how do you do a fallback to offline settings?
That's a good point. So there are multiple different considerations when you're talking about fallback to offline settings. There's what I just talked about putting your settings there during build time and release time so you don't have to make a query during runtime. So I just demoed that. That's exactly how you do it. I don't know. Like I said, I probably mistyped something in the build pipeline, but there would have been a JSON file there that could have been used as app settings JSON. Another aspect would be something that we have in our configuration provider, which is called an offline file cache, which if you're running on the same VM or something, and maybe one time when your app is starting out, it doesn't have network connection, you can use an offline file cache in our configuration provider library, and it will pull the last retrieved settings. They write them to a file, encrypt them, and it will pull them in case it doesn't have a network connection. So kind of two different practices for offline. So probably meant the first one, but the second one is there as well.
That's cool, because I thought maybe you just pull it at build, but then you also have a cache to fall back on as well.
Yes.
That's cool. Is Azure App Configuration recommended for secrets like connection strings? Another good question.
All right, so Azure App Configuration is a completely secure way to store any key value. Encrypting things, I mean, there's no worries there. Authentication, authorization, all good. However, there is another service named Key Vault, which is better for management of secrets. They have things like, if you're managing things like certificates, auto renewal of certificates. Or if you have things like connection string, they'll expire your connection string, and they have very granular access policies. So they are the best place to store a secret. So there's nothing wrong per se with storing a connection string in app configuration, but ultimately for secrets, that's exactly what Key Vault was designed for. Whereas we were designed for just configuration, extensive querying mechanisms, things of that nature. And one of the things that we're actually going to be coming out with soon is a way to reference Key Vault secrets in the .NET Core configuration provider. So we'll go through to Key Vault for you in your app. It kind of abstracts Key Vault, but your secrets can still live there.
And that's cool because Nick had the same sort of question. What's the difference between this new app config and Key Vault? So Key Vault is for secrets. App config is for, how would you finish that sentence?
Yeah, Key Vault is 100% designed for secrets. Azure App Configuration is designed for configuration. There's nothing limiting you from putting anything you want in app configuration, but ultimately, as we have configuration management utilities, Key Vault is going to have secret management utilities, the expiration, secret rotation, or certificate rotation, things like that. So those are values that we're not going to be able to give because that's not what we were designed for.
That's awesome. Does this configuration service integrate directly into Azure Functions so I don't need to manage the config there?
Okay, so two things. Our .NET Core configuration provider is net standard. You can use that in an app function and pull it right when your app function starts off. The second thing is I exported something to a JSON file in the last presentation. You can export it to an app service through the CLI or through the portal. And so other platforms within Azure we want to integrate with to be able to push our stuff there. Azure Function, AKS, you name it. On our roadmap is the ability to do this automatically via sync tasks and to just have your configuration live there, but you can still manage it centrally in app configuration.
Amazing last question. Is there an app configuration NuGet package for the .NET Framework?
So there is, yes, there is the one I just mentioned is net standard, so you could use it in the .NET Framework. Also, we do have a configuration builders NuGet package. The configuration builders was introduced, I believe, in 4.7, and it's kind of a .NET Framework way to do configuration, well, built into the framework there. And we do ship something for that. So it's an Azure App Configuration specific .NET Framework configuration builder.
Amazing. Thank you so much, Jimmy. We have some feedback coming in on, may I say, they're Mika's jokes that I was asked to read. Okay? The jokes on .NET Conf, I told her that they may not work, but she was adamant, so maybe we should have a talk with her afterwards. Up next, app services every .NET developer needs to know with Tim Hewer and Angelos Petropoulos. Did I say it right?
Perfect. Off we go.
Awesome.
Thanks, everybody. Good morning, good evening, good afternoon, wherever you're watching from. I'm Tim. This is my esteemed colleague, Angelos. We're here to talk with you about Azure services that every .NET developer should know and get excited about using your apps. So first, I want to set the stage, Angelos, and just make sure everybody, we're gonna throw out some terms about Azure.
Yep.
So we should probably make sure everyone knows what those terms are. In Azure, there's a lot of different things that we'll talk about, but just to level set. So we're going to say things like accounts and subscriptions. And accounts is something that represents you and me, our actual identities. That's how we authenticate with the service. A subscription is something that we can share together, right? That's kind of a billable unit. You'll also hear us talk throughout this session about resources and resource groups. A resource represents an individual unit of any service that's created in Azure. And so like I have an app service is an actual, which is one of the things we'll talk about today, is an actual resource. A resource group is things that we can group together, perform some more security on, establish some more boundaries of what can be in those services and configuration around there. So we'll talk about those two things quite a bit. Most explicitly today we're going to talk about two things, right, Angelos? We're going to talk about hosting and services, right? And the way that we think about these things is hosting is you're going to provide the code and Azure's going to run it for you. And the services that we're going to talk about is more you're going to provide the data and Azure's going to, these Azure services are going to take some action on the data. So specifically during this session, we're going to focus on those two aspects of hosting and service. And to do that, Angelos has built a very simple application to allow us to walk through that. So we have we're gonna show an image gallery, right? And so
worth millions.
It's
worth millions.
Yeah, we're going to IPO at the end of this. You'll want to get in at the bottom here. So I think we should just dive right in and get started. And let's so throughout this, we're going to cover roughly 5 services that are really kind of table stakes that .NET developers, .NET Core developers should want to know.
Everybody should be aware.
Yeah. So tell us about this this site and show us the first demo here.
Let's jump straight in because we have a lot to cover. So I have the simple ASP.NET Core MVC application working here, already running locally, local host. It's called Core Image Gallery. I can register a new user and log in. So I'm going to go ahead and log in with my demo account.
So as you're logging in, so what are you using for this authentication here?
Yeah, this is powered by ASP.NET Core Identity. So go search for that if you want to know more about it. But the whole register with different accounts, social, and all of that comes kind of for free, and you basically configure it, and it just works.
And it's all taken care of for you when you do the initial configuration, right?
That's right.
Okay.
So now I've logged in. I'm going to click Upload Image. I can pick one from my local machine to upload it to our gallery. It's going to take a little while to upload it. It's telling me it did some file processing, and the file will be available shortly in the gallery. And I can just click Return to Gallery. And here's the picture I uploaded. And I'll open it up to show you that the processing we were talking about is just a little watermark
copyright so that we protect our millions.
Oh yeah, this nobody will steal this now.
Yeah.
All right. So very simple application. Let me stop it from working. Let's go back to the code and check out what I just showed you. Simple solution, a couple of projects. I'll start with imagegallery.model, nothing but a class library. Nothing interesting here really, just a class with some properties. That's what we use in the page that shows you the confirmation after the upload. So just showing you there's no tricks. So nothing really interesting there. The main project, ASP.NET Core MVC, I'll show you startup.cs real quickly. Classic stuff. Like we said, we're using ASP.NET Core Identity, we're using MVC. But the thing I want to draw your attention to is we have a service, an interface called iStorage service, and an implementation of it with file storage service. So let's start with the interface. Let's check that out. It's pretty simple. Just a couple of operations on it. Get images async, that's so we can populate the gallery. And add image async is just when you do another upload. So nothing too crazy here. Close that down. Actually, I want to show you the implementation as well.
Yeah. Oh, the one we're currently using.
Yeah.
Yep.
So let's go and take a look at the class that implements iStorage service. And this is giving away the secrets immediately. You'll see here there's going to be a folder called user images. We're going to put it under www root, and that's where all the pictures we upload go into. It's the local store for the server. Nothing really interesting in the constructor. Add image async. I have a little helper method here to get some properties out of the image so I can show the confirmation page later. We just get the path here for the destination. We create a stream. We use a little watermarking class to add the watermark. I'll just show you that real quick, just curious. I don't really know what it's doing, but it works. All right. And then finally, we just record the upload, and you get to see the screen that says, go back to the gallery.
So it's a standard ASP.NET Core web
Nothing
application, uses MVC.
Yep.
Nothing special that's any cloud specific or binding us to any decisions at this point.
So
But now we've only been running it local.
Yeah, this is all local, and I forgot to mention that ASP.NET Core Identity uses local DB. So we have a dependency on SQL Server right now, but yeah, it's just
the local
DB.
instance of it.
That's right, yeah. So let's take this application, which is a typical application, and it's deployed to Azure, and then slowly we'll try to modernize it and make it a bit more cloud native.
Let's do it.
All right, so I'm gonna right-click on the project, and I'm gonna click Publish.
Now, the one thing that we've already done is we've already created that account and subscription that we talked about.
Yeah, it's because we don't want to waste too much time now in the demo. That's pretty easy to look up, and you can do via the CLI, through the portal. It's all pretty easy.
Yep.
So here, when I right-click Published, I'm picking Azure App Service. And because you're nice and you've already provisioned the resources for me, I'm just going to select existing and go find them.
I try to add value by provisioning resource groups all day.
That's fantastic.
Yeah.
So here, it's going to access my subscription, and then it's going to go look for all the resource groups under that subscription. And then I will be able to find app service instances running in those resource groups. So like you said, a resource group is just a folder. It's basically a nice way to organize your stuff so you can go find it easily.
And you can have more than one subscription, and in fact, that's what took it a little bit long, because you do have a lot of subscriptions.
7, sorry, yeah. All right, so here's my demo resource group, and I'm picking my existing instance of app service. I'm clicking OK, and now Visual Studio will talk to that instance, capture some information, and all I have to do now is hit publish. But before I do that, I have to make sure my ASP.NET Core Identity data and schema makes it up to the new instance of SQL Server you've created for me.
Right, because we were using the local DB.
Right.
And now we want to use an Azure SQL provider. In fact, Azure SQL itself.
But you did all the provisioning, so I'm not really sure what you did there, but thankfully, Visual Studio will let me do everything through its options. So if I just edit the published profile so I can access settings, you will see here at the bottom of the dialog, we're discovering data contexts. What that means is Visual Studio is now hitting the app service instance I've selected, and it's asking it if it has any SQL Server connection strings. Because if you've already done the work, I might as well benefit from it.
Yep.
So now that the spinner is done.
And it's real time.
This is real time.
This is real time.
Yeah,
so
this is
communicating with our subscription, and I've already done the provisioning of Azure SQL for you and provided a connection string for you.
So why should I bother with that again, right?
Yep.
All that is there. I can just pick it, check a box. That will apply Entity Framework data migrations as soon as I publish. So all I have to do is save, hit publish. Now what's going to happen is Visual Studio, of course, will build the project. We'll talk to the app service instance, upload all of the content. Then it's going to go and check SQL Server, run Entity Framework migrations. And we try to give you, visual clues what's going on. You can always go to the output window and get more verbose information about what's happening here.
So why are we using app service and not a VM?
Right, so VMs are great. In fact, if you go and create a VM through the Azure portal, we even have a very nice template where it will set up IIS and MS Deploy, and then you can just come into Visual Studio, like I did now, right-click, publish to the VM. It's all great. But this is a talk about services of Azure that you should know about. An app service should really be your go-to hosting option in Azure. At the very least, you're getting a fully managed instance, so you don't have to worry about patches and security fixes and frameworks and all that kind of stuff. It can very easily scale out and scale back based on just setting some metrics and some options up. It can make sure that you can keep your site running even when you're deploying into the same instance by taking advantage of a feature called deployment slots.
Like a staging and production.
There's many, many good reasons. It's your go-to, and don't be, all these features, if you don't necessarily need them, don't think that it's superfluous. There is different queues and tiers, so there is different pricing and features for dev test than production. So maybe you don't need everything all
and
at
I think
once.
one thing that I like about app services, which you mentioned, is VMs are great, but there's still some configuration you have to do to kind of bootstrap them.
Exactly.
Whereas app service, as we just saw, deploying even directly from an IDE or from DevOps, it's taking care of a lot of that configuration for us. We know we're just telling it, hey, we have a .NET Core framework, and here's my bits.
Right.
Yep. Great.
All right.
Okay, so we deployed. Look, the URL doesn't say localhost anymore.
Right. So this is live.
Success.
Running in Azure right now.
Awesome.
Fantastic.
Yeah, so let's go back to the slides real quick and just kind of review those first two things. So we said we're going to hopefully cover 5 services here. The first 2 things we just were able to show is talking about 2 services. App Service, which kind of is that hosting platform here. App Service is really great for web apps and APIs. As Angelos mentioned, it's a fully managed environment, so you get the OS patching, high availability and high scale by default, with you able to kind of provide the throttling mechanisms as well within that. And it's first-class tooling across Visual Studio family of products as well. As you saw here, we're using Visual Studio for Windows, but we also have similar experiences in VS for Mac and Code. And then the second thing, because we were using ASP.NET's identity integration, we were using a local DB SQL Server instance. And so we were able to use any framework migration scripts to put that into Azure SQL. So now our app that was running on-prem, basically prem being your box here, is now hosted in Azure, and our identity is also in Azure. But we've got a couple more bits there, right? So we were uploading images. Were those images in SQL?
No.
Okay, let's take care of that. That's probably bad.
So the app is running in Azure, but we can do a bit better, because if we want to take advantage of App Service and its ability to scale out, for example, you will notice or you'll remember that the images are being stored on the WW root.
Yeah, the file storage provider that you had there.
Right.
Yeah.
So a new instance is provisioned, then that folder will be empty. If traffic goes to that server, the gallery will look empty.
Yeah, redx. We don't like redx images.
No.
All right, let's solve that. So we can go back to the demo.
All right. So what I'm going to do here is I'm going to introduce the third Azure service called Azure Storage. Basically, we want to be able to store files. It's a common thing apps have to do. Azure has a service for it. So what I'm going to go do here is show you a new implementation of iStorage service, the same interface we saw before. Some simple strings and variables here. We'll talk about those. It's nothing to worry about. But let's go back to the add image async and compare it to the previous one. So here we have get image properties like before. We have an upload container, and we just get a reference to it. This is basically a stream we can write into. We then create a memory stream. Before we were creating a file stream because we were writing locally. Here I want to do the watermarking, so I'm going to do it in memory. And then image blob, which is a reference to Azure Storage. We're just going to copy the stream into it, and now the picture is uploaded.
Now, those 2 APIs that you're calling there, the get block blob reference and the upload from stream, those aren't things that you wrote, right?
No, that's Azure. That's a library that I get for free.
And so because we're making the decision, we're using Azure Storage and blob storage in this case. We have an SDK available to us that allows us as .NET developers and C# developers in this case to work in the language we love, get all the productivity in Visual Studio that we like, and have kind of this strongly typed interface with the service, not have to worry about REST and all that type of thing. Perfect.
So now what I have here is the app will work just as before, but now it's going to take the pictures and upload them into storage. So even if new instances are fired up, then they will just talk to the same instance of storage, so I'm good. But we can do even better. When you're in the cloud and you're migrating applications, it's a great opportunity to optimize and get efficiencies and modernize an application.
Yep.
And when you're on-prem, there's typically tasks like things firing off on timers and scheduled events and triggers that trigger workflows and multiple operations. And typically those things are achieved with, let's say, a Windows service running somewhere or a Linux
Some daemon or cron job or something like that.
But how do you do that in App Service? You can't really do whatever you want on that box. So Azure offers you a service called Azure Functions, which I'm going to use now to take the watermarking process out of the main app and just do the watermarking after the picture has been put into storage with some sort of background task.
Great. So we're identified an area where it's not mission critical to us.
Exactly.
As someone's uploading it, we're kind of almost like async workflow in nature. to offload this little microservice that you're going to create here.
Yeah, I mean, it doesn't really matter if the image takes a second or two to get
We may
uh,
lose $1 in our IPO.
Well, I think we got 909,000 something,
Okay,
999. It's good. We're good.
What we lose, we'll make up for in savings
Right.
on Azure. That's what they tell me.
All right, so back on the project. So I have a new project here in my solution called imagegallery.az functions. How did I get this in here? I did right-click, add new project, and I picked Azure Functions because I had picked it before, or I can just search for Azure Functions up here, and I create the project. Now, inside it, I have my watermarker class from before. I just moved it over here. It's the same code.
Same code, now
I still
it's
don't
just
know.
right.
I still don't know what it does.
Yep.
Image uploaded. So that's my first Amazon Azure function. I'm going to right-click, and I'm going to show you how I did that. I click Add, New Azure Function. You get to name it whatever you like. You click Add. And here's where I talked before about, you probably want to have some sort of trigger or timer. So here we have the list of possible ways you can execute your Azure function. Very commonly, you have HTTP triggers. Maybe you do something on the website, and the website calls the function.
So this is like get and post and
Exactly.
actions, yeah.
But I also have what I want here to use in this case, which is the blob trigger. So as soon as the picture gets uploaded to blob storage, I'm going to get told that just happened.
Yeah.
So I just gave it a connection string, and that's how I got it in there. So let's take a look at the code. There's not a lot to it. I have my watermark up here. I have an attribute telling me that this is actually going to be an Azure function, and the name can be whatever I want. It can be different than the name of the method. And I'm going to look at my first parameter called input blob. That's basically whenever the picture gets uploaded, because the annotation says it's a blob trigger,
Yeah.
exactly. The name of the container is going to be called images, and then whatever the file name is, it's going to go into this variable called name. So I have a string name here, and I can reference it conveniently through here. And then I have a second variable parameter, which is basically my output. So after I do my watermarking, I'm going to put the contents in here, and it's going to get written where? Into a new folder container called images-watermark.
And that's also an
then
Azure Storage blob container.
Yeah,
Yep, just a
in the
different
blob
one.
container, you can create as many of these groups as you like.
Got it.
So all this will do is be notified, do the watermark, and then move the picture. But since I'm creating these two groups and I'm moving pictures from one to the other, what I want to do is also clean up after myself. So I want to go and delete the original image that was uploaded. So what I'm going to do is go to delete original image. That's just another Azure function, again with a blob trigger. So keep in mind you can have more than one per project. Sometimes it's often easy to miss.
More than one function per project.
Per project, yeah.
Yep, okay.
And here what I'm doing is I'm showing you that you can even access configuration values in the definition.
So before where we had you had the hard-coded blob name, now you're pulling it from ASP.NET Config.
Exactly, so
Right.
just showing you that both are possible. The other one was just easier to read.
Got it.
So here what we're going to do is we're going to be told when the image lands inside the watermark container. So that's after the first function has worked. And what I'm going to do is I'm going to know to go and delete the original one now. All right. So I have this working, and I think it's going to work, but I want to make sure it works locally before I put it into Azure. And even though I'm using Azure Functions, something that is native to Azure, I can still run my project locally, including Azure Storage. What I have to do is fire off the Azure Storage emulator.
This is a good point. So this is another set of tools that are allowing you to do cloud development,
That's right.
but have a faster inner loop development, F5 debug kind of life cycle.
And the emulator, you have to start it on your own because it's kind of really hard for Visual Studio to know exactly when you're going to access it, and by then it might be too late.
Okay.
But for Azure Functions, all I have to do is right-click, set it as the startup project, and why don't I put a breakpoint, see what happens.
So
Fire it up.
we've started the storage emulator, and now you're starting the Azure function. This is going to run on the cloud now, or this is also another emulator?
This is now the emulator being fired up by Visual Studio because it's clever enough to know that's exactly what you need.
And so this is a local instance of the Azure Functions runtime that's running our
That's
code
right.
now.
And you'll notice this is the 64-bit, which we added support for recently.
Nice.
So VS has detected the runtime is up. It deployed my function and acquired a log to it. And now the function should be working. Now, two ways I
So
can
now the
test
function's there, it's ready to listen.
It's ready to do the
Ready for the
watermarking.
trigger.
All right,
Ready
exactly.
for the trigger, okay.
And since we're on the topic of working locally, I also wanted to show you the Azure Storage Explorer. That's a kind of cross-platform app that you can download separately. Similar functionality exists in VS if you go to Cloud Explorer, so look that up. But Azure Storage Explorer lets me interact with Azure Storage, whether the instance is in the cloud or locally. So here, I can actually go and look at my storage account locally. I can look at my emulator running. I can look at my blob containers. And I can actually see the 2 containers I had before, images and images watermarked. So if I really wanted to execute my Azure function locally, I can literally just drag drop a file using this tool, and it's going to kick it off. But let's do the full thing. I'm going to come back to Visual Studio, and I'm going to fire up the website.
Yeah, now we got to run the app itself locally,
yeah,
right?
I'm going to run that locally and just exercise the full end-to-end.
So now what we have here, as this is spinning up, we're running our local process that's using the storage SDKs, using serverless functions, but running both of those basically in a local inner loop.
That's exactly right.
We haven't published anything to our Azure yet.
Everything is local right now, local host. So I'm going to do the same thing now, upload an image. Pick a different one this time. So file is being processed, blah, blah, blah. It will be available. So, oh.
And that's our breakpoint.
Breakpoint hit. All right. So I bet if I go here, put a breakpoint on my delete one, if I go back to upload, I'll just let it go. Come back to my website. Oh, didn't have enough chance. My second trigger has fired off. Everything is happening synchronously. All right, it's all good. I'm going to continue this. Now, when I'm going to hit return to gallery, the image will already be there, and it's already watermarked.
That's awesome. So now we can go ahead and republish these, republish our app to Azure at that point.
Exactly. So what I want you to see here is if I want to take this Azure function and publish it to the cloud, right-click, publish, exactly the same experience as before. I already had a profile there. Create, select existing.
Same configuration.
The same as before. I'm not going to bore you with the same stuff.
Awesome. So now we've got, we're using app service to host, Azure SQL in the cloud, blob storage for our files, and serverless for some lightweight functions that kind of asynchronous in nature. So we've got like 4 services we're running on top of the app itself. So how are we going to feel good about the health of the app here?
Okay, so feedback we get from customers a lot is running things in the cloud feels like maybe they're far away from the diagnostics a little bit.
Yeah.
That's not true. That's not true. Let me show you how. All right, so let's go back, close all this down. I don't need anything local running. I'm going to go to my production cluster now. I'm going to go to my production resource group. So this is my website running in production right now. And I have a report that if you try to upload an image without logging in first, something happens to the app. So let's go check it out. I will go and upload the image. Pick one, Scotland. Check that one. All right.
So we've got a crash here effectively.
This is the dreaded, something went wrong, but you're not in a development mode and you can't really get the call stack, and now you're probably going to be worried about, well, how do I get access to logs? And this is annoying. It was so much nicer when I was local. Well, let me just show you something called Azure Monitor.
So now where we're going is we're logging into the portal.
I'm going to go back to the portal. And you know how we said that resource groups are a nice way to organize your resources? What I'm going to go do here is I'm going to go to my resource groups, scroll down until I find my production resource group. And here I get a list of all the services this resource group has provisioned. And you were kind enough when you provisioned our app service instance to actually attach it to Azure Monitor. What you get by just attaching it to Azure Monitor is diagnostics. So all I'm doing is navigating to the instance. And oh look, there is a chart there for failed requests. Well, that's exactly what I needed. So I'm going to click that, see where it takes me. Okay, I'm scroll down. Okay, so there's an action post upload. Yep, that sounds like what I just did. And it lets me drill into, because I'm going to keep clicking until I get to a call stack here.
Yeah, so we're able to go to the portal now and see, this is almost real-time diagnostics as well of what happened. And get basically to our core exception here then.
So this has an end-to-end transaction. It has automatically recorded for me without me doing anything special. If I keep going, I will eventually get to the call stack. This is what we all wanted to see.
And we can figure out the exception there at this point.
All right, so this says core image gallery extensions upload. Okay, so
We
I
let
wrote
somebody
the app.
do
It's
something
small.
without authorization.
Yeah, I mean, it's kind of obvious. I shouldn't let you upload the picture without sending in first. But the point was getting to the call stack, right? So now I can go back to my code and see that get image properties is assuming I'm authenticated, basically.
That's awesome. So let's go back to the slides and review that what we've seen here. So what Angelos was able to show is we had a typical ASP.NET Core application, fairly simple one at this point, that was doing a couple different things, and we basically moved it all to the cloud, not having to worry about managing our own box and infrastructure. We got hosting out of App Service. We've got data storage in two ways, actually, using Azure SQL, which, if we needed relational database needs on top of our identity, we could still use that as well. We're using blob storage as kind of our durable storage for objects and things like that. A serverless function that is just kind of asynchronous. And actually, by the way, we only pay for that when we call it.
That's right.
So it's not this long-running process. And then we have really rich insights and monitoring into our app. So there's a ton more in Azure that we could do as well. We didn't even talk about containers and things, but that's kind of like the next level that I think an enterprise level application might look at is how do we do container orchestration? And Azure has Kubernetes services that we can do there, as well as other services that there's data services with Cosmos DB, Active Directory. Another service bus and SQL managed instance and everything like that. So I think it's a really quick overview of kind of some key services that .NET developers should know. Here's some resources for you. We want you to kind of go get the tools and SDKs, .NET Core 3 release, getting Visual Studio and both the Core SDK. And then as well that second link if you want to learn more about Azure and actually walk through some of the same tutorials of the services and get those SDKs that make it easier for a .NET developer, that's the place to go. And if you haven't tried Azure yet, you can get a free subscription that gives you free services, some forever and some for a 12-month period. And I think the good thing about there's a lot more richness in the monitoring and diagnostics, and I think a good thing is the session right after this, Saurabh is going to go over some more of what we've done more in .NET Core 3 for those type of things. So. Thanks, Angelos. It was good primer, and encourage everyone to take a look at this. Mika.
All right. Thank you, Tim and Angelos. For those of you who don't know, Tim is actually my boss. So how are you doing, Tim?
I'm doing well. You're doing a fantastic job.
Thank you. So yeah, we have a few questions that we can go over right now. Let's see. This one's for Tim. Good to see Tim presenting. Brings back bittersweet memories of Silverlight. Do you have anything to say about that?
Probably not allowed to say anything.
Let's see the next one. Can app services run Blazor? Can app service?
Yes, and if you're into Blazor and into app service, also check out the Azure Signal R service. If you need more info, let me know.
Okay. Awesome.
Yeah, Dan Roth gave two presentations earlier today, but also yesterday, kind of how that kind of all works together as well with Blazor and
Okay, awesome. Here's another one. This one's from John. Will VS generate the EF scripts if you just save the publish profile instead of clicking publish?
Clicking publish actually deploys the app and then executes the migration scripts I had already set up before. So I just didn't type, create migration, but you have to do that first, and then publish will execute it for you.
So creating the profile doesn't create a migration script for you.
Oh, it does on the server. Yeah.
But locally it doesn't. You have
locally, yeah.
Okay, great. Thank you so much, guys, again. Next we have, let's see, we have diagnostics improvements in .NET Core 3.0, and this is with Saurabh and John. Take it away.
You guys were good to go?
Yeah.
All right, everyone. So John and I here are going to be talking about diagnostics improvements in .NET Core 3.0.
So I'm John Salem. I'm an engineer on the .NET Runtime team, and I work on diagnostics.
And I'm Saurabh Shirhati. I'm a program manager on the .NET team. So let's go ahead and get started. So this is what we're going to be covering today. We're going to talk about new features in the runtime, which is the new diagnostic server that allows us to egress this rich diagnostics information and the IPC protocol it speaks. We'll also cover the new diagnostic tools that we've built, which will allow you to consume this information. We're going to go over .NET counters for metrics, .NET Trace for collecting traces. We're also going to visualize sample CPU stacks using SpeedScope that we collected with .NET Trace. And we're also going to look at .NET Dump as a way of collecting and analyzing process dumps for .NET applications. And then finally, we'll just recap and tell you how to acquire these tools so you can do what we showed you today during the course of our talk.
So for the 3.0 release, we've added a diagnostic server into the .NET runtime itself. So it speaks across a transport protocol depending on which platform it's going to be, a named pipe on Windows or Unix domain sockets on non-Windows. Now it speaks a custom IPC protocol, and we've built some tools on top of that protocol that are capable of, like Saurabh said, creating dumps on Linux, attaching to the event pipe, as well as attaching profilers.
So if I understand correctly, you've prepared a demo for us today. It's an image processing app that's had a few performance issues that you ran into as you were building it.
Yep.
So we're going to run through the tools and we're going to solve your issues, and everyone can see how we use these tools to solve your issue. So can we jump over to John's computer right now? Oh, perfect.
Yeah. So you see here the beginning of a basic little console app. All it's doing is taking an input image, in this case the headshot for the .NET Conf, and outputting what we call a PPM file. Now this is a classic image format. It's very, very simple. It's just a couple ASCII characters as a header indicating what it is, followed by every pixel written out in ASCII plain text delimited by some white space. Very easy, classic CS 101 type assignment to generate these files.
So can we go ahead and have a look at your app run?
Yeah, so let's go ahead and run it.
So John's just running his application, and he's going to start it up with the image that he just showed you. As you can see, he has a couple of transforms that he can run, and he's going to run the aptly named PPM slow transform because, well, it's a little slow. And as you can see, no matter how long I talk, this thing is still processing just one image. So John, how do I get more visibility into what's going on? So this is like my 10,000 foot view of the world. I first want to know that there's something wrong. So how do I get these metrics when your application is running?
So we already know it's slow, but the runtime produces a whole bunch of other interesting data that we can take a look at using one of our new tools, .NET Counters.
So John's just going to go over in another terminal window. He's running .NET Counters, and he's going to pass it the process ID of his already running application. So once it loads up, you can see that he's out of process connected to his existing application, and he's getting live updates to event counters. And when he goes ahead and runs his application, you can see these counters just light up. You can see it's pegging his CPU, it's about 22%. He has a lot of GC collections happening. Allocation rate is really high. Like if I were to look into this, just the allocation rate number should make me suspicious. So why are you allocating that much, John?
I don't know.
Can we look at your app? Can we see what's going on?
Yeah, let's go ahead and take a look. So if we scroll on down, you'll see we're doing a whole bunch of stuff. We're loading the image, we're mutating things, we're appending to a string. It's really hard for me to tell from this point of view, like what exactly is going wrong.
So how about we recap what we learned about metrics, and then we'll look at if there are other tools available that can give us more detailed information on what was happening while your application was running. So I'm hoping my screen's back up. And then let's go ahead and talk about metrics. All right. So the .NET runtime and ASP.NET Core both emit event counters, and you can customize custom event counters using the event counter API. These event counters can be consumed both in process and out of process. In process, we have the event listener API, and that's in fact what the Application Insights SDK uses to give you counters in .NET Core 3.0. And out of process, you can talk to the diagnostic server. That's exactly what you did with the .NET Counters tool. Our tool only showed you the live values for those metrics, but the runtime actually computes additional stats. So you can get count, min, max for all the metrics that are emitted. And you can think of event counters as the successor to perf counters. So they work everywhere that .NET Core does. So unlike perf counters, which are Windows only, event counters work on Linux and Mac OS. And unlike perf counters, they are usable in low privilege environments. So you can use it in Xcopy deploy, and you do not need administrative privileges to actually get access to those counters. So this was a good, we got a view into what's happening in the runtime. We know we're allocating a lot.
Yep.
So if I were investigating this further, I'd be like, can I see what was actually on the stack? Can we see what's taking up CPU time? Can we see what's actually causing those allocations? So if we switch back over to John's computer, John's got his application back up and running. And are you going to introduce us to the new tool?
Yeah, so I'm going to go ahead and run .NET Trace, and we're going to rerun that slow transform again. And that's going to actually give us a view, just like you're asking for, of what was on the stack at a given point in time.
So John's going ahead and running .NET Trace. He's pointing it to the process ID of his existing, already running application. And this is going to do a couple of things. So as he goes ahead and hits enter, you can see one of the providers enabled by default is the sample CPU stack profiler. So what's happening right now is the runtime suspends all running threads every 1 millisecond, walks all your stacks, and generates these CPU stacks. In addition to the sample CPU profiler, you can enable additional profilers. So we ran it with the default argument, so we didn't do anything like that. But if you're used to using ETW and collecting other events from the runtime, you can just pass them as parameters. It's the same keywords and same filtering that you would for ETW events. So, John, I see the output file was this nettrace file. So can you tell me what the nettrace file is and how will we consume it?
So we send events across the event pipe using a format known as nettrace. Now, if you're on Windows and you're running Visual Studio or Perfview, you can just open up that file that has a ton of information, like you said. Most things you can send across ETW, you can send into these files. Now, because I'm not on Windows, I need another way of opening this file. And so for now, we have a way of converting these files into other formats. So right now we have SpeedScope, which is what I'm going to go ahead and do right now.
So we're converting it to SpeedScope for the purposes of using it and visualizing CPU stacks in SpeedScope. If you were on Visual Studio, you could open it there. If you were in Windows, you could also open it in Perfview and get detailed activity view, event counts, and all the other things you're used to doing when you do ETW with Windows. So John's gone ahead and he's opened this collected CPU trace in this application SpeedScope. So John, just tell us more about SpeedScope and how do I get it?
Yeah, SpeedScope is an open source application. You can find it on GitHub. The author also has it hosted up at a website at www.speedscope.app. I actually have it installed locally here on my laptop using the new Chromium-based Edge. So it's installed here locally on my box as a PWA. So this is running right here.
So now we're at the part of the exercise where I got to see a bunch of color lines on your screen and figure out what's wrong with your app. So I'm kind of going to ask you questions, and hopefully you will point me at what's needed to get to the root cause of this problem. So I'm just reading from left to right. I'm seeing a bunch of things. I see this unmanaged code time. What is that?
So because it's the runtime tracing itself, we don't have insight into the native code. So most things that are after a transition into native code, you'll see unmanaged code time. So in this case, that's the top of the stack for a console read line. So waiting for some kind of I/O interop or something like that, right?
OK, so that makes sense. So we know your app is slow. We know the part we don't care about is waiting for you to type, because that's just you being slow, right? So how do I filter out to only the parts I care about? Where do I get to the meat of what was happening in your application?
So this is what we refer to as an icicle graph. If you're familiar with a flame graph, it's the same thing, just inverted. So the bottom frame here is the top of the stack at a given point in time. This is the time order view, which means we're going to read it from left to right. So if something's on the stack for a really, really long time, chances are we're going to see a very consistent bar across. And in fact, we do. If you take a look here, you'll see that we have a convert to ppm slow that's been on the stack for, it says 78% of the time of the trace. So if I double click on that, we can scope into just what was happening during that call.
So that's interesting. So you were able to, now we're in the region of interest. We were able to filter out the stuff that we don't care about. And if I recall correctly, we said we're processing an image. So I assume there's a lot of you repeating the same operation over and over again on every pixel, which probably also explains why we have so many of those word icicles. Is there a way for me to view the cumulative impact of these operations? Can I stitch these stacks together to see what's really eating up the most time?
Yeah, so like you said, we're seeing a whole bunch of fragmentation here. This is a sampled set of stacks, which means we're going to have a little bit of noise in terms of timing, right? So we get a sense of what sat on the stack for a really long time, but for a lot of these really small chunks, these were probably a bunch of repeated calls that were happening quickly in succession, so we can't really get a sense of what took the most time. We just know that it was there a long time. So if we take a look at this, you'll see from the left to the right, we've got that image load, which didn't actually take much time. But if we go and take a look at this left-heavy view, like you were asking for, this gives us a nice aggregate view. So all of those discrete samples get aggregated into a single sample. So in this case, we can see again, there's our nice long frame for convert to PPM slow. And if we zoom in on that, we can take a look at exactly what was happening during the whole time that that was on the stack.
So can we go back to your code? So if I'm looking at what you're showing me, I see some string concatenation, some stuff that seems vaguely familiar from when we saw your code. So do you think this is enough for us to go fix the problem at hand?
I think this is enough for me to identify what happened. So if we go back to the code, you'll see here's that image load that didn't take too much time. Here's some basic I/O, and then here's that mutate that was only on the stack for a fraction of a second. But like I pointed out before, we see a whole bunch of string concatenation, and then here's a whole bunch of string concatenation happening inside of a tight loop. And I think that's going to be our culprit.
So just explain to me, why is that plus equal to there a bad thing?
So in this case, I'm actually taking a single string and then concatenating to it over and over and over again. And this is going to cause a lot of churn because it's going to be creating a whole new string every time I append to it, which means there's a whole bunch of junk strings that are getting thrown out, which is why we saw my allocation rate spike and the GC rate spike. So I actually already have a solution written up. So if we scroll back up here, it's quite a simple solution. You just have to use a string builder. This is exactly what it was made for. And if I replace all of those plus equals and concat calls with sb.append, and we switch back to the app and run the regular PPM, you'll see that it takes less than 0.2 seconds to do the exact same computation.
About 200 times faster.
Yeah, just about.
So we were able to use metrics to figure out that there was something wrong, and then we knew what to go look at by collecting a trace, right? So let's just recap what we've learned about tracing. So we introduced you to the .NET Trace tool that allows you to collect event source events, including sampled CPU stacks. You can obviously collect other providers, both those present in the runtime and custom providers as well. We are working on adding support for GC heap dumps, so we can give you object counts of what's on the heap that you can collect out of process in this manner. And we have tools for visualizing CPU stacks in SpeedScope, in Visual Studio, and Purview. And we're looking at adding other tools to visualize this data. You know, we have a prototype for Chrome DevTools, and we're looking at other stuff as well. So this was great, but I suspect this is not going to solve all our problems, right? What if I want to look at all the objects in the heap? Like looking at CPU stacks isn't quite going to get me that richer fidelity of information. So do we have something else we can look at today to get more information on what's going on in your application?
Yeah, if you're looking for something that's more descriptive of a precise moment in time of the entire world of your application, you're going to want a crash dump. So if we switch on back to my box, we can take a look at a bug that I've been hitting with one of the transforms. So whenever I've been running the grayscale transform, I'm actually hitting an issue where I throw an unhandled exception and my whole process dies.
Okay.
So I could go and load up a few different dumping tools, including our new .NET dump tool, but it's happening a little bit faster than I'm capable of hitting the keys. So let's go ahead and run my grayscale transform. And it's pretty instantaneous. But luckily, there's a command line or environment variable that you can set that tells the .NET runtime that if it encounters an unhandled exception and it's dying, to take a crash dump of itself. So in this case, you can actually see that as it was dying, it went and wrote a core file for me.
So if I understood correctly, I can use the .NET dump tool to collect a process dump on like when desired, or I can have the runtime set itself up to collect a dump when it's about to crash due to unhandled exception.
Yes.
So that's great. Now I have a core dump. How do I analyze this dump? How do I actually introspect what was in memory at that time and what is possibly the cause of my error?
So .NET Dump has another command, subcommand on it called analyze. Now, if I run that and point it at the dump that we just collected, you'll see we get this nice little REPL environment. So let's take a look at what we can run here. Now, if you're familiar with .NET Diagnostic from the past, you might recognize pretty much all of these commands. These are the commands from SOS. The REPL that I'm getting here in the .NET Analyze subcommand is actually a hosted version of SOS that's reading my dump that I just took and was placed in that directory earlier.
So for folks who aren't familiar, SOS is a set of debugger extensions that we shipped. It allows you to introspect .NET structures in memory and reason about it. Initially, it shipped in Framework. It shipped as an extension to WinDBG, but now we've hosted it inside a console application. Because we have a WinPE reader and we have an ELF reader, we can read these memory dump files ourselves, introspect the memory, and give you more rich information about it. So can you find out the exception that occurred, John?
Yeah, I can use the good old print exception command here. And if I just type PE, it'll go ahead and show me that we hit a system overflow exception, that I was doing some kind of arithmetic expression that resulted in an overflow. It even tells me that it happened inside of the convert to grayscale function. So let's go ahead and take a look at what might be the offender.
And John just showed you running PE, but you can run dump obj or dump heap, or the newly added SOS command for dump async that can actually walk the heap and stitch together async stacks. So definitely recommend you try that out.
Lots to explore in that tool. So if we take a look here, part of converting an image to grayscale is taking weighted averages of all the various color channels. So in this case, I was taking 30% of the red channel, 59% of the green channel, and accidentally 111% of the blue channel, which means that I'm definitely going to be overflowing if there's any blue there. So it's quite an easy fix. And if we go ahead and replace the code and rerun my process and rerun the transform, and go ahead and see we get our nice little grayscale image.
So this is great, but what if I was running in a Linux container? Would that work? Because we spoke about debuggers, and because I know there are difficulties even building LLDB, say if I were running in an Alpine container. Will this work in an Alpine container?
I actually ran that entire demo from inside a container using the new dev container experience in VS Code and Visual Studio.
So do you need to do something special to run in a container to get this to work?
Yes. So when you're running inside of a container and you want to take crash dumps, this is going to be the same regardless of how you're running your container. You need to enable a couple capabilities, namely the sys ptrace capability, as well as setting the security option setcomp undefined.
OK, so let's go ahead and recap what we just learned about capturing and analyzing memory dumps. So right now we don't have any dump collection or analysis on macOS, but it's fully supported on Windows and Linux, including ARM64 and Musel-based distributions like Alpine. It does not require sudo privileges on Linux to capture a dump, but you do need sys ptrace, and you do need to turn off seccomp so you can actually collect the process dump. The collected dumps aren't portable, so you need to analyze it on the same OS architecture, or at least the same architecture and libc version, like set of native dependencies, so that you can analyze it. So that was the ability to collect dumps and analyze them without using a debugger.
Yep.
Right? So the obvious next question after we've introduced people to all these tools is, how do we acquire these tools? So these tools ship as .NET Global Tools. Global Tools, if you haven't heard of before, are just packages on NuGet that have an executable, and the .NET SDK knows how to extract them and place them on your pod so you can run them. So once you've acquired all these tools, once you do .NET tool install, you should just be able to do .NET space counters, just like how John ran them on his machine. In addition to the tools we mentioned, we have a couple other tools. We have .NET Symbol, which is a tool to download all the files necessary for debugging. That includes symbols, modules, SOS, the DAC. And it works for ELF and WinPE. Like we said, macOS and Mako dumps aren't supported quite yet. And we have .NET SOS, so we spoke about how you don't need a debugger to analyze memory dumps, but there are cases where you might want to you might need a native debugger, say to look at native stacks, or look at like manage to native stack transitions, like disassembly, things that aren't possible with just our hosted version of the tool. And for those scenarios, we have a global tool that allows you to configure LLDB and load SOS. On Windows, it's even easier because we ship SOS as part of the WinDBG extension and gallery. So you should just open a process dump and be good to go. Just make sure you have a new enough version of WinDBG. And with all those tools covered, I think we're ready to take questions from people.
Thank you, guys. So let's see if we have any questions up here. We have like a try.net Jupyter Notebooks question. Yeah, it doesn't seem like we have too many questions, but is there anything else you want to add to the talk?
I think let's recap. So there were a lot of capabilities we covered.
Yeah.
So we have this big scary slide that we were, you hoping to use for one of the questions, but we talked about things that we've added. So we've added stuff in the runtime. So the runtime now synthesizes counters. We have runtime counters and ASP.NET counters. We're looking at adding new like ADO, EF counters. These are emitted via event counters. And these can be consumed via the event pipe, which can be consumed in process via the event listener or an IPC stream. These can also be collected via your OS native eventing mechanisms. So we have support for ETW on Windows. We also have support for LTTNG, and that's something that was there previously as well, will continue to be there. One of the things we've also done is if you're using ASP.NET or other app models that make use of iLogger, we actually pump all the logs to iLogger through event source. So you can connect out of process to your running application and egress, say, ASP.NET logs without having and you can change the verbosity on the fly, do things like that. We've also added the ability to capture a process dump and analyze it.
Cool. We actually do have one question real quick. Event source dump, like event viewer stuffs or something else. Crash dump, is this something like blue screen crash dump and we have to use Crash Analyzer to open those files, is the question.
So event source is a class inside of the runtime that allows you to essentially write your own eventing into your application. So it's more akin to being able to call an event and see that in a lot of rich, detailed information. You can feed objects into it, you can feed additional metadata into it, and it's a lightweight infrastructure for egressing that out of your application. Crash dumps are state of the world when you hit a certain point in time. So you mentioned sysinternals. There are tools like procdump that enable you to take crash dumps. There are lots of other ways of collecting crash dumps as well, right-clicking in Task Manager on Windows, using LLDB or GDB directly when you are working on non-Windows platforms as well.
Great. Thank you so much, guys. We're going to actually run to some commercials right now, so we'll be right back.
Hey there, treasure hunters. Here's the next clue for your hunt, your journey. And it comes to us from our friends at DevExpress. And they riddle you this. We love helping developers solve their tasks. Whether that's helping them write code faster in Visual Studio or integrating powerful UI controls into their WinForms, WPF, ASP.NET, JavaScript, or .NET Core applications. Our loyal customers love us too, and there's a special number that shows just how much. Follow the clues to find it and continue on the treasure hunt at this address. Head out there now, follow their clues, and respond to the .NET bot in the Visual Studio Twitch channel. Whisper that response, that magic number, and you could be well on your way to the next step in the technical treasure hunt.
We are in the exciting and ever-changing age of big data. The volume, velocity, and variety of data has been increasing multifold in recent years. Take, for instance, a factory. There could be thousands of IoT sensors, or Internet of Things sensors, in a factory, each producing petabytes of data. And now while it's great to have that much data so you can understand how our machinery is functioning and places for improvement, how can we actually process it all when we have that much? And more than just that, how can we process it all quickly and efficiently? Well, welcome to the world of Apache Spark. Hi, I'm Bridget Murtaugh, and I'm a program manager on the .NET team here at Microsoft. In this series of .NET for Apache Spark 101 videos, we're going to be diving into the exciting world of big data analytics within the .NET ecosystem. So what is Apache Spark? Apache Spark is a general-purpose distributed processing engine for analytics over large data sets, typically petabytes or terabytes of data. Put maybe a little bit more simply, Apache Spark is a great tool we can use to analyze a lot of data in a quick and easy to understand way, so you don't have to be a data science expert to use or understand it. So there's quite a few useful things that we can do with Apache Spark. For instance, there's Spark SQL, which allows us to analyze structured data, such as data stored in a CSV or in a database of some sort. There's Spark Streaming, which allows us to analyze and gain insights from data live as it's being produced. So in our factory example, we could gain meaningful insights from our data live as it's coming from our IoT sensors. So if there is some sort of malfunction in the equipment, we could detect it and go address it. There's also machine learning capabilities with Apache Spark so that we can combine the powers of big data and machine learning to get faster training or prediction. There's also visualization opportunities so that we can gain meaningful insights into our data through graphs or plotting or other visual means. So in order to understand how Apache Spark works, there's only three main components that we need to discuss. The first one is the driver. So the driver consists of the user's program. So for instance, that could be a C# console application that you've written. And it also consists of the Spark session. So the job of the Spark session is to take the user's program, so to take that C# console app, and to divide it into smaller pieces, which can be known as tasks. Those tasks will be divided among our second component, which are the executors, or the worker nodes. So each worker node is going to get its own task, and with that, it'll be able to execute a small part of our user's program. The third component of our architecture is the cluster manager, which helps manage allocation of resources and how our program overall gets divided and then executed in the end. So now that we know how Apache Spark works, it sounds great. I want to be able to use it to analyze all of my data, all of my terabytes and petabytes of data. But up until now, the popular APIs for Spark were written in languages like R and Python and Scala. But what if I want to use Apache Spark with my pre-existing .NET code or knowledge? Well, we now have a great solution, and it's known as .NET for Apache Spark. So if I go to the .NET website, which is just dot.net, I can scroll down and find the machine learning section, because we've combined the machine learning and big data sections together. So I'll go past ml.net for now, and I'll see .NET for Apache Spark. So .NET for Apache Spark is a free, open source, and cross-platform big data analytics framework. Like some of the scenarios we had mentioned earlier, like Spark SQL and streaming and machine learning, we can use .NET for Apache Spark for all of those applications. The .NET bindings for Spark are written on the Spark interop layer, designed to provide high performance for multiple languages. It's also compliant with .NET Standard, meaning anywhere that you already have C# or F# code, you'll be able to use .NET for Apache Spark, meaning you can finally use big data analytics in any of your .NET code bases. And as we had mentioned, .NET for Apache Spark is open source, so you can go ahead and check out the GitHub to learn more and to contribute to the open source community there. Thanks for joining me in this video, where we learned all about Apache Spark and the exciting new tool known as .NET for Apache Spark. Stay tuned to the other 101 .NET for Apache Spark videos to learn about all of the exciting applications we can start building and running using big data analytics in the .NET ecosystem.
What's up, everyone? Welcome back. Today, I'm going to be talking about Unity. My name is Christos Matskas. I am a product marketing manager for Unity and mobile. And I have a really great interest in this product. You probably have had a lot of announcements throughout the 2 days so far. So .NET Core, Visual Studio, and Visual Studio for Mac. So today, what I want to show you and why I wanted to pick up this session is because I wanted to showcase that with .NET you can build some amazing things, including games, right? Our agenda for today is very simple. I'm going to introduce Unity to you just to let you know what it is and what you can build with it. And then I'll show you how to get started if you've never done Unity gaming before, like I haven't. So it's a great experience to see how you can set up your machine. Then I will show you why you want to use Visual Studio or Visual Studio for Mac to write your games. We'll do a few demos just to showcase the capabilities. And finally, we'll talk about why Visual Studio is so well aligned with Unity and what makes it such a great product for debugging and writing your games or your 3D real-time applications. And hopefully at the end, we'll leave you with some learning materials and set you up for the next few sessions of the day. So getting started, Unity, of course, is the most widely used real-time 3D framework. Right? It started as a game engine, but now they're targeting different industries. So their goal there is to give you the tools to create applications for not just games, but 3D real-time applications. They're the most widely known engine, and it's built on .NET. So if you're a .NET developer, there's nothing stopping you from writing games starting today. And the nice thing about Unity is that you don't just have one platform, but you have over 25 different platforms, whether you want to develop games for Xbox, whether you want to build solutions that run on Windows or Mac OS. Obviously, mobile is very big. Mobile games are fantastic these days, and many people monetize on that. So if you want to build things for that, then that's also there. tvOS, the platform is insane. So taking your .NET skills with Unity and our IDEs means that you can build almost anything for any platform out there. And getting started, obviously, the first thing that you need to do and you need to be aware of is that ever since 2019.2 version of Unity, things have changed quite a bit on how you install Unity. So there are two ways to get started with Unity. One is you go to the Unity website and you download the installer, and then that allows you to actually go and get the bits that you need. So it's a Unity first experience. And many developers that know Unity will start from there. But if you're already a Visual Studio developer, there's a way for you to add the Unity workload to allow you to get started. So we'll see how you do both. So if you're inside Visual Studio, you select the game development with Unity, and that will download the Unity dependencies for you. And the other way around, if you're already on Unity, then you can go and add the components that you need. So if you are on Mac OS, then it will download the Visual Studio for Mac components. If you're on Windows, it's clever enough to let you know that you need to download Visual Studio. So I already have both the installers here. So if you're in Visual Studio installer, you're just going to modify. It kicks off the modification of the latest version that you're using. Today we're using 16.3, which is the latest and greatest. And if I scroll down here, you'll find that I already have selected the game development with Unity. If you don't have it selected, you add that, and we'll bring down all the necessary dependencies. So I can close that off. And if I go to the Unity hub, up until this point, that didn't exist, so you would download directly Unity and get started. But now they have a Unity hub like the Visual Studio installer, and it allows you to add multiple versions of Unity because certain things may not be working with the latest version of Unity, especially their component engine. So here you just come to install. You add your installation, and then from here you can also add modules. So in this instance, you'll notice that we already have the Unity game development checked in because we went from the Visual Studio workflow first. But if you don't have it, if you start with Unity, then that's the way you get started. And that's all you need. As soon as you do that, if we jump back to the slides, you'll notice that there are certain things both inside Unity and the Visual Studio installer that show you that everything has been configured correctly. So we're ready to go with these ones. And what this one is telling here for the external tools is that if you are working with Unity and you are on Windows, it has already recognized Visual Studio 2019 as present. And I've already checked in the editor attaching because one of the big things that you want to do is as you write your code for your games, you want to make sure that you can debug the code, right? And you want to do it in Visual Studio because it's the best editor out there. So next we're going to look at why would you want to use Visual Studio or Visual Studio for Mac over, say, Notepad or OneNote or whatever. If you've been developing for a long time with Visual Studio, you probably know some of these capabilities. But if you're not, if you're new to Visual Studio, or if you're just focused on Unity, then I would like to highlight some of the big features here. Obviously, refactoring is big. As your code grows, you want to be able to quickly jump into the code and change things, move them around, clear your code, and what have you. So you can always use the mouse and right-click on a line, or you can instantiate the command by using Control or Command dot. And you can go straight to definitions. I will show this in a demo very quickly. You can navigate to decompile assemblies. You can get suggestions for variable names. The ID guides you through a lot of good practices, and will try to give you the tools that you need to build good code. So if you're creating a method that you want to duplicate, for example, then we can quickly do that in the code. There are a lot of tools there to make you more productive with the scripting in your games. Multi-cursor mode editing, we got global search. That's very big, because if you have a big code base, as your code base grows, you want to be able to quickly search and find different components in your code. Going to enclosing block if you have big blocks of code. And finally, whether you're working on Visual Studio or Visual Studio for Mac, and you like a specific set of bindings, then we also give you the ability to actually switch the bindings around. So if you're in Visual Studio for Mac, there's a setting there that tells you, I want to use my Visual Studio key bindings. And since I have both machines as well, I like to have that consistency across the two IDs. So you can do that as well. Next one, we have IntelliCode. Some people may already know IntelliSense, and IntelliCode is the next level. It's the AI-guided IntelliSense that you get inside your code, and it's always context-aware as well. I will do a demo on how IntelliCode works and how it can improve your game coding. Visual Studio LiveShare, this is a life-changing experience, because up until this point, you maybe have been developing in teams or developing in isolation, and you always get stuck, right? There's always the internet, but there's nothing as somebody out there that can help you out. So using LiveShare, you can actually set up a session to share your existing coding environment with somebody else. So there could be somebody sitting 3 hours away from you watching TV on their Surface Go, and then you call them and say, I'm stuck with this solution here on my game. I don't know what to do. Can you help me out? You can actually spin up a session inside Visual Studio. They could be sitting on their sofa, playing with their Visual Studio code, doing some web development. They don't need to have the exact same setup. You'll be sharing your environment. So LiveShare allows you to unblock. It allows you to share your environment and find solutions to problems. Sometimes you can use that as a learning experience as well. So that's really important. I will show you how to spin up a LiveShare session if you want to. We have built-in source control, obviously, if you're using Git, and most people these days tend to use Git, and we do have built-in ID support there. We have real-time code analysis. That's very important. As you write your code, you want to have real-time feedback. You don't want to have to write your code, save it, and then build it, only to find out that something is not as you would like it to be. That also includes some of the things that I'll be talking later, like Roslyn analyzers, and getting immediate feedback about the quality or the errors in your code. Editor config is very big. Lots of people talk throughout the conference so far about editor config and how it ties very well with Visual Studio or Visual Studio for Mac. And for those people that have not used editor config before, it's a way to actually define code, how the code should look and behave, how you want your variables to be declared, how you want your spaces and tabs to be declared in your code if you want to go down that route. And because it's a file that is checked into your solution, it follows the code everywhere you go. So if a new developer joins the team, then editor config allows them to pick up the exact same code habits, if you want, and apply them to their code base as they code. CodeLens gives you a very quick glance about how your code has changed over the times and over the years, how many check-ins you had for a specific method and what have you. And then some other capabilities is obviously if you're changing across machines, if you work at the office and then you come home and you pick up the work, you can actually synchronize your settings for the IDs across those devices and across those environments. So you can have a consistent Windows layout, you can have a very consistent look and feel. So if you prefer dark themes, then that's how it works. And then we have custom screen layouts, which you can save as well and then take them with you. And And if you didn't know, we already support light and dark themes on your IDE to make it look and feel as you would like to. So next, I'm going to jump to a couple of demos, and we're going to talk about some of the things I've shown you already. So moving back to my code, we have talked about refactoring. So usually when you are sitting in your IDE, you can control dot, and then you get IntelliSense and says, we can remove those usings and make sure that you don't have them anymore. You can also fix on all document, all projects, and all solutions. So if you're brave enough, you can apply that setting across the whole solution. So let's do the document over here. You'll see it says I can preview your changes, and then you can apply them. We have things like, let me do another one. You can see here, again, we have fixes. We talked about the multi-caret editing. So if I were to say add new methods, I could do Control-Alt dot, and then select multiple locations, or Control-Shift dot. Sorry, Control-Alt. Select 1, 2. That seems to not working. Okay, I'll move on. But we can also do multi-line editing. So if you're here and you want to change from private to public, you can go public and automatically applies. Again, we do support multi-caret editing across the files, but let me change that back to private. We don't want to break our code. Okay, so this one, I did talk about editor config, and the easiest way to showcase these is if I jump into my files. Let me just see desktop, and I already have an editor config. The easiest way to get started, I find, is if you jump to the Roslyn repo on GitHub. They have already an editor config that is pretty well tweaked so far. So as soon as we drop the editor config there, you'll see we have all these different settings. Obviously, you can also change them to fit your team's needs. And that means that if you want to break, or if you want to go from a warning to an error, then it allows you to go that. So you can see here the severity set to suggestion, but you can change it to error, and then that will cause everybody to actually go and fix their issues. But if I go back up, I'll pick up something that's very well debated and a heated conversation. So if I go with tab and save that, it's saving, it's thinking about it, there you go. So if I switch back to my code, you'll notice that I right now have 4 spaces everywhere, but if I do Control-K and Control-D, automatically applies the editor config settings to my code. That means that as soon as you add your editor config, you can go back and apply those settings to your files, which is fantastic. That means that your team can have a consistent code base there. So let me just, don't save that one, obviously. Let me just go back and revert that, because I'm pretty sure my team will be upset about the tabs. Space, save that, and again, that applies. I did mention about LiveShare. So if you've never used LiveShare, it's available on Visual Studio and Visual Studio Code. You don't have to have the exact same environment on the target machine, the one that you're sharing with, but you can go into LiveShare. It's already kicked off a sharing session. I don't have anyone right now to share with, but if I go into more info, you'll notice that it says just copy this URL, send it to somebody else, and with that they can actually join your session and share exactly what you see here, which is fantastic, especially if you're in games development, you're new and you need support throughout your coding session. So I'm just gonna stop that live share in case anybody wants to join, and I'll go back to some of the other things I talked. So let's see here, what else do we have? CodeLens, we have building source control. Yeah, let me just show you this one. So with source control, again, it will automatically pick up. I was using Git locally here, so you'll notice that there's a lot of files that have changed throughout my editing. You can also use an exclude, so git ignore, to exclude some of the files, because obviously you don't want to check in everything on your source code. And like in dark themes, with the settings, if you didn't know, you can create custom settings as well. So if you want to have a very specific layout for your games development, you want to ignore your debug, you want to ignore other things that are not relevant to you, or windows that are not like toolbox, then you can come here, create your session, your layout, and then you can apply it anywhere you are. These settings do carry with you as soon as you log into Visual Studio with your account. So if I were to change to a web layout, it will ask me whether I want to do that, and then it does it. There you go. It's very different, right? I want to go back to my default one because I don't like this one. I should have created one for Unity, obviously, but it's fine. So I'll go back to my default layout. There you go, applying this one. Fantastic. Anything else we want to highlight here? And IntelliCode, I will show you in a bit, and I will explain why. Real-time analyzers. We have Roslyn. If you don't know about Roslyn, you can download and install Roslyn analyzers. The IDE also comes with some default analyzers. So here, as I type, it might come back with a suggestion saying you're missing an underscore prefix, or you could make this field read-only. So straight away, it actually tries to make me a better developer by providing some suggestions for my code. And Roslyn analyzers are very powerful because they run at real time as you type your code, so you don't have to again save and build before you find out that there are some warnings against your code. Right, moving on, I want to highlight why Visual Studio is so important with Unity, and why when you use them together, they set your code on fire, right? You become a lot more efficient. Obviously, IntelliCode now has been designed to work with most of the C# default projects, but our team is working to bring the Unity API messages into IntelliCode, which means that we're scanning our code bases out there to make sure that we pick up the best skills for your Unity games. And IntelliCode goes one step above IntelliSense because, as I said earlier on, it's context sensitive. It knows exactly where you are and what you're doing, and will provide you with the best ideas as you type. Visual Studio does come with superior debugging. We have the ability to set up trace points and breakpoints and really dig through the code. There have been already sessions that show advanced tips and tricks on how to debug using Visual Studio, so I would urge you to go and see these. We also added a Unity Project Explorer, which makes your experience slightly better. So if I switch back to my Visual Studio, you'll notice that I don't have it down here, but if I search for Unity, you'll notice that it has Unity API reference and Unity Project Explorer. So that brings up, it gives you a more simplified version or a look and feel of your files and your assets, so you don't have to go through the standard Solution Explorer. So we have an optimized experience for you. Attach and play, going back to the IDE, up until this point, we only had attach, so you had to spin up the game, and so you had to spin up the Visual Studio attached to Unity, and then you had to go back to the Unity editor and spin up the game, and then set breakpoints here in order to be able to attach. But now, lo and behold, we have attached to Unity and play straight away, so it will kick off your game end to end. So if I were to try this one, and we can also put a breakpoint over here, we'll kick off my awesome game. It's not awesome, but I did spend an afternoon writing this game. So I wanted to prove to myself that as a .NET developer, I can write something in Unity in not a lot of time. So within one afternoon, let's say 4 or 5 hours, I was able to put this thing together. So let's see if it's already kicked off. The breakpoint is there. If I'll go to my game, trying to switch now. Maybe. Right, let me stop that one. Bring it back to focus. I think it's right. Something resolution something. Okay, so that's my game. It's a very basic game. I created a car and I put some obstacles on the road, and what I'm trying to do is circumnavigate around them. So I had no knowledge of that. I've used some ready-made components. So Unity makes it very easy to actually create a whole world out of ready-made assets. So all you have to do literally is write the experience or the behavior around these objects and how you want them to behave. Right now, before even starting coding anything, these were just dumb objects sitting on our scene. So what I did is actually add user controls to be able to navigate around the car, and then I wanted to also add the behavior of moving the camera behind the car so it follows the car as it goes through. And later in the game, or in my talk, we're going to add one behavior, which is exploding crates, because there's no fun if there's no explosion, right? So I wanted to make sure that if you touch the crate, it just explodes. So right now we're here. You see it actually has kicked off the game. So I can see, I think, there you go. We can navigate around the space. It's very basic. I showed them to my daughters and they were not very impressed because they play Xbox, and then when I showed them this, I was really excited, but the excitement did not really pan out with them. So as you can see, I can already control it, and the code that I needed to write to make this happen was literally a few lines of code. So in this instance, we have 4 lines of code that control the forward and backward and the sideways movement, and then 1 more line of code that actually allows us to control the camera. Now, I did speak about IntelliCode and how it works for us. So if I were to do transform here and then do a dot, you'll notice that we do have position, local scale, parent, local position, and rotation. It's the IntelliCode here. It tells the code that you might want to use these first because these are the most common ones in the context of the update. So maybe you want to pick these ones up rather than try to find through the API. As you can see, it's a massive API here. I have no idea what I need to do. So IntelliCode really helps me focus on the things that really matter. And the nice thing about that is that if you go into an if statement, then it will actually change the whole experience. So let's say if I go down here and say if, and then transform, and dot, you notice that it's changed slightly, so it gives us the root, which was not there before. It also gives us a child object, so it looks for, like if transform has child objects, you might want to do something. So IntelliCode hones in into those those parts of the API that do make sense to you. Right. I did talk about IntelliCode, yes. And one more thing about IntelliCode, right? We already have the automatic IntelliCode, which does a lot of things out of the box for us, but you can take it one step further by training IntelliCode to apply specifically to your code base. So if you search for IntelliCode up here, IntelliCode, you notice that there's IntelliCode model management. And what this does is allows you to submit your code to our IntelliCode engine to create the model that you need to apply to your machine. And that makes it very specific to your code base. You can also share that with the rest of the team, and that makes everybody more efficient. So if you have a large code base with a lot of classes that you want to be able to quickly bring to the surface, then IntelliCode allows you to do that. And you also have a custom model for Unity to allow you to even be more efficient. Right, jumping back into our Unity, the last thing I wanted to do is obviously show you some of the good things in Visual Studio. We do have the ability now to create C# files, shader files, and enum files directly in the Unity project, in the Explorer. Faster project reloading, so we want to make sure that as you change your code from Unity, then the project reloads much faster, especially if you add a lot of assets. We want to have reduced time for debugging, so not many delays. The team has really focused on better performance. We also want to support more unsafe code debugging options. And we have Unity-specific analyzers and diagnostics inside Visual Studio to make you look better and have better code. And finally, we're suppressing non-applicable C# diagnostics. So with that, I wanted to go back to our game and just add the explosion. Because, as I said, I promised you explosions, so we'll see some explosions. This time, I'm going to go via Unity. So here, you'll notice I have an obstacle. Which I'm actually using to create lots of obstacles in our game because we have about 6 of them. It doesn't have any behavior or code, so what I'm going to do now is add a component. And in this instance, we're going to add some C# files, so a new script. We'll call it collision detection because it's actually colliding with something. Collision helper. There you go. A new script, collision helper, create and add. So this will add it to our obstacle. Now, because everything else in our code base inherits from that base obstacle, all I need to do now is go into our, where did that go? Oh, it's still loading. Right, okay, still fixing it. Adding it. There you go, so the collision helper here. Now, that file is here. Let's tidy up a little bit. We want to have a nice, tidy solution. And I'm going to jump into my collision helper. This will open inside Visual Studio. I'm going to delete these ones because I don't need them. And I'm going to add my snippet. So what we're doing here, very basic, took me probably 2 hours to figure it out. 4 lines of code, and there you go. What we're doing is we're getting the game object. We need to make sure that it's only the vehicle that collides with our crate, right? Because if everything else collides, then we don't really need to know about that. Then we grab the particle system that actually throws the explosion. We make sure that we have a handle on that. In fact, I see I've used the curly brackets that Matt stocked on the first day to check whether it's null or not. And then we need to make sure that it's not playing right now, and then kick off the destroyment. So I'm going to kick off the game now. Let's save this one, and then kick off the game, blow something up, and then we can move into questions. There you go. It's going to take a couple of seconds. And explosion, right? That's it. 4 lines of code, and you have an explosive crate. Right, last slide for me for today is all about what you can do next. So if you are keen on learning what you can do next, we just go and download Visual Studio at the Unity. We recently launched some amazing learning tutorials with Unity in collaboration. So go there. We have more than 6 hours of learning materials. And then we also have a how to build your first game. Our PM, John Miller, wrote this one. It goes through step by step on how to use Visual Studio for Mac and build your own tic-tac-toe game. So thank you very much for joining me today.
Fantastic. We have one question for you, my friend. It is, what UI controls are compatible with Unity?
From UI controls. So there's a lot of components out there. You can get a lot of assets from the Unity store. You can get a lot of assets from third-party suppliers. So I think it's as much as your budget can afford.
Oh, fantastic. That's amazing. Well, thank you so much for your time, my friend. That was amazing. We have a short commercial break, and after that we have building amazing cloud-connected apps with Xamarin, Azure, and App Center with my dear friend and colleague, Matt Sukup. Let's go to the commercial right now.
Hey there, treasure hunters. Your next clue is courtesy of our friends at DocuSign. And they want you to use the landing page to guide you in poking around DocuSign's C# tools to find the solution code. Go to this URL, poke around there, find that secret code, whisper the response that you found back to the .NET bot in the Visual Studio Twitch channel. Let it know, and you could be well on your way to the next step in our technical treasure hunt.
Hey friends, let's talk about a Hello World app. Now we did a video on a Hello World app, but we did it from the perspective of C#. We looked at the namespace and the using commands and things like that. In fact, we did a whole video series and we ran the application. We hit Control F5 to start without debugging, but we never really looked and found the thing we made, did we?
Yeah, we were really code focused. And for me, it's not really concrete until I see where it exists on my computer's disk. So let's take a look at project types.
So what we're looking at right here is exactly where we left off at the end of the C# video series. We were making a little banking application. It's a console app. So it's not a Windows app that pops up and has buttons and things. It runs at the command line. And over here on the right-hand side, we've got this Solution Explorer. Are those my files? Is that a representation of what's happening on the disk?
Right, so what you see in the File Explorer isn't exactly what you see in the Solution Explorer. So here you have a bin folder and an object folder. You have .csproj files. None of that you see in the Solution Explorer because that isn't exactly what you need right now when you're in your coding.
Are they kind of hiding that from me? Because it's really not the point right now. The point is my code.
Right.
Okay, but we were building stuff, we were running stuff. We spent a whole bunch of videos learning C#. I was running my application by pressing Control F5 or start without debugging, or F5 to debug, but I never really saw the thing. Like, where's my thing I made?
Right, so the output of your app is actually in the bin folder. Why don't you double click on that?
Okay, bin.
And in debug.
Debug.
And in Netcore App 3.0. So now we can see the .exe, which is the output application of what we built.
Okay, so that's the stuff I made, my Superbank EXE and my Superbank DLL, and then there's some other kind of peripheral stuff that came along for the ride.
Right.
Can I run that?
Yeah.
Okay, so if I run that, well, that wasn't exciting. It just kind of, let me do that again. Maybe I did it wrong. It just came and went.
You didn't do it wrong. So that's basically what console apps look like. If we don't add like a console.readline or it doesn't wait for feedback, why don't we run that from the command prompt?
Okay, so I'll go out to my command prompt. I'm using the Windows terminal. And you'll notice that I'm in the same folder, right? I'm in the exact same folder. And I can compare these two folders.
Netcore app.
I actually right-clicked here in Explorer and I said copy. And I came down to the command line and I said CD and I pasted it in. That's how I got here. And if I type dir, that's the same stuff, right?
Yeah.
So you said I can run that. So my Superbank, I'm going to hit tab. Remember, tab's our friend in Visual Studio, and it's our friend at the command line. So I'll hit enter. Aha! That's what I was seeing yesterday when we were doing C# videos. Okay, so that's the app that we wrote yesterday, which is great. So the Superbank EXE and the stuff around it is my app. Can I just take that and give that to my family and they can run it too?
Yeah, if they're running it on the same operating system. If you want to publish it out to different operating systems, you can run different commands, but we'll cover that in a different video.
Yep, we're going to go through publishing and the difference between running on Windows or running on Mac or running Ubuntu a little bit later, and the idea of a .NET runtime and how that runtime is needed, and all those things in the publishing video. But that's a Hello World. Like that's the anatomy of a .NET Hello World application using Visual Studio 2019. Stick with us for more .NET Core videos coming up next.
Hello friends, my name is Matt Sokup and I'm a Senior Cloud Advocate here at Microsoft. And for the next 30 minutes, I'm going to show you how to build a mobile app using Xamarin, connect it to the cloud with Azure, and make it amazing with App Center. So let's jump right into it and show you what we're building today. So what I have here is, you may have seen this app used a couple times yesterday and during the keynote, and today it's the Pretty Weather app. And it looks pretty good, right? We have the weather conditions, we're in Seattle, we have the temperature, we have the current date, but the world doesn't revolve around Seattle, right? Don't tell anybody that here, but there's more cities involved. And so what we're going to do is we're going to make this app fully functional. And by that, we're going to hit the three little icons in the bottom. And then we're going to be able to sign into Chrome, say no thanks, and actually be able to sign into our app. So I'm going to enter my email address and my favorite password of all time, ABCD1234 with an exclamation point, sign in. And what this is going to allow me to do then is save cities that I want to be able to view the weather with. Hit a plus button, and I can now add other cities other than Seattle around. Enter Honolulu, probably has a little bit better weather than Seattle, and now I can be able to see the current weather conditions then in Honolulu. So what I did is, in addition to the current weather conditions, added a little magic to be able to sign in and have data follow me around to different locations or different devices. So let's see how we did all of that. We're going to be using, to build all this, three things. Xamarin for the mobile app, functions to be our compute in the cloud, and then App Center, mobile backend as a service to do auth and data, which wraps around Azure B2C and Azure Cosmos DB. So first up, Xamarin. So a quick overview of what Xamarin is. Xamarin is Microsoft's framework for building performant iOS and Android apps. But it's so much more than that. You can build Mac OS apps, you can build watchOS apps, you can build tvOS apps, you can even build apps for Samsung's Tizen operating system. So it's much more than just iOS and Android apps. And how this is done is that you use the great power of .NET and C#. So we have, let's say, an iOS UI, an Android UI, and a C# UI for Windows. So we're going to build a UI for each one of those out separately. We're using C#, we're using .NET, we have full access to the platform, but we're building those UIs separately. But we're building an app. That one app is still going to perform the same thing, although we have to build it for each platform. So when we call to that web service, when we go get our weather information, it's going to be done the same way. So we may as well use a shared C# logic layer, and that's where the power of Xamarin comes in, that we can write our shared logic just once and have it used across multiple platforms at the same time. But we can do better, and that's where Xamarin Forms pops in. So what Xamarin Forms does, it gives us an abstraction of the user interface layer. So let's say iOS has a button, Android has a button, and UWP has a button. So what we're going to do then is Xamarin Forms gives us an API that lets us program against a button. And then Forms takes care of emitting a natural native button for us. So now we're sharing C# logic for our application logic. We have shared logic for our UI logic, and we have more and more shared code. This is great. So that, in a nutshell, is what Xamarin is. The next thing I wanted to talk about is the compute layer, or Azure Functions. And so this is a quick diagram of what we're going to call the cloud native compute, or how we're going to architect our apps. So way back in the day, we had the on-premise architecture. And so what that was essentially, that was the old data, or the computer underneath your desk, right? Where you had to take care of everything yourself. The machine, make sure the operating system was good, you had to install all the software yourself. But as we moved along, we started moving to the cloud. So you had infrastructure as a service. So you no longer had to take care of the hardware. Then you moved to platform as a service, so you didn't have to really worry about the operating system. And now we're at functions as a service, or serverless, where we're only worried about writing our code. And so our answer to that is Azure Functions, where it's events being tied to code, and then we have functions. And so what are some of the events that we can write, that functions run off of? Think of having a blob being written to blob storage, or something being written to an Azure queue. So that in itself will actually kick off an Azure function and have our code start running. The secret sauce, though, comes in with the bindings. And so what a binding means is that we can have something, let's say from Cosmos DB, be bound to an Azure function. And then, like a document, can be sent into our function as a variable. So the same thing can happen with a Azure storage table or a file. It automatically gets sent in, or we can write it out as well. So this gives us a really powerful mechanism to write some really cool code with a little bit of lines. So some scenarios to demonstrate this. So let's say we had a timer going off every 15 minutes. That's our event. The function then kicks off. It will then find and maybe clean some invalid data from a table, and then we are resulting with a clean table afterwards. Another event could be a file, a CSV file, let's say, gets added to blob storage. We have a function then that takes that in, transforms that CSV file into data rows, and then from there, we can display a Power BI chart graphic. Or our scenario that we're dealing with today is our mobile app. It needs a forecast. It sends off an HTTP GET request to a function. That function then is going to call off to a third-party weather service, get the data back, and then it's going to massage that data into a version that the app can deal with, send it back down to the app, and then the app displays the data. So let's see how we can use compute with Azure Functions and add that in to our mobile Xamarin application. So this is what the function looks like. It's called get current conditions, and it's running as an HTTP trigger. So that means that as soon as an HTTP GET request comes in, it's going to trigger off this function and it's going to start running. And then it has various requests, queries that I can get, a latitude and a longitude, and then it runs through. So actually, let's kick this off and run it. So it's going to compile, and I'm going to run this all locally. And then as that fires up, I'm going to actually call it out through Postman, through this localhost 7071. And here I have Postman set up, and I'm going to be passing in a latitude and a longitude of Seattle. So I send it off, and it comes in here and hits. So now what I can do here is step through. So I get my latitude and longitude out of the query string. And then these next ones I'm just pulling out of essentially a config file to get my key and my URL for my third-party weather service. And so that's another great thing about putting this up in functions. Instead of having it in my mobile app, I can have the key to my weather service not on board my mobile app where it could be possibly compromised. I have it up on functions within the Azure cloud, and it's safer. Eventually, I could even put that in Azure Key Vault and really lock it down if I wanted to. Great. So back to the function then. All I'm doing here is using this client, which happens to be an HTTP client, calling getStringAsync, invoking that third-party weather service, getting my data back, deserializing it, and then finally, all I'm doing here is putting it into a version that my mobile app would use. So I continue that off, and down here, I just get this little JSON back, and this is all my map app needs to display its data. So I've already actually deployed that to Azure, that particular function, and I'm going to run my mobile app now to actually see it in effect. So I'll compile it and run it on the emulator. And as it's going, all I'm going to do here, again, is using the HTTP client, is called getStringAsync, and it's just calling out to prettyweather.azurewebsites.net to get its data back. So as soon as it fires up, still compiling, and then we should have it done in just a second here. Hopefully. And then we'll continue on talking. Here we go. So it loads up. Going to deploy it to the emulator. Then once that's done, it'll go through. And the very first thing it's going to do is going to hit this weather service here, get the weather info, and then it's going to deploy, call out to the function. Loading itself up, and then it should come in here, and that's what it did. It called the getStringAsync, and I can see my weather info that came back. It's the same thing as before. And now it's just been updated with weather from Honolulu. So there we go. So that's all that's involved with loading up and calling an Azure function from a mobile app. It's just an HTTP GET request involved. So that's pretty straightforward as far as it's creating just a backend, a web API, but doing it with Azure Functions, a cloud-native way of creating a web API. So now adding the real amazing stuff to functions or to our mobile app, and that's with App Center. And so what App Center is going to do is going to allow us to wrap together Azure AD B2C, Active Directory B2C, business to client, and also Azure Cosmos DB on a really nice, easy to use, developer-friendly SDK. And so the way this works is that a lot of y'all may be already familiar with App Center in the DevOps portion, where we had build and test and distribution. So what happened is that with build, what you would do is that you would connect to your favorite repo, and then as soon as you would push to that repo, it would build, it would kick off some unit tests, and maybe even some UI tests that would run on real devices. And then as soon as that was done, everything would pass, it would kick off to the distribution, whether it's distributing to the stores or whether it's to some external beta testers. And then you would have some diagnostics that could run So what happened if the app crashed maybe? You can get full stack traces. It could hook into App Insights. And then you have analytics where you can track how people are using your app. That was App Center. However, there is this new features called the Mobile Backend as a Service, where there's authentication, data, and push. Now what's great about these features is that they interact really well amongst each other, and they are super easy to use. So first we'll take a peek at what the authentication does. And as I mentioned before, Visual Studio App Center's authentication works hand in hand with Azure Active Directory B2C. So AD B2C itself is, I'm going to say it's a little bit involved in getting set up. And so what App Center Auth is going to help you do is going to help you ease that process of getting set up and making calls to it. So its focus is on making everything easy for you. And so the other way, so there's two parts involved in calling and authenticating and signing in your users. There's the B2C portion, and then there's the actual signing in portion, which is done through Microsoft Authentication Library, or MSAL. Now the MSAL is all done on device, and that's taking care of displaying the web view and actually communicating to B2C and performing the authentication, where B2C handles like calling out to Twitter or Facebook or your email to make sure you are who you say you are. So you have these two pieces that need to interplay with each other nicely in order to get your sign-in experience. App Center makes this whole layout and this whole journey way easier. This is what it looks like. It's just sign in async. Now, if you're familiar with what the MSAL framework was before, it's super powerful, but it was a lot of ceremony that goes along in setting it up. This is what it looks like now. It's super, it's nice, it's developer friendly, and that goes right along with the App Center ethos. Going along with this, I mentioned that right now it's just working with Azure Active Directory B2C, but in the future they're implementing something called Bring Your Own Identity. And so what this means is that if you're using Auth0, or if you're using Firebase, or if you're using Azure Active Directory already, you can just bring those in to App Center, and it's going to work for you. So you don't have to be just using B2C. You could be using any of those other identity providers, bring it in, and you'll still be able to work with them behind that beautiful SDK that we had. Then, next up is the data portion. So what the data gives us here is a nice wrapper around Azure Cosmos DB. So the way is, what I mentioned before, is that auth and data and push work together hand in hand. So this is one of the ways that they do. So we're logged in with auth, and then user A, user B, and user C, whenever they do some data information, they get their own private partition within Cosmos DB. So when I want to store some data, I get my user A partition, same with B, same with C, but yet we still have some public data. And so there's no, I don't have to set up as a developer, set up a new partition for anybody. App Center's SDK takes care of that for me. Another thing that we get with the data SDK is the ability to do offline writing. If I'm connected, it writes to the cloud right away, also writes to a SQL cache on device. However, if we're not connected, just writes to the cache on device, and we keep on going. It'll write up to the cloud next time we're connected. Same thing when we're reading. Always read it from the online cache or the cache on device. If we're connected, reads to the cloud and syncs up. Automatically works. You don't have to worry about whether you're online or off. The SDK is going to take care of it for you. So some methods here that you have. You create your data model, new it up, and then there's a create method, a delete method, passing in the IDs of what you want, and then the partitions here are the user documents as opposed to public. And then there's a list async to get them all back, a read for a single, and then a replace, which is like an upsert or an updating. Other cool things that we have with App Center is that you can see data metrics from what your Cosmos database looks like, all within the App Center portal. and you can actually go through and view different documents. And the best thing at all is that there is a free tier coming along. It's not there today, but it is coming along soon, so it is Cosmos DB free tier with App Center, and that's really slick. So let's jump in to the last demo that we have going, Walking on Sunshine, auth and data with App Center. So first thing I want to do is show you how we would set up the portal, the App Center portal, to work with auth and data. So what I would have here is I open up a App Center application, and I have auth and data here. So just by hitting auth, it says welcome to auth, connect my Azure subscription, and I can go through. I'm going to have my pretty weather. It's reading what's already in my Azure subscription, user impersonation, and then for the policy, I have to manually add my user flow, which happens to be this. User flow is the how you sign in. So it's like which identity providers, like if you want to connect to Facebook or if you want to connect to Twitter. And then I can just say connect, and that's all there is to it. Now my app is set up to use authentication. The same with data. All I'm going to say is I want to use an existing database, use my subscription, hit next here, which database, within it, user preferences, which collection, and that's it. I would hit done. So to show you one that's already set up and ready to go is one on my Android. Auth is already there. It's telling me my tenant name, my application ID, and the data. And you can see here I have overview and then my Explorer. And you can see I have both Seattle and Honolulu added. So the next thing what I want to do here is finally go through and show you the methods that I have set up to be able to log in and to save data. So I hit the little things below, and the sign in right here is just auth, sign in async. I have tokens that come back, an account ID, which is my B2C account ID. All within it I can get. Listing my cities out is just a data list async, sending in a city info, which just happens to be a regular class. Continue on. And then when I want to add a new one, I will come through here, pick a new city, and crash the app. So what it would look like if I would pick the new city then is save async, and it just says create async, city info, passing in everything I need. And then what I would have there is some really, really funky stuff. But if I go over to my real device, I can see if I load up the app, I should be able to see Madison, Seattle, and Honolulu come up. And obviously Madison did not save, but that's okay. So hopefully it saves here without crashing anything, and it comes over. So great. That's the quick version of adding everything and using App Center with a Xamarin Mobile app. So in summary, we use Xamarin for creating a cross-platform mobile application, Azure Functions for our serverless backend for our compute, and then App Center for our mobile backend as a service, data, and authentication. So please go out and learn more. Follow these documentation links for Xamarin, App Center, auth, and data. And finally, the bottom one there is all the code that you can want from this session.
All right. Thank you so much, my friend Matt. How are you doing today, my friend?
I'm doing well, Seth.
Fantastic. So here's a question that I always get that I thought I would ask you. Performance with Xamarin versus native is, like, tell us about that.
You get 100% native performance with Xamarin, as you would if you were writing something in Java or if you're writing something with Swift. You're going to get the same native level performance as you would. So there is no difference. As if anything, Seth, if you write bad code, you can get bad code.
Yeah, he's saying that from experience because we work together, and so he's seen some of that. All right, so here's another question. Does Azure App Center auth work with the securing with securing a web API being called from a desktop app?
That's a good question. So the Auth Center app, it works with securing a web API calling from a mobile app. I haven't tried it from a desktop app, but they do support WinForms in the other portion of App Center. So I'm not going to speculate and get the project team or the development team, product team into trouble, but it's just a JWT token.
Fantastic. Well, there's a lot of good links that he put up there, so make sure that you follow those and get some of the code so you can try it out yourself. It's pretty amazing. Now, as we go along, make sure to remember to participate in the technical treasure hunt. It's still going on. You're going to want to watch all of .NET Conf 2019 because .NET Partners are sponsoring a technical treasure hunt. There will be fun challenges to solve, and you'll be eligible to win a lot of prizes, which is cool. So what we're going to do is we're going to throw to a commercial break, and right after that, we're going to have a tour of what's new for XAML Tools and XAML Islands in Visual Studio 2019 with my good friend Dimitri Lyalin. But this first.
Welcome back, treasure hunters. I've got your next clue from those wily folks at Mobilize.net. They want you to use this choose-your-own-adventure Bandersnatch style story to decide what to do with some toxic legacy code. Choose the right path, and you're a hero. Choose wrong, and dreadful consequences might befall you. Go to this URL to get started. Whisper that response when you get to the end to the .NET bot in the Visual Studio Twitch channel, and you could be well on your way to the next step in our technical treasure hunt.
Hi, I'm Scott.
And I'm Kendra.
And we're going to talk to you about .NET. This is our .NET 101 video series. If you've just arrived here, you might want to go backwards and take a look at the C# 101 series. C# is one of the languages within .NET. But what is .NET anyway?
Right, so we've been talking about .NET for a while, and we haven't fully explained what it is. It definitely has something to do with development, so let's dive into that. So .NET is an open source development platform for building different types of apps. And of course, that next question is, then what's a developer platform?
Yeah, it's a little bit confusing. It is the languages that you use plus the libraries that you use, and that together is a developer platform, and .NET is one. Now with .NET, there are certain languages that you can use, C#, the one we've been teaching today, also Visual Basic and F#. And then the platforms, or the things that you stand on, the things that you write your software for, are .NET Core, which is open source. It runs anywhere, like Windows and Linux and Mac. The .NET Framework, which is very popular and been around for a very long time. It's let you write websites and services and apps on Windows for many, many years. And then Xamarin or Mono, which is a .NET for mobile. So you can write your .NET applications on an iOS device or an Apple Watch or an Apple TV or Android. All of this together is examples of .NET. These are multiple .NETs. And that can be a little confusing itself, so what we can do is just write to a standard. We can use a standard set of libraries and make sure that our libraries are standard. So you just think about the .NET standard, and your .NET stuff will run anywhere, which is really cool.
Speaking of running anywhere, what exactly can I build with .NET? Turns out, you listed a few of them just now, quite a lot. So we have desktop microservices, web, mobile, all of that. What's your favorite?
I like IoT. I like being able to write .NET on a Raspberry Pi or even on the Windows desktop. So I can write a Windows desktop app and then suddenly go to a tiny device and I'm using the same skills and the same libraries, which is really cool.
Definitely. Who builds .NET? Turns out it's Microsoft and several thousand of our closest friends. So over 60,000 developers and 3,000.
Hi, I'm Scott.
And I'm Kendra.
And we're going to talk to you about .NET. This is our .NET 101 video series. If you've just arrived here, you might want to go backwards and take a look at the C# 101 series. C# is one of the languages within .NET. But what is .NET anyway?
Right, so we've been talking about .NET for a while, and we haven't fully explained what it is. It definitely has something to do with development, so let's dive into that. So .NET is an open source development platform for building different types of apps. And of course, that next question is, then what's a developer platform?
Yeah, it's a little bit confusing. It is the languages that you use plus the libraries that you use, and that together is a developer platform, and .NET is one. Now with .NET, there are certain languages that you can use, C#, the one we've been teaching today, also Visual Basic, and F#. And then the platforms, or the things that you stand on, the things that you write your software for, are .NET Core, which is open source. It runs anywhere, like Windows and Linux and Mac. The .NET Framework, which is very popular and been around for a very long time. It's let you write websites and services and apps on Windows for many, many years. And then Xamarin or Mono, which is a .NET for mobile. So you can write your .NET applications on an iOS device or an Apple Watch or an Apple TV.
Hi there, welcome to another .NET Conf Talk. My name is Dimitri Lylan and I'm really glad you're joining me today. And today I'm going to do a session on XAML tools for WPF and UWP developers. We're going to go take a tour through XAML tools. I'm going to do a lot of demos, hopefully everything will work. We're going to look at features that are existing features you can use today, features that are coming. So we're going to do some roadmap, and we're even going to look kind of further out if we get time to say this is what's really coming down the pike in the future, and we want your feedback on it as well. So hey, let's get going. Before I jump into the details of my talk, I'm just going to mention that 3 days of content and desktop talks have been kind of spread out across all 3 days. So if desktop development is something you're interested in, I hope you can check out one of the other sessions. So there they are. They are also in the agenda. The agenda link is down below, and everything will be available on demand if you missed it or will miss it in the future. All right, so my session. So we're going to start off by looking at XAML tools. XAML tools, I'm a PM of XAML tools for WPF and UWP, for WPF and UWP applications, and I work closely with Xamarin Forms. So all the XAML teams work closely together. And in my talk, I'm going to cover what's new in tooling around Hot Reload, Designer, and the code editor. I'm going to talk a little bit at the end around modernization of applications using XAML islands, and just touch on roadmap just a little bit, and hopefully that'll be a good talk. All right, let's jump in. So this demo was going to be a code demo, but I'm going to apologize and do some screenshots, but it's a cool demo, so I hope you enjoy it. Unfortunately, my VM kind of died this morning. Thanks, VM. But let's talk about a new feature we're working on in the XAML Designer. So if you're a WPF or UWP developer and you use the XAML Designer, we're adding features to that capability, right? To that space. We have been thinking for a long time what feature would be a good way to increase developer productivity. So something we're going to ship in a future Visual Studio Update release as a preview flagged feature, so you'll have to turn it on, is XAML suggested actions. Think about it as a light bulb on top of controls. So we're starting off with a well-defined set of controls that we're going to enable this on. And a light bulb is going to make all the common properties of those controls available. So here's stack panel. Here's a label. We even have nice color pickers we're going to build into that. Here's the image control, things like source, visibility, very much common properties. So as I kind of go down this list of controls, you see that these properties are probably the ones you often have to go set. And today, if you will go into the properties panel, it's kind of hard to find the most common properties. This is hopefully going to alleviate that. In the future, it will even expand to other capabilities as well. So it's a cool feature we're working on. It's going to ship in a future preview. 16.4, one of the update trains, one of the preview trains. We'll put it into the release notes when it's available. It's going to support the controls up on the screen right now that are listed, but it is going to be extendable. We are going to add it to more controls in the future, and we're looking at actions, because sometimes you have a control that has properties you want to change, and that's great. Other times you have a control like a tab view. You need to add another tab. So instead of having to know how to do that XAML or have some other paradigm in the UI that lets you enable, to add a new tab easily, we're going to try to see if these quick suggested actions work well for you. So check it out when we make it available. Just wanted to show you one future-facing thing, and unfortunately my demo failed. All right, so from here on in, it's demo time. So I'm going to jump right in and talk about a story that could have been a little bit better day one, but such is life. So today, yesterday, WPF Core shipped. That means WPF Core as a framework is GA. And if you install Visual Studio 16.3, that means you have the tooling. Unfortunately, the designer is off by default. We screwed up. We made a little mistake. So I'll show you how to enable it. If you go to, if you have a WPF project, so this is a WPF project right here, you go to Tools, you go to Options, and you go to Preview Features. If you enable Use Preview of the .NET Core SDK, and you restart it, and we'll do that just to kind of prove the point. So let's restart the application real quick. And I should have my little demo app. Okay, let's get this thing open. All right, so you can see Designer is loading. Totally our fault, sorry about that. But Designer is there, and we're going to service this release to make it available. But I just showed you how to enable it right away and start using it. Now, the one thing I do want to point out is that, and let's make sure I have the right, I have so many of these little applications. Sorry, I just need to make sure that I'm looking at the right one. All right, yep, this is the right one. All right, so we have multiple designers that my team works on. So some of our designers, one of them is for .NET Framework, WPF, one of the .NET Core, and one is for UWP. So if you really pay attention, you switch between those three, you're going to see some slight differences. Those are not bugs. Those are differences that we've sort of made decisions on. We're here to hear your feedback on it. But for the most part, most of the features of the designer work the same across all of them. So everything you would expect in this designer to works here. So if I go to Toolbox and I go ahead and I drag a button, that works. And if I resize the button, that works as well. XAML is changing. One tip, lots of people don't realize there's an edit template feature in here that can create a copy of a style. This is accessible through right-clicking a control on the design surface or in the document outline, so it's really available anywhere. And if you right-click on that and say, yes, created within my application here, you get a bunch of XAML. So designers are here. Quite a powerful feature. Some of the features that we also get asked, would you add the feature? And we say it's there and it's our fault you don't know about it. So we're working to fix that. But one of the cool features is regions. So I'm going to show that feature right now. Region button style. So this came in through surveys. People were asking me, Dimitri, can you please add this feature? And I wanted to show that it's there. So we can add a region. And then we can collapse the regions. So region begin, make sure it's right, and region, am I having my first demo fail of the day? Oh, Jesus. When something just works every single time, well, I can assure you this feature does work. I've tested it so many times, not sure why this is misbehaving. But there you go. Sooner or later, one of your demos will fail. But basically, regions are in there. Give it a shot. If you hit a bug like this, please let us know. We're here to make it better. So I just wanted to show that designers there. We have region support in the XAML editor, and we have the ability to edit default styles or templates. So from there, I'm going to jump into the meat of the demo, and we're going to talk about an application. We're going to use this application for the rest of the talk that I've been building. Using some newer bits than what you would have access to, but for the most part, all the things I show will work with some minor exceptions, and I will point those out as we go. So here's my project. It's here for demonstrative purposes. There's really not a lot of code to it. It's just a basic WPF core app. I have a view model with some dummy data. It's like a fake email client, that we're building. It's really, really poor. And there's an object called email, and I'm going to do some binding to it in real time. So with this application, I'm going to just reset it back to the original state and just run the app and show you that it's really bare bones. There's absolutely no code in here right now. And then we'll begin coding, and I'll talk about some of the features. So first things first, there's a bunch of tools that are related to the hot reload feature that I'm about to demo. The first tool is the in-app toolbar. This is the toolbar that appears in the application itself at the top. It's collapsible. One of the new features we added is we made it movable left and right because sometimes we'll block UI. If you collapse it, it's pretty small, but still, that wasn't sufficient in all scenarios. We also added this right-hand side hot reload available because developers were not aware if this feature was working or not. There's some scenarios where the feature doesn't work. So we added the message that says unavailable or available so that it's very clear if hot reload is on, and you can collapse that away if that's not helpful to you. Clicking on the link will take you to documentation, both the documentation says how to use the feature in this case, or if it's unavailable, how to resolve that as well. So it's a really important tool, and hopefully you find it useful. One of the things that a lot of people don't realize also is there's a button in the live visual tree that if you click the button, it completely goes away from the application. So it really doesn't have to be there if that's not something you want. In our case, we're going to put it back in. And I want to show hot reload. And hot reload is a feature that changes the app as the app is running. This app is running right now. I've cheated a little bit. I've created a view model and I created all the placeholders because when you're running with hot reload, Visual Studio will block you from adding a new control or changing the structure of the project, right? So you kind of have to make all of that available. And while I can edit C# using C# edit and continue, view models don't respond very well just because of how it's architected. So I put all of that in place, and now I want to show you how hot reload and some other features make this really good experience. So with that, I'm going to show you the first feature, which I'm just going to add a button just for the sake of demonstration purposes. So I'm going to add a button in here. The button will be 100 by 50. All right, there's the button. And if I go back to an application, I see the button. It just appeared magically because of hot reload. Now this window, I'd actually love for it to be visible at all times. So I'm going to go in here and say topmost, and I'm going to say true. And now the applications will be visible all the time. These are changes that are happening to XAML and being reflected in real time. So what if, let's say, I wanted to learn more about the button, see the C# code behind it, and I didn't know where the button was in source. In this case, it's easy. In most more complex applications, really complicated. We have a button called Enable Selection. You click on that, click on the control, and in our live visual tree, you can see the button. And this is where I want to highlight a new feature that's coming soon. It's not yet available, but this feature is coming soon. It's called Just My XAML. If I turn Just My XAML off, you get a much bigger live visual tree. We show you everything in a live visual tree, and that's useful sometimes. But by default, we find that only the XAML that you've written is useful. So we're adding a feature called Just My XAML. It'll be on by default. There'll be a setting to turn it off by default in case you want the old behavior, so that's pretty cool. And this is basically giving you all the flexibility here to build your app as app runs. Now actually, let's start building the app for real. I'm going to go ahead and kill this temporary button and show you a feature that we've gotten kind of by default because other teams are doing work called IntelliCode. With IntelliCode, you get stars in IntelliSense of the most likely actions that our AI analysis shows that you might take, so RML. That means we've looked at GitHub, we looked at open source projects, and we've made some decisions based on that data for XAML, C#, and other languages. So here it's saying to me, there's a really high probability that you want to add grid column definition, grid row definition. In fact, I do. So as I do that, it says, hey, there's a really good chance that now you want to add a column definition. Yes, I do. And as I'm doing that, it makes writing code just so much easier. So here I am doing row definition. I'm like tab completing through this like no tomorrow. So it's really, really performant. And hot reload's making all these changes come alive for us in the app itself. So as we go through, I was going to write all the code, but as I realize how little time I have, I'm just going to cheat a little bit and cut and paste a few times. You don't really need to watch me type. That's fine, right? All right, so first of all, let's add some meat to this application. So I'm going to paste this thing right here. All right, and as soon as I do that, my app comes alive. I just created a list box. I created a list view, and if I click on the list view, there's an area here where the details of the email should be coming up. I've also created some references to some styles that should be in my resource dictionary. Now I have a resource dictionary, so I'm going to go ahead and create that. So I'm going to go in here, and I'm going to go to my solution. So here's my merged in resource dictionary. So I'm going to put some code in there, save that off, go back. So now the error went away. All of a sudden, my application slightly changed. So as you can see, it's actually working in real time. Hey, let's take it out. The application changed, put it back in, application changed again. Very powerful feature in that sense. We also have a cool feature available as part of the in-app toolbar, which lets you see exactly the alignments of things. So as you select, you can see how that selection is aligned to other things. So we draw grid lines based on enable selection. So you say enable selection, you click on something, and then it enables you to show the grid lines around it and across. Very useful feature in more complex applications. Right there, you can see exactly where reminder baby shopping ends, and you can see how that aligns with that was useful. So a cool little feature, display adorners available. And then with the selection, I'm able to once again click on here, and then see exactly, where's this border defined, then click on define view, see where this thing is available in my source code. So it's very powerful in that sense. Now let's keep building this application up. I'm going to add some more of the code that I wrote before. So I'm going to add another piece here, which is a text block. And think about this, my app has been running the whole time. I am not having to switch around. So as soon as I added another one, let's in fact collapse this. This is where collapsing is useful. As I'm switching, it's working, right? It's displaying the content of the email. Now behind the scenes, this is just all in MVVM. I've got bindings happening, and the bindings are, here, let's lower this so I can show you. We've got bindings to an emails collection, observable collection of email objects, and we have a selected item binding two-way to the selected item, and then we have the text block binding to the selected item.body, everything just works, and you can go ahead and say title, so you can really change this in real time. Body works. If you misspell something, it's just not going to work until you fix it, but you're getting errors inside of your output. So if you're watching that, you can see if you're just have spelling errors that are coming in there. All right, so there you go. The application is being built up, but that's not all this thing can do. Let's go a little bit deeper. I'm going to go back to my cut and paste window here and put in a status bar into this application. So right now, no status bar. If we were building a real client, we'd have a status bar. So I'm going to add the status bar in. And now we have a status bar. It says connected, works great. But in reality, a lot of the way that you would compose a real WPF or UWP application is by using controls to move some of the logic out. So in this case, I want to move my status bar into a control. Now, I've cheated a little bit. I've already put a control in here. So I have the status bar placeholder. If you didn't have this, you would have to stop right now and go ahead and make that happen. So in here, I will select this, and I will say, well, I'm gonna cut this out because I don't need that. And I am gonna first add a reference to the control. So all these, normal XAML things, MLNSS. Oh, I did this before. I should have cleaned it out, but it's okay. We'll do it again, just because I want to show that everything you basically need to do is really available in real time. So here I am, and I'm typing control, and I'm getting IntelliSense. IntelliSense showing me this is probably the control that I want to highlight, so I'm doing that. And as I go down, I can now put the control in here. So I'm going to go down here, and I'm going to say control. There's the control. I'm going to put its grid row, grid column span, close that out. And right now, it looks a little bit messed up because now my status bar lost the grid row and column span. So I'm going to remove it. I'm going to go and I'm going to open up the control. I'm going to paste it in there, and everything is back to normal. Very powerful. You can literally be sitting here building your app, especially if you, again, get your view model and everything working correctly. So let's dive a little bit deeper on the tools that are available, because this isn't everything. So let's say I want to play around with the status bar, but now I'm shifting scenarios a little bit. I want to make changes that I don't want to commit. Right now, hard reload is all about you're changing XAML, and as long as you don't delete the XAML you changed, don't undo the XAML you've changed, it's going to wind up in your application sooner or later. Now, what if you want to just really try something crazy or experimental, and you just want to focus on the session that you're working in now? So we have a tool for you as well, and I want to explain one confusion that I've heard customers say. They're like, well, there's already a properties panel. Wouldn't they use a properties panel to change properties? You would if you want them to be committed to the source code. But if you just want to play with the application as it's running and just have it be temporary, we have another tool for you. Let me go ahead and show that right now. So I'm going to select the status bar control. I'm going to open it up, and I'm going to go to the status item. In fact, I'm going to go all the way down to the text block inside of it, the one that says connected. And I'm going to click this button right here called Show Properties. Now, this will show something called the Live Property Explorer. This is another window. It's not the Properties window. It's the Live Properties window. So it's the one that lets you make changes that are temporary. So let's go ahead and make some temporary changes just for fun. First of all, I don't know if connected is the word I want to say, because I'm like, well, connected works about connected live, right? Will that work? Will that sort of fit? So hit enter. Okay, yeah, that's fitting. The status bar is not breaking. Okay, that's good. I actually want to change font, so I'm going to go in here, and I'm going to say font size. What if the font was 24? Oh, that's not going to work. Font 24 is definitely going to be too much. How about font 18? Still cuts off a little bit, right? Not really great. It's 14. 14. Oh, 14 looked good. So now I know which font I want to make. So I'm going to go in here, and I'm going to say font size 14. So this enables you to play with the application in a way that you can kind of go crazy, and then you can reset everything back to the default values, or if you just stop debugging, it will reset itself. So it's very much safe to go ahead in there and make lots of changes that you want to try. So this is hard reload. I've gone through and I've built like a little application that sort of feels like a real application, right? We've got everything working, and we can see clearly what our tree looks like. So some of the other features that I want to point out that might not be familiar to everybody is some of the work we've done. So I'm going to minimize the app because I want to focus on the XAML window right now. So some of the work we've done in the XAML itself. One of the things that you might want to get help on, because it's not clear where something is, for example, static resources like listbox email style. Where is the listbox email style located? I'm not sure where the XAML is. If you right-click on it and you say peak definition, you can actually look at the definition and you can see the file that it's in. And it's one of these temporary files that you can pin up. It's just like peak definition in other languages, and that works. It works in a lot of places. Give it a try. If it's not working somewhere for you, let me know. If there's a scenario we didn't think of, we'd love to hear from you, but that's a cool feature. You can also right-click and say, or use F12, you can say go to definition, so you can actually just jump straight to the file and make changes there. So if I wanted to go in here, and I wanted to make the fonts even bigger, there you go, the font became even bigger. Again, hard reload is still working as we're doing all of these things. Another feature that I've talked to people, they're not familiar, we have it, but it's actually really useful for really complicated applications that might have, like, let's say, a lot of resources at the top and you want to look at something, we're looking at XAML at the bottom. We have the splitter right here. If you drag the splitter, just like in other places, you can stay at the top in the top one, you can scroll down to the bottom one, and you can make changes, cut and paste values, things like that. Very useful feature, and definitely worth knowing all of these little tips and tricks to make it easier for you to build your XAML application. So I'm going to go ahead and actually move this back up so that works, and now it's back into being one single window. All right, let me make sure that I've shown you everything that I wanted to. All right, I think I did in this case. So let's look at one more feature here. So I'm going to stop debugging. This is a feature that's available, and it's best to look at it when your application gets a bit more complicated. That's why I kind of kept it today. And this is a document outline, really undervalued window in the XAML tool space. We're in fact thinking of maybe doing more with this in the future. We'll see how that goes. But basically, this window enables you to see all the controls that you've written inside of your application, and you can go ahead and look at the designer, and you can make things visible or hidden, so it has that ability. In my case, I don't have much to show in that sense, but you get the idea. So these are temporary changes that don't apply to your running app. It's design time properties that you're changing. You can also right-click on a control in here, and you can edit a style and create a copy, just like we saw. You can click on View Source, and it'll select where in the source this is. So think about document outline as the control that you can use when you're using the designer and the XAML editor, the app is not running. And then when you switch to hot reload, as your app is running, that's where the live visual tree, the LVT as we call it, is available for you and lets you do everything you need to do there. All right. I also want to point out a couple of things. Like we're constantly making this better. So I'll give you some examples. There was a deadlock error, like we messed up. We had an error where if you said in WPF application, go to definition, we actually froze Visual Studio. Really sorry about that. We did not mean to do that. We fixed it. It's in one of the recent updates. There was also a bug where as you're typing IntelliSense, for example, in the code editor, you would get static resources for, let's say, a list view. And we would, in theory, only show you the styles that apply to target of type list view. But we had a bug where we're showing everything. So things like that are being fixed. We're not making a lot of noise about it, but we know these are behaviors nobody wanted to have. And if you find behaviors that you're like, why is this working? Kind of strange, let us know. We could miss something too, but we really want to make it better. So these are investments that are going in for WPF and UWP developers. We're doing everything for every type of customer that we have. All right, in the last couple of minutes, I want to show you one more demo. So one thing I will point out is that we're switching gears quite a bit here, but it's really worth knowing about. So I'm going to switch over. So these are just the hot reload docs I had open just to demonstrate, like we have hot reload documentation. That's where the link goes if you click on the link. But let's switch to another doc completely to XAML Islands. XAML Islands is a technology that's been being worked on for a while. It's a technology that enables you as a WPF or WinForm developer to host UWP controls inside of your application. So let's jump back into my slides for just a couple of minutes here. And just in the interest of time, I'm going to go quickly through it and just explain that, XAML Islands, think about it as if you think about UWP as a whole, there's a lot to it. There's an app model, there's MSAX, there's all of these things. But one of the biggest parts of it is the controls. And if you want the controls in your application, XAML Islands is the way we've enabled. This just wasn't possible without XAML Islands. The work that my team is doing for a future release, probably sometime in the 16.4 timeframe, is we're making it so that implementing XAML Islands will not require you to do manual steps. Today, there's some manual steps that you would need to do. We're making it so you don't need to do manual steps. And the way XAML Islands work today is requires 1903 version of Windows. They are looking to backport XAML Islands to older versions of Windows, but for now that's the thing. And it allows you to host inside of a C++ app, Win32 app, a WinForms or WPF application, and then you host your controls in there. And there's all these wrappers that we've built. I would say just look at the documentation. That's the best place to get all the information, but there's lots of wrapper controls that the team's built. It's open source, and it's pretty easy to implement. It's kind of basic. There's not a lot of tooling support. It doesn't give you all the niceness of how to reload designers, but it does work in your application. So if you're blocked, this would unblock you. And just a quick demo of what that can look like, I will show you something that's super simple. This application literally has 3 list boxes, but it's very significant. The first list box on the very left is the one that comes with WPF. This is a WPF core app with a WPF list box. Nothing to see here. This next one is XAML Island. It's a natively used. I'm doing data binding using C#, so I'm doing it in C# just to kind of demonstrate that that's possible. And then we have a third one which I've styled, so it's even possible to style it as well because I'm hosting it in a custom control, so I have full control over style, look, and feel. And I'll have the sample available as part of the links. So that's kind of my demo. All of this is here for you. I wish I had more time, and I'll be back on. We have community stand-ups and other things we're doing via Toolbox to talk more about this. And thank you so much for joining me. If you have questions, please tweet at me or email me. Thanks a lot.
All right, awesome. Thank you so much, Dimitri. So we have a couple of questions. Let's start with this one. So JDK wants to thank you for using the dark theme for your demo.
Dark theme, huh?
I like the dark theme. Good.
His eyes can't take any more of the white background, so thanks, Dimitri. Yeah. Let's see, what else do we have? Matthew says, the changes to XAML Designer that I'm seeing right now give me hope for a normal sleep cycle in the future.
Oh, hey.
Yeah.
We're trying. It's a goal of ours, and we have some really interesting things planned for the XAML Designer. If you're interested to have conversations with us, again, tweet at me or email me. I'm dimitri.lilen@microsoft.com. I'll make sure my email is available easily for everybody.
So here's a question that I have. Is it pronounced XAML, XAML, or XAML?
Seth, we've talked about this.
Yeah.
It's XAML.
Okay. Are you sure, though?
It's XAML.
Okay, XAML.
XAML.
All right, so as we go, we are almost done with this part of it. We have one more session, but before that, I want to let you know that you need to participate in the technical treasure hunt. And that's the important bit. You can do that all day today. There's going to be more stuff going on. But before we go to the next session, which is Secure Your NuGet Package Ecosystem with Karan Nandwani, did I say that right?
Yes, it is.
We have something to show you. Let's take a look at it.
Hey there, treasure hunters. I've got your next clue in the hunt. And this one's from the folks at Contrast Security. They want to know, at this URL, which one of the code snippets contains a security vulnerability? Do your best investigation, take a look, let us know. Whisper your response in the form of code and a letter, one of the letters that corresponds to that code snippet that does contain the security vulnerability. Whisper that to the .NET bot in the Visual Studio chat room on Twitch, and you could be well on your way to the next step in our technical treasure hunt.
Hi, I'm Cam Soper, a content developer working on .NET Docs here at Microsoft. Welcome back to Entity Framework Core 101. In our previous video, I showed you how easy it is to use Entity Framework Core to create and work with a new database. In this video, we're going to show you how to use Entity Framework Core to work with an existing database by reverse engineering it. Looking at Visual Studio, I have a brand new console app that doesn't have any code added to it at all. I've already added the NuGet packages, same as we do with a new database, Microsoft.entityframeworkcore.sqlserver.design, and .tools. I have an existing database. This database is already populated and was built by hand by a database administrator. To reverse engineer the database and create my entity model code, I'm going to use the scaffold db context commandlet. I'm going to pass in the connection string. I'm going to pass in the name of the provider so it knows what type of database to execute that connection string on. And then I'm going to optionally specify an output directory and a name for the database context. Now that the scaffold is run, we have a complete working entity model. Looking at the products entity, it should look pretty similar to the one we created in the last video. One difference you'll note, however, is there's no data annotations describing the behavior of these properties. For example, which one might be required or might be a key. That's because these behaviors are contained in the onModelCreating method of the database context. If we'd like to create an entity model that looks more like the one we created in the previous video, we can do that too. I'll start by deleting this entity model. And I'll run the scaffold db context command again, but this time I'll add the data annotations flag. This time, the products entity has data attributes that describe the behavior of the properties, such as the key and required. And the onModelCreating method in the database context is much more sparse. Now that we've seen how Entity Framework Core can work with an existing database, in the next video, I'm going to show you how to use Entity Framework Core with ASP.NET Core to streamline your web development.
Hey everyone, welcome to .NET Conf. My name is Karan Nandwani. I'm a PM on the NuGet team. Today we'll be looking at how you can secure your NuGet package ecosystem. In the recent past, there has been an increase in the number of supply chain attacks, and they have made the news. We have seen that there has been a propensity for using package managers as the mode of attack for some of these things. Today, let's recap some of these incidents and see what we can learn from them. So Homebrew is a package manager that you can use to install software on Linux and Mac OS. And there are many use cases here, such as setting up a dev box really quick with the essential tools that a new developer might need. Now, in this case, sometime last year, a security researcher was able to get access to the core Homebrew repositories. They had commit access to these repositories, which means they could have made a change, and that change would have flown to anybody that ran Homebrew update or recently installed Homebrew, and they would have gotten their malicious formulae. Now, the takeaway really here is that there was no way for the end user to protect themselves. So really what we are asking is the tools that package managers should be able to detect if a package has been tampered and block installing such packages. In addition, there should be a way for package authors to stamp their identity on a package, and on the other end, for a package consumer to be able to validate this identity and confirm that this package truly came from who it says it came from. In a separate incident last year with NPM, the NPM account of the maintainer of a really popular package was compromised. The attacker went on to publish a malicious update that got into 4,500 accounts and got the credentials before it was taken down. Now, we should understand that this was not a fault on the NPM.js side. The attacker was able to get the password and username for the maintainer from a third-party leak and was able to reuse it to gain access to the maintainer's NPM.js account. So the clear takeaway here is that username and password security is simply not enough. In a separate incident, an attacker uses a different vector to target package users. They published several packages that looked very similar to a very, very popular package which has over 2.5 million weekly downloads. They then went on to these were all malicious packages that harvested environment variables from the victim's machine, and this attack went unnoticed for nearly 2 weeks. So the key takeaway here is that popular repositories should be able to detect and block typo squatting attempts. In addition, there should be a way for users to define which publishers they really trust,
And if a package does not meet that specification, it should fail to install. Now, let's take a quick look at what does a typical NuGet workflow looks like and what are some of the best practices. So let's say I have an awesome library that I want to share with the world. And the obvious next step there would be to create a NuGet package. The first best practice here would be to author sign it. Now, author signing it allows me to stamp my identity on the package. And on the consumption side, it allows the consumer to validate that this package really came from me. Next, I want to publish this package to, let's say, NuGet.org. Last year, NuGet.org adopted MSA-based authentication, which allows users to opt into 2FA. Now, setting up 2FA is really easy. It is literally 3 steps after you log into NuGet.org. Now, if you are an enterprise customer that uses Azure Active Directory to log in, you can ask your admin to enable 2FA, and it's just that easy. And as we have seen, enabling 2FA would have prevented several of these attacks that we looked at. The next step here really is to publish this package to NuGet.org. Now, when a package is being pushed to NuGet.org, we actively check if this package ID looks very similar to an existing package. And if it does, we block it from publishing at that point itself. After it passes that and it does not look similar to an existing package, it undergoes several checks to see, including virus scanning, to ensure that this package is safe for consumption. Once it passes these checks, NuGet.org then signs it with its own repository signing cert. This way, you can be guaranteed that this package is truly coming from NuGet.org, even if you are using it through, let's say, ADO, using an upstream source, or this package are rehosted on an internal feed, etc. Now, let's look. This was the publishing side of things. Let's see what we can do when you're consuming these packages. So to begin, we have something called as client trust policies. This allows a package consumer to define policies that say, I want to trust a package that has been authored by a certain author, or I only want to trust packages that come from a specific feed, let's say NuGet.org. And you can get more specific by saying only by these specific users or accounts. Let's take a look at a quick demo of how you can do this in your day-to-day flow. So I have a solution that is NuGet Cleaner. I've been working on this side project for a while now, along with the new PM on the team. And I want to implement client trust policies. The first thing that I did here was add a new NuGet.config file. And this file is at the solution level. This is necessary to isolate the settings that I want to apply to this solution from the other solutions that I might have on my machine. So the first thing I really want to do here is start using, start validating signatures when the package is being installed. The way you would do that is by setting the signature validation mode to require. What this does is every time you install a NuGet package to any project in the solution, it will check that the package has a valid signature. Now, this happens at the time of installation, which means when the package is being extracted, it checks for this signature, and then that point onwards, that package is assumed to be safe. Hence, it is a best practice to add a new global packages folder, which is exclusive for the trusted packages that you want to use with this solution. The way you can do that is simply by adding a new key called global packages folder and defining that folder. Now, let me quickly close the solution and reopen it so that the new config can take effect. All right, so let's try to install some NuGet packages into this project. I'm going to try to install newtonsort.json. And what do we have here? The package failed to install, although it has a valid signature. The reason for that is, although we said we want to validate packages on installation, but we did not really specify what packages or sources we trust. So the next thing to do here is define NuGet.org as a trusted package source. The way you can do that is using the NuGet trusted signers command, and you can say add a new trusted signer and say NuGet.org. And what this does is it will go out to NuGet.org, figure out what is the right fingerprint for the packages that are signed by NuGet.org, and insert it in your config file. So I'm going to once again reload my solution for the settings to take effect, and let's try to install that package again. And as expected, this package now successfully gets installed. But what if you told me that I want to have more fine-grained control over the kind which users on or which package owners on NuGet.org I trust? You can easily do that by specifying owners. And in this case, I'm going to say I trust James NK, and I trust any package that is published by Microsoft. Awesome. So let's reload our solution again. And we're going to try to install a bunch of more packages. So I already installed Newton's or JSON. I'm going to try to install this one from Microsoft. It should, it tells me license acceptance, goes through perfect. Now, what if I try to install a package which was, say, something like this, castle.core. And as expected, it did not get installed because although it has a valid signature, it is not in our list of trusted signers. So to summarize, client trust policies guarantees you package authenticity and integrity. That is, you're guaranteed that this package truly comes from who it says it comes from, and that the package has not been tampered with after it was created or published to NuGet.org. Now, in addition to client trust policies, you can also use log file. What log files do is they store the hash of the package content. And when a package is being restored, it validates this content hash against the package which is being restored. If the content hash does not match, it fails the restore and ensures that a package does not, a bad package does not find its way into your NuGet dependency chain. And to close the loop here, we have hosted a first-class and highly available symbol server on NuGet.org. This allows package owners to publish symbols using the new snupcake format. The new snupcake format uses a secure portable PDB for symbols. This also allows you to and securely debug your NuGet packages. And to make things easier, NuGet.org symbol server is listed as one of the default sources in Visual Studio. The added security here is that the DLLs in the NuGet have a checksum for the PDBs, which means that when you're debugging, the Visual Studio debugger will actually validate that this checksum matches and provides for a secure debugging experience. Now, let's take a sneak peek at what we have coming up in the next few releases. We will be integrating with GitHub token scanning service. What this means is if you inadvertently checked in one of your NuGet.org API keys, within seconds we will be able to detect that and delete that API and disable that API key and also notify you. This will minimize the potential for malicious use of anything any API key that you might have leaked. Also, we are working on a new feature that helps you identify and flag vulnerable packages anywhere in your dependency graph. This includes any packages that this includes your transitive dependencies as well. And this will allow you to proactively update your dependencies to the ones that do not have these vulnerabilities and ship more secure code and applications to your customers. So for anything that we looked at today, you want to know more, go to akms/secure NuGet, and we have links for everything there. That's all we have from the NuGet perspective. Thank you very much.
All right. I'm excited to be here, Mika.
Me too.
So we have just come into Frame because I was singing like some Spice Girl
you were
stuff
too busy.
over there.
Yeah.
And they're like, hey, Seth, the director's like,
Stop
you
singing.
need to go in there right now.
Right now, yeah.
Because you know you're not a very good singer when it comes to the Spice Girls, number one. And number two, you're kind of working and you're like,
You're on the
Seth,
clock.
let's get in there.
Yeah.
Maybe do something.
Yeah.
All right, so what do we got here for a new post? Looks like we are done for today. Thank you so much for that.
Yeah,
That was
thank
awesome.
you.
The cool thing about NuGet, that I like is that it allows you to share code, but that's also the bad thing about NuGet. So it's good to have all of this infrastructure to make it a little safe. Do we got anything else in there?
Yeah, Ryan actually is talking about securing NuGet packages at Build. Super pumped about this session.
Oh, so fantastic. So
yeah.
securing NuGet, like I said, the cool thing about NuGet is that you can share stuff, but that's also a bad thing about NuGet. Okay, so look, we are done in Studio A for today.
Yes.
Is that right?
Yes, we are.
Okay,
Yeah.
so what we're gonna do is we're going to now toss it over to Studio C.
Yeah.
So you can still ask questions on the .NET Conf hashtag, but I'm probably gonna go home and have
Take
a
a
dinner
nap.
and then maybe go to sleep
Yeah.
or something.
Yeah.
Take a nap, sing some more Spice Girls. What we're gonna do is we're gonna have Jeff come in here because right now, come on over, dude. As he's coming, we're gonna toss over to them. You had the party last night too, right? The after thing?
We had the after party last night.
Okay.
Yeah.
Okay.
The after party.
Okay. And so were you wearing that?
No.
Okay,
not that time.
so now this time we're gonna have an extra party. So looks like you're muted right there. So why don't you talk into the small of my chest here?
Hi, Seth. It's so good to see you.
How
I'm
are
gonna
you,
flip
buddy?
this over so that I'm not muted.
Now he's on.
Am I on? Can you hear me now?
Yeah, no, you were on before, but not with the mic.
I see.
Yeah.
We're professionals.
So let's go show them where Studio C is.
Let's go for a
Let's
walk.
go, Mika. Let's
All
go
right,
show
yeah,
'em.
let's
So
do
what we're
it.
gonna do is we're gonna go out here. I'll open the door for you because no one ever gets to see Channel 9 Studio the way I do. So
No.
this is Channel
Oh my
9
goodness.
Studio. Yeah.
I was off.
So let's come over here. Wait, come here. I want you to meet someone. Come here.
Closer.
This is Beth Massey. She is the one that did all of the work. We just stand around and look pretty. Here, look, speaking to this right here. Tell.
I love you all. Thank you so much. We had such a great
And
event.
we adjusted the mic so that she could literally talk right into it. Right? Do you see this? This was all planned by our wonderful studio people. So we're going to have you back up here. Let's come over here.
Let's go for a walk.
Let me show you all the buttons that they push. I'm going to try to push some buttons, and if anything happens, just let me know. This is where all the buttons happen, right? This is the director. Here, Cameron, Cam. Golnaz tells us what to do, and we do it mostly out of fear. So there is that. And so these buttons, she says never to push, okay? This means that we're recording it, right? Come over here. So that way, at the end of 24 hours, all of this stuff, all of the hot little bits are going to be in your hands as well. So should we go back to Studio C?
Let's take a walk.
All right, come on, let's come
I think
this
it's
way.
about time.
Let's come this way here. So you don't want to turn your back because that's awkward for them.
No. I
So
got to
come on
cross
here.
over.
So this is Studio C. Obviously, it says warning. Anything in this room can be live streamed. So we're going to go in here. So let's open it up.
Here we go.
Okay.
Hello.
Fantastic.
Oh
And
my goodness.
This is now where the magic's going to happen afterwards. So why don't you come in here? Here.
Join us.
Very good.
Oh my gosh. So we're about to go live 24 hours straight on Twitch, twitch.tv/Visual Studio. If you're out there, if you're watching on Twitch, click that follow button. You want to follow along. You want to know what's happening because we've got lots more content after .NET Conf for you, but we've got our crack team of hosts all throughout the day. You're going to see a bunch of folks hosting, showing content throughout the day. Every time zone.
So they are telling me to rap in my ear because I have a special earpiece that makes me get into really special places all the time. It's really fantastic. So we're going to wrap it up here with the .NET Conf from Studio A. Oh, they tell me to keep talking. So Javier here is the other mastermind that you may not hear. Let me scoop down so you can talk into. He does all of the website stuff, and he brought up a beautiful dashboard.
You're welcome.
Hold on, let me get closer. Thank you.
So here's how technical we are.
Look at
I have
this.
double keyboards.
2 keyboards.
Because I have to.
This is a
use
2 keyboard show.
It is. It's great, and there's more buttons.
Look at all these buttons.
There's buttons.
Don't push this one. No, they told us that this will cause issues.
It is not good.
There's literally an X there that says don't push it.
But I kind of want to push it.
All right, no. So before we go, we'd like to say thank you for those that were with us in Studio A. We're going to turn it over to Studio C after a short little break, but go to twitch.tv/Visual Studio to continue all of the joy and the fun. Make sure you tune in. See you there. Hit the button.